Hi guys, a very good morning everyone. Welcome to the revision marathon beginning. Yes guys, this is BYJU'S exam prep ECEECS YouTube channel. The marathon, the last lap for GATE 2024 has now started, and as you know, as promised, okay, the BYJU'S exam prep always will be standing with the students to support in their revision plan. Of course, we have stood up entire year also, but this is a very crucial time to capitalize, because if you don't revise, if you don't capitalize on your preparation, okay, maybe you don't get the best possible results. Okay, so it's very important to go through all important concepts, formula, and etc. Right. So yeah, so to boost up your preparation, to assist you in the complete revision, okay, I'll be, and not only be, the entire team of ECEE, we are taking up different subjects on different days. Okay, so this is the beginning of the revision marathon. So how many of you are ready with the full josh? It's a cool morning. Sorry for a slight delay. We got the session pushed to 10:15 a.m. It was at 10 a.m. but no problem. I got stuck in some traffic, but then eventually now all okay and all sorted. All ready guys? So now come on, everybody. Okay, chalo ji, come on, show your readiness with full josh. Okay, and let's start by hitting the like button. Do not forget to like it. Let's start with the putting your attendance, and your attendance is just one like. Okay, so that I see how many of you are really attentive. Okay, not just watching but really attentive, right? Chalo. Prabhat, yes, why not? Just one extra effort you need. I'll tell you that. Chalo. So this is a regular introduction about me that you must be knowing. Let's move forward. So guys, this is what the revision marathon we are starting today, to ensure that you cover every subject in one shot. Okay, to ensure that you cover every subject in one shot. Okay, and this starts today. That is 8th of January. That is the Monday. Okay, just a second guys. एक घंटे से लाना, ठीक है? 1 घंटे बाद, हाँ, ठीक है, जैसे अभी हो रहा है, लगभग 11:15 साढ़े 11 एक को भी लानी। Okay. Yes, Nishu. So guys, the today's subject, okay, that is the digital electronics that I was telling you. Okay, of course, this subject is for ECEE computer science instrumentation also, right? Chalo. Yes, Vikram. Okay, for instrumentation also, and schedule ki agar baat kare. Okay, so have a look into the schedule for ECEE, guys. Okay, whatever I have fit in the one slide. So today you are having the digital electronics. Tomorrow you will be having the analog circuits by Sanjay Rathi sir. Okay, so analog will be taken tomorrow same time by Sanjay Rathi sir. Okay, then once again I shall coming up. Okay. Once again, I shall be coming up on Wednesday. You will see me again with control system revision. Okay, and then Ishan sir will be bringing network theory. Sakit sir will be bringing communication system. Again, Ishan sir bringing power system, and etc. Very good morning, I. Okay, yes. The watching is to like ratio is not that great now. Okay, so that like shows how much attentive you are. Okay, so show your attentiveness so that I can start with the blaster energy. And now guys, I told you in the day before yesterday session also, guys, every subject we are also going to have a daily free live quiz. Okay, a free daily quiz associated with every subject. Now at the beginning, let me tell you, okay, in this we are going to revise the subject entirely. Okay, depends on topic, either in the form of formula, either in the form of questions. Okay, now if you really want to score good and you have not done anything much yet, what you can do is watch this entire revision marathon in one shot. And since it is the last 1 month, okay, I know you cannot practice a lot, I know that, to be honest. Okay, so how you have to balance your preparation? Okay, if you really want to utilize this marathon, okay, daily class. Okay, number 1, okay, follow the daily class. Okay, number 2, daily quiz. Okay, it's a 1-hour quiz. And this is available on the app. How will you join the quiz? Where is the link of the quiz? I'm going to tell you that. Okay, I'm going to tell you that. Where is the link of the quiz? How do you join the quiz? Okay, so daily class. Okay, and based on that, the daily quiz, that quiz is also for the entire subject, and that is with respect to solutions. Solutions will also be there. And then if you say you need to discuss the quiz live, I'll come live also to discuss. Okay, take care. And then number third, in case you have not done PYQs, ek PYQs ka tarka. That's what I'm telling you. Last month you may not go for a lot of practice from this book or that book, but at least PYQ, at least 10 years, at least 10 years. Okay, at least past 10 years. If you do this much, na dear. Okay, maybe you have not prepared a lot till now, but even if you follow this daily class, attempt a daily quiz and PYQs, at least 10 years. Zyada karoge to better hai, but at least 10 years PYQs of GATE. Okay, I think you'll be scoring a decent number in the GATE exam. Okay, you will be scoring decent number. Now, how good, that depends on whatever you have done in past. Okay, but even if somebody not done anything great till now, still you can score decent if you really honestly do this, honestly. Okay, not just writing on a piece of paper, but actually implementing it. Okay. Chalo, so this is what, how to join the quiz. Where is the quiz of today? What time it starts? I'm going to tell you that. Okay. Now guys, in case some of you are, confused about GATE exam, kar rahe, Gaurav, leave it to me. I'll start. Okay. So, and if you're by chance looking for one-to-one counseling regarding any of your doubts with respect to GATE examination, okay. So, or maybe your juniors or your younger brother, sister, anybody looking for any sort of complete counseling with respect to GATE exam. So you can guys, like, this is the today's video. You go to the description of this video. Okay. You go to the description of the video. Okay. And there will be a statement written. Okay. For guidance, get in touch. Okay, maybe यहाँ पे थोड़ा सा blur होगा, but you can look. There will be a statement. Register now. You can directly go to the description. You can click the link in the description. Okay, and you can book your counseling session free of cost, 1-to-1. Okay, with the counselors. Okay, with the expert video session you can book with the counselor and get yourself very comfortable with the GATE exam, with the ESE exam. Yeah, any doubts, even if you have the last 1 month of preparation, any sort of counseling you're looking for. Okay, you can get it directly by booking your free session. Okay, and how to book the session? The link is there in the description. Just go to the description of this video. The link is there and you can join. And now very, very good morning. Once again, a warm welcome from my side to all the GATE champions. And now, okay, let's get moving ahead. So guys, do not forget at least this. Okay, if you really want to score good, okay, okay, do not forget here. Okay, do not forget to follow this. Okay, if you follow, okay, you'll be getting good results. Chalte. Okay, so now let's get started with Boolean theorems. Let's start with the revision of Boolean theorems. Very, very fundamental Boolean theorems. Okay, marathon PDF, I will tell you. I'll give you the PDF also, don't worry. And I'll try to give you today itself, today or maximum tomorrow. I'll ensure that, because marathon PDFs are important. Okay, so I'll try to give you by night only. Okay, so dekho, there are some Boolean theorems which are very basic, single variable. Okay, single variable. Okay, say for example, x plus 0. These are identities. X plus 0 equal to x, x into 1 equal to x. Achha, identity, you must almost know what is the meaning of identity operation. Okay, whether it is in the form of addition or multiplication. Okay, identity variable is something which when applied with x returns the same value x. Okay, like x into 1 is x, yeah, in the form of addition. For multiplication, what is the identity? 1. For addition operation, what is the identity variable? It will be 0. X plus 0 equal to x. I just want to discuss you. Yesterday in the ISRO examination, okay, okay, there was a question, what is the identity for convolution? Just 1 second, I'll discuss and then we'll continue. Okay, in the ISRO examination yesterday, there was a question, what is the identity for convolution? Okay, so when you convolute any signal with what signal? You get back the same signal. It is the impulse, na? xt convolution del t is xt. xt convolution del t is xt, right? Okay, so that was one direct question in ISRO. What is the identity variable, identity function, okay, for convolution? So it's delta. X convolution delta is back x. Convolution of a signal with unit impulse replicates the signal. Okay? Correct. Okay. X into 0. Oh, I think that's a typo error. Okay, we'll keep looking into it. Okay, yes, Nishu. Okay, so that is what identity means. Now, so similarly, now let's come back to the Boolean world. X plus 0 returns x, x into 1 return x. Okay, x plus 1. Now in Boolean, 1 plus x is always 1. Okay, because it's the Boolean world, 1 or 0. Okay, plus means parallel switches. If any one of the switches on, the result is on. Whether it is 1 plus 0 or 1 plus 1, both are equal to 1. Okay, x into 0, of course, is 0. Okay, x plus x is x. There is no 2x. It's Boolean. X into x is also equal to x. Okay, now x complement. When you take the double complement, complement cancels, and x complement equal to x. Okay, x plus x bar. A variable and its complement are always in the different state. So that means either it is 1 plus 0 or either it is 0 plus 1. Okay, so both of them are equal to 1. Okay, and x into x bar, any one of them is 0, na? So 0 into anything will be 0. Now if you have noticed, always remember, there is a duality. There is a duality. Okay, here, okay, look into these two results which are known as identities. Okay, what is the difference in these two results? Okay, here we have plus, here we have dot. Here we have 0, here we have plus. There is always a duality principle that exists in the Boolean theorem. You should remember it always. And what does that duality says? That in any Boolean theorem, okay, suppose, let me hide this. मैं इसको छुपा देता हूँ. Okay, I'll hide this side. Okay, in any Boolean theorem, if you replace plus by dot and 0 by 1, the Boolean theorem remains unchanged. मतलब the Boolean theorem still remains true. Okay, right. So let me do it here. I have hidden it. Okay, replace what? Replace plus by dot, yeah, dot by plus. Replace the operator. So this becomes plus replaced by dot. Okay, also replace the 0 and 1. Wherever there is 0, replace 1. X into 1 equal to x. Oh my god, is the same thing written here? Yes, the same thing is written here. Okay, not only this one. Take any other thing. Say for example here, take the last one. X plus to be replaced by dot. Okay. Equal to 1 to be replaced by 0. 1 and 0 replace hoga, plus or dot exchange hoga. Same thing is written there. Okay, same thing is written there. Hope you have understood. That is what is known as duality. Okay, now coming to two variable theorem, multivariable, 2 or 3 it could be. Okay, so commutative. Okay, x plus y or y plus x is same even in the operation of and also x into y is y into x. Okay, x plus y plus z. Associative. What is associative? Okay, if you are adding 3 variables, you can add any two first. X plus y plus z, yeah, x plus y plus z, yeah, maybe x plus z also can be done first. Same thing applies on y. You are multiplying 3, you can multiply any two first. X into y into z, yeah, x into y into z, yeah, again x into z into y, wo bhi same hoga. Okay, now distributive x into y plus x into z, x can be taken common and distributed separately to y and z. So here I have taken x common, then y plus z. Okay, now this distributive theorem, okay, in the multiplication form, no, this is normally applicable in the real world also, but this is only Boolean world. Okay, x plus y, x plus z. See, आप इसको ऐसे याद रख लीजिए ना. Okay, apply the dual. Okay, what is the dual? X into y will become x plus y, correct? X into y should become x plus y. Plus will become into x into z. Into will become plus. Okay, so this should be how much? X into will become plus. Y plus z will become y into z. ये लिखा है आपके सामने. That is the next theorem. Clear? So that is what distributive theorem in terms of in a multiplication operator. X plus y into x plus z is x plus y z. Now from here, dear, there is one theorem which commonly comes up in the question. See, questions of Boolean theorem are actually very easy. Sometimes they come, okay, and they become very easy for you. Okay, but यहाँ से एक बहुत common parameter आता है. Suppose it is x plus y. ठीक है, यहाँ इसको reverse लिख देते हैं. Let me start from there. You have x plus yz na? Suppose you have x plus x bar y. Rather than yz, let me take x plus x bar y. So x plus yz is x plus y, x plus z. ऐसे distribute करोगे. So what should be x plus x bar y? X plus x bar, x plus y. But dear, what is x plus x bar is 1. 1 into x plus y will be 1. So I can write it like this, that x plus x bar y. I can write it like this. X plus x bar y is simply x plus y. X plus x bar y is simply x plus y. This one is important. जो ज़्यादा important है वो highlight करूँगा. Okay, this is really important because you know lots of questions this is going to be used. X plus x bar y is x plus y. ठीक है. So now come here. X plus x y, basically x if you take common 1 plus y will be 1. So you are left with x. इसी का dual ले लेंगे तो x into x plus y. X into x plus y also equal to x. Okay. Now what is next important is De Morgan's. Okay. और एक ये वाला भी थोड़ा important है. Okay. De Morgan's. ठीक है. De Morgan's. x plus y whole bar is x bar y bar. Okay, the complement of whole addition is equal to the multiplication of individual complement. Similarly, x into y whole bar, the complement of multiplication is equal to addition of individual complement. It is x bar plus y bar. ये तो होगा two variable पे. Okay, it can be applied to multiple variable also. x1 plus x2 etc up to xn whole bar. Addition का whole bar. It is multiplication of individual bar, x1 bar plus x2 bar etc. Similarly for the next one. But actually when you are going to calculate the complement of any function, okay, so suppose if I tell you there is any function given to you, suppose that is a plus b bar c, okay, a plus b bar c, okay, a plus b bar c plus a bar d, some नहीं, a bar d नहीं रखते हैं, look into this. A plus b bar b, okay, plus c bar d is how much? Okay, is how much? Now this is f. So what is f complement? I actually want f complement. What is f complement? Now guys, you can apply 1 by 1 De Morgan's law. But rather than applying the 1 by 1 De Morgan's law, what you can directly do? Okay, first calculate the dual of the function. Now what do we mean by dual? One step में करेंगे. Okay, dual means plus will be replaced by dot. Okay, plus will be replaced by dot. Okay, and then complement every variable. Okay, so first of all, a will be written as a bar. Listen to me, a will be written as a bar. I am trying to calculate f bar. Okay, plus will be written as into. B bar will be written as b. B bar into c है, तो I will write into c की जगह plus आएगा and c will become c bar. Again plus will become into, and then you have c bar into d. C bar will be written as c. Into will be written as plus. D will be written as d bar. That is the f complement. Okay. Yes, dual and then complement, but better apply in one single step rather than taking two different steps. Na? Apply it in one single step. Okay. Replace the plus by dot. Okay, and complement every variable. तो a की जगह a bar, b bar की जगह b, c की जगह c bar, c bar की जगह c, d की जगह d bar. Okay, and instead of plus you have dot. Here it is into b bar into c. तो ये plus हो गया, ये plus हो गया. This was plus, this becomes dot. Clear everybody? This is the direct way of taking the complement. Lots of places you will be required to calculate the complement. Okay, so this is how you can do. Okay, now next important thing, guys. One theorem that I want to discuss separately. Very, very important. Directly you get the questions on this. Directly you get the question. Matlab even statement factual wise directly. Okay, you get the question on this. That is the consensus theorem. Okay, what is the consensus theorem? Dear, you have AB and suppose you have A bar C. Yes, anybody can, and this is very important. Let me see. Anybody can name what is the consensus theorem. Chalo, let's also test. Since it's revision, na, to thoda bahut to pada hoga aapne. Can you name the consensus? Come on. Okay, we are not yet hit the 100 likes. Come on, guys. 100 attendance is required. 100 likes are required. Morning motivation. Okay. Tell me. Can anybody? Let me start with AB. Or you can start with XY, whatever. Okay, anybody can name consensus if you know. Otherwise, I'm going to write it. No, it's not AB plus BC plus AC. There has to be some complement as well. It's not all true variables. No. Write down, you can write down consensus. No. Very important. Okay. Chalo. So almost two statements I had already written. Okay, you can write in terms of X as well. Okay. Correct. So, in terms of AB, correct. Yeah, BC is redundant then. Correct, Gautam. Correct. So, देखो, AB plus A bar C. इतना मैंने लिख दिया था ना? Okay, AB, then A complement is available with another variable C, and then the product of these two variables. Product of BC. Okay. One of the variable multiplied by A, another multiplied by A bar. Okay, and then the product of these two variables BC. Okay, this BC will always be redundant. This BC will be redundant, and you can write down AB plus A bar C. You can write down the result as AB plus A bar C. ठीक है? AB plus A bar C. ठीक है जी? चलो ठीक है. Now in whatever form you write that, this is one form and you can arrange the variables. Okay, now how this comes up? Okay, how this comes up? Okay, you can solve it by K-map also, and we are going to revise K-map also, don't worry. Okay, we'll be revising the K-maps also. We'll be coming to the questions based on K-maps. Okay. Now, first of all, since we are talking about Boolean function, what are the different ways to represent Boolean functions? Usko samajhte hain thoda. How do you actually represent Boolean function? And to explain you the Boolean function, I'm be taking some example. And the example is let's design a 3-bit prime number detector. Okay. Suppose you want to talk about a 3-bit prime number detector. A 3-bit prime number detector. तो चलो आ जाते हैं इस पे. What is a prime number detector? A function, a circuit which will produce high output whenever the input is a 3-bit prime number. Okay. Now 3-bit में, okay, if you talk about a 3-bit, you will have 8 combinations. Okay, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, which of them is the prime? Now when you take the decimal value corresponding to it, okay, what are the prime numbers? Okay, what are the prime numbers in 3-bit? It's going to be 2, it's going to be 3, it's 5, and it's 7. These are the prime numbers, na? These are the prime numbers, hope you know that. These are what is known as the prime numbers, 2, 3, 5, 7. 2, 3, 5, and 7. Clear, everybody? Okay. In the 3 variable format. Okay, so 2 bole to 0, 1, 0. 3 is known as 0, 1, 1. This is 1, 0, 1. This is known as 1, 1, 1. Okay. So यहाँ पे आ जाएंगे whenever it is. So this is 2, then 3, then 5, then 7. I have made the function 1. I need f bar also for later reference. अभी इसको छोड़ दो. Look into the output. So output is high. Okay, whenever the input is any one of them. Okay, whenever the input is any one of them, output should be high. Such a circuit I want to talk about. So this is the truth table. Okay, number 1, what do? You make the truth table of the circuit. Okay, number 1, what you do is the truth table of the circuit. ठीक है? तो ये आ गया 2, 3, 5, 7. Okay. Of course, wherever f is not written, I mean it is 0. I'm not writing 0. I'm just writing the true value. Okay. And if the f is 0, its complement will be 1. Okay. So at that places, I have written the complement. See, ye zeros hai, obviously. Okay. And wherever f is 0, the complement is 1. Okay. So later on, I'll be using the complement. Okay. But abhi f ko dekhte. ठीक है? Now this is what is a truth table. Now next, what do you do after truth table? You try to write down the canonical form of function in the form of minterm and maxterm. Okay, canonical form means the form that is obtained by directly reading the truth table. Now function is high at 0, 1, 0. How do you design? The function is high at 0, 1, 0. How do you design? Okay, how do you write down the algebra? So 0, 1, 0. How will you write? Okay, this is ABC, correct? This is ABC. Okay. So, whenever a variable is 0, take its complement. B is 1, to take it directly. C is 0, to take the complement. Clear, everybody? Whichever variable is 0, take the complement form. Whichever variable you see 1, take it directly. Okay. So, A bar, B, C bar. Automatically, dear, when 0, 1, 0 comes. When 0, 1, 0 comes, what is going to happen? 0 complement. Okay. Then 1 and then 0 complement. 0 complement is 1. Okay, then again 1, again 0 complement 1, answer will be 1. That's what you want, na? That's what you want. You want the function to be 1 whenever the input is 0, 1, 0. And not only 0, 1, 0, this is one case, okay. Or will be replaced by, okay, the plus operator here, then corresponding to 0, 1, 1. So 0 means A bar. Okay, then 1, 1 means BC. Wherever you see 0, take the complement. Wherever you see 1, take the variable directly. Plus, etc., etc., etc. I'll write down the complete answer. ठीक है? इसके लिए आ जाएगा A, B bar, C, then A, B, C. Okay, this is what is the first look of the function, and this is known as what? This is known as the canonical SOP form. Okay, this is what is known as the canonical SOP form. Canonical SOP form. Now, what is SOP here? What is SOP here? Okay, look into each and every term. Okay, it is the same, guys. 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. चारों को कोड कर दिया है मैंने. Okay, now what is SOP? SOP stands for sum of product. So each and every term is a product term. Each and every term is a product term, and then you take the sum. Sum of what? Sum of products. You are taking the sum of products. So this is what is SOP form. Okay. Canonical means what? Canonical means the form directly obtained by taking the truth table. No simplification has been done yet. अभी simplify नहीं किया है इसको. ठीक है? If we want, we can simplify also. But right now, no simplification has been applied here. As of now, no simplification is applied. ठीक है? Correct. Okay, so this is A bar, B, C bar, A bar, B, C, A, B bar, C, and A, B, C. Okay. Now, understand what is minterm. Understand what is a minterm. Next important parameter is minterm. Okay, what is minterm? A minterm of n variables is a product term. Dot means product term of n variables in which each variable appears exactly once in either true or complemented form, but not both. Ab dekho, to explain you minterm, na, I will do one activity. I'll do an activity. Okay. Look into this function f. look into the function f. Dear, from the first two terms, okay, what can be taken common? B को common ले लीजिए. नहीं, C, A bar B is itself common. From the first two terms, A bar B is common, then you are left with C bar plus C. From the last two terms, AC is common, you are left with B bar plus B. Now, dear, we know x plus x bar is 1. X plus x bar is 1. Okay, so this is known as A bar B. C bar plus C is 1. Okay, then plus AC. Then plus AC. B bar plus B equal to the 1. B bar plus B equal to the 1. Okay. Now, dear, what about this expression? This is also a sum of product expression. Na? Okay. Both of the terms are product terms. Both of the terms are product terms. And then you are taking the sum of them. This is also a SOP form. This is known as standard or minimized or reduced SOP form. This is known as minimized or reduced SOP form. Okay. Minimized or reduced SOP form. Yeah, also known as, yes, minimal SOP form. Okay. Okay, both of them are SOP. Canonical means direct truth table form. Now, in the canonical, because you have every term is directly taken from truth table, every term is a product of 3 variable. Now, many times students are confused. Every product term is a min term. Is this also a min term? Please tell me, dear, yes or no in the comment box quickly. Is this also a min term? A bar B. ये भी तो product term है. Is this also a min term? That is what is the confusion. See, many still say yes. Many still say yes. Dhyan rakhna. A bar B. Next is AC. They are product terms. They are not min terms. They are not min terms. Be very careful, guys. यहाँ पे conceptual mistake हो गया. This is not a min term. What I'm telling is a min term of n variable. We have a 3 variable function right now. Okay, a function of 3 variable when you're talking. So min term will always be a 3 variable term in which every variable has to be there. Okay, it may be A bar or A, but it has to be there. Like A bar, B, C bar. Here A bar, B is D. Where is C? Absent, na? It could be C or C bar. कुछ ना कुछ आना चाहिए, but none of them is here. None of them is here. Okay, so this is not a min term. This is a min term. So when you're talking about a 3 variable function, min term means a product of all 3 variables. Please remember, it should be a product of all 3 variables. The variable can be either true or complement. It could be x or x bar, but कुछ ना कुछ होना चाहिए. Each variable appears exactly once in either true or complemented form. Okay, but not both. ठीक है? Similarly, in AC, B is missing. So that is also not a min term. So understand the difference between a product term and a min term. A product term and a min term. Okay. Now I have reduced this function. Using the Boolean theorem. Can you also reduce it using the K-map? Chalo. So I'll keep linking. Let's make the study today relatively easy. चीजों को link करके study करेंगे. Okay. Can you also link it using K? Can you also minimize it using K-map? Okay, this one was simple using Boolean, but many problems using Boolean will take time. You can refer to the K-map. So what is the K-map? Chalo. So let me jump to the K-map slide for a moment and we will come back here. Okay, we will come back here. I know when to come back here. Don't worry. But I want to link the things and discuss. Link करके discuss करेंगे. So dear, where is my K-map? Baba, where is my K-map? कहाँ चला गया? Yeah. So this is a 3 variable K-map format. Okay, this is a 3 variable K-map general format. So with this, we'll keep revising K-map and we will go back to the min terms. Many more properties of min terms to be discussed. Okay. Now, look into it. We know that K-map gray codes are followed. 0, 0, 0, 1, 1, 1 and 1, 0. Okay. This is what? This basically follows the gray code. So that every consecutive box differs only by 1 bit. Okay, 0, 0, 0, 1, 1 bit of difference. Okay, 0, 1, 1, 1, 1 bit of difference. 1, 1, 1, 0, only 1 bit of difference. Okay, they have to differ only by 1 bit. This is gray code. A can take any value 0, 1. So A is here, B, C is here. Overall, this is 0, 0, 0. So 0, 0, 0 means M0. Okay, min term number 0. I can write a decimal mein likh de simply. Yeah, okay, let me write it in M0 form. Okay, then 0, 0, 1, M1. 0, 1, 1, M3. Okay, 0, 1, 0, M2. Okay, then what is this? 1, 0, 0, M4. 1, 0, 1, M5. 1, 1, 1, M7, 1, 1, 0, M6. Okay. Simply the decimal conversion I am writing. ठीक है ना? Okay. So always remember the last 2 columns will be swapped. Okay. So this is 0, 1, 3, 2, 4, 5, 7, 6. These are swapped. Okay, these are swapped. Okay, so if I want to take an example here, obtain the simplified form of, okay, 2, 3, 4, 5. Summation of the minterms 2, 3, 4, 5. So what will you do? First of all, you will fill. Okay, 2. This is 2. Okay, this is 3. Okay, 0, 1, 3 to remember. 2, 3. Then 4, 5. Okay. First of all, you will fill it up. Okay. This is 2, 3. This is 4. This is 5. Right now? Ye ho gaya 2, 3. Ye ho gaya 4, 5. Next. Okay. Next, you start pairing. Next, what will you do? You will start pairing or grouping. Okay. You will have groups of only 2 or 4 or 8. Groups in the form of 2 power n. Okay. You can make the groups of 2 raised to the power n term. Okay, so like this is a pair. Okay, this is a group of 2. Okay. Okay, this is a group of 2. After making the group, okay, you should write down the answer. Now, when you're going to write down the answer, please see here. Let us come back here. Okay, let us come back here. Yeah, let's see from here only. Okay, look into it. These two are the values of A. This is A0 and A1. And what I told you in the minterm rule just now, whenever A0, it corresponds to A bar. Whenever A is 1, it corresponds to A. So, यहाँ पे A1 hai. So, all of these boxes will correspond to A. Similarly, look into it. This is BC. So, B is 0, B is 0. But these two places, B is 1. At these two places, B is 1. At these two places, B is 1. Okay, so all the boxes inside it correspond to B. Other will be B bar. Okay, wherever B0, it means B bar. Okay. Now, look into C. 0, 0, 0, 1. Ye C hai 1, ye hai C1. Okay, so, you know, all boxes inside this, okay, will correspond to C equal to 1. Okay, C equal to 1 means we write down C. Okay, we write down C. Okay? Chalo, cool hai. Now, you must know all these regions in 3 variable. Okay, you must know all this region in 3 variable. Ab dekhiye yahan pe. Okay, what is this particular term equivalent to? What is this term equivalent to? Okay, this is fitting where? Okay, it is fitting completely within B. It is fitting completely within B. Okay, in the C it is 50%. 50% not allowed. Ekdam simple tarika batata hu. 50% not allowed. Now look with respect to A. This is A and it is outside A. Outside A ka matlab kya hoga? Outside A means A bar. Outside A means A bar. Okay, and inside B. So this is A bar B. This is A bar B. What about this term? Similarly, this is clearly within A. So likh diya A. With respect to C, again 50% not allowed. Now dear, this is B. This particular term is completely outside B. This is completely outside B. And completely outside B, so I will be writing B bar. Completely outside B means I will be writing the B bar. I will be writing the B bar. Okay, so A bar B and A B bar. Okay, so what is the answer equal to? A bar B plus A B bar. Acha, what is this A bar B plus A B bar? It is basically the XOR. We will revise XOR also, but this is what basically XOR is. This is what basically XOR is. Okay, so this is A bar B plus A B bar, or F is equal to A XOR B, I can see. Okay, this is how we have simplified. Okay, ye simple hai. Okay, we will come to 4 variable K map also. Okay, abhi I'll very soon revise you the 4 variable K map also, don't worry. Okay, but yeah, let us jump to that minterm maxterm discussion. Pehle usko finish karenge hum. Okay, then we will jump to the 4 variable. Okay, so dekho here. Okay, here now we have 2 forms, canonical SOP form and the standard SOP forms. I have explained you the difference between a regular product term and a minterm. These are minterms, these are not minterms. Okay, these are minterms. All of these 4 terms are minterms. All of these 4 terms are minterms. Okay, all of these 4 terms are minterms. Okay, acha, same problem if I want to reduce by K map then. Same problem if I want to reduce by K map. I have reduced by Boolean theorem. Okay, suppose the same problem I want to reduce by the K map. Okay, again this is A 0 1. This is BC gray code 0 0 0 1 1 1 1 0 gray code. And what is the function now containing? What are the minterms in the function? What are the minterms in this given function? So this is A bar B C bar. Okay, corresponding to 0 1 0. Okay, corresponding to 0 1 0. Okay, which minterm is coming? 0 1 0. M2. That is known as M2. Then 0 1 1. 3. Okay, 1 0 1. 5. Okay, 1 1 1. 7. And commonly we write it in the form of minterm list. Okay, rather than writing M2 plus M3, we write it as summation form. Summation M 2 3 5 7. What are the minterms coming up? 2 3 5 7. So write down summation M 2 3 5 7. Summation M 2 3 5 7. Have a look into it. This is a complete list of minterms. Okay, what are all the possible minterms? Okay, for 0 0 0, A bar, B bar, C bar. That is known as M0 because it corresponds to 0, 0, 0. 0, 0, 1, M1. 0, 1, 0, M2. 0, 1, 1, M3. 1, 0, 0, M4, etc., 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 etc. ठीक है. Yes, yes, Dave, it is a scoring subject. थोड़ा बहुत बस counters वाले problem और FSM problem पे ज़्यादा focus करना है. Rest it is scoring. ठीक है. This is the list of all the minterms. Okay. So what are the minterms that have come up here? M2, M3, M5, M7 written in the form of list. This is known as minterm list. This is known as minterm list. So I'll just write down these minterms in the K map. Okay. This is 2, then 3, 4, 5, 6, 7. Okay. Now what will you do? You will again make the groups corresponding to it. Okay, this is one group, this is another group. Okay, adjacent boxes can be grouped. Okay, adjacent boxes can be grouped. So ठीक है, now write down the answer corresponding to every term. Okay, what is this? Region एक बार फिर से लिख दे. I already explained you. This is A. The last two row columns for B, the center two columns for C. Okay, so where is this belonging to? This is belonging above A, outside A bar, again within B. So it is B. What about this particular term, dear? See, this is within C. Within A, clearly. With respect to B, 50-50%. 50% not allowed. Okay, 50% not allowed. Okay, so this is A and C. This is A and C. Okay? This is A and C. Yes, you should study once, Akansha. You should not neglect floating point representation. Okay, so what is the F equal to? Okay, A bar B plus AC. Solved by K map also. Same thing we have solved by Boolean also. A bar B plus AC. A bar B plus AC. ठीक है, A bar B plus AC. Done है. A bar B plus AC. Okay, all cool, dear. Okay, all cool. ठीक है. So this is what is the minterm form, या canonical SOP form, या standard SOP form of writing the function. Now, dear, let me start by complement of the same function. We are in that prime number detector. Okay. So what are the prime numbers? 2, 3, 5, 7. Wherever the input turns out to be 2 or 3 or 5 or 7, see the output is high. Okay. When the output is not high, it means 0. Okay. And whenever the output is 0, its complement will become 1. So now come to the column for F bar. Please now come to the column for F bar. Suppose I want to write down the F bar function. Dear, suppose I want to write down the F bar function. So how will you write down the F bar function? Dekhna. How will you write down the F bar function? How will you write down the F bar function? Okay. So 0, 0, 0. That is, how do you write 0, 0, 0? A bar, B bar, C bar. All are 0, so all will be complemented. Okay. Then A bar, B bar, C, etc. So let me start writing F bar. See, I am writing here F bar. Please see. I am writing here F bar. Okay. So A bar, B bar, C bar. Then A bar, B bar, C. What is the next term? What is the next term? 1, 0, 0. 1, 0, 0 means A, B bar, C bar. ये देखिए A, B bar, C bar. And last one is ये रहा 6. 1, 1, 0. 1, 1, 0. How do you code? A, B, C bar. 0 means bar. तो ये आ गया. Last is A, B, C bar. Okay. A, B, C bar. ठीक है. Now, this is F bar. I want to write down F. So how do you write down F? Okay. How do you write down F? Okay, F bar ka bar, complement and complement, double negation. Complement and complement will cancel each other. So I'm not taking the complement of it using the De Morgan's law. Okay, so De Morgan's will come up here. Okay, so A bar into B bar into C bar. How will you write this? A bar, B bar, C bar. A bar will become A, B bar will become B, C bar will become C. Every into, ये product term था ना, will become plus, plus, plus. ठीक है, plus, plus. Similarly, this plus becomes into. Then A plus B plus C bar. Okay. A plus B plus C bar. Next आ जाएगा into A bar plus B plus C. Next आ जाएगा again into A bar plus B bar plus C. All variables are complemented and plus and dot are converted. Plus and dot are converted. ठीक है? Plus and dot are converted. Okay, this is what I have done. Okay. Now, this representation of F, ये भी F है. Okay. This representation of F, what is this known as? What is this known as? Look into each and every term. Now, what is each and every term here? Each and every term is a summation term. A plus B plus C. It is a sum term. A plus B plus C bar. It is again a sum term. Okay, sum. Okay, so each of these term is a sum term. Okay, and then you take the into. Then you multiply them. Then you take the product of it. Okay, this is what is POS. Product of sums. This is known as POS form. This is known as the POS form. Product of sum form. Product of sum form. Clear everybody? This is product of sum. This is product of sum. ठीक है जी? चलो बहुत बढ़िया. This is product of sum. Okay, hope that is clear. Okay, that is product of sum form. ठीक है. अच्छा, now again this is canonical FPOS. What is canonical? It is directly obtained from the truth table. I have not reduced it right now. Okay, now each of this term, some terms, because it contains all three variables, like what was the condition for min term? Min term is a product term, but compulsorily all three terms are coming. Similarly, if there is a sum term containing all three variables, that will be known as a max term. That will be known as a max term. A max term of n variables is a sum term of n variables in which each variable appears exactly once in either true or complemented form. See, here there is C, here there is C bar, here there is A bar. Okay, but all variables are coming in each sum term. That is important thing. Okay, either in true or complemented form, anything. Okay, anything. That is what max term is. Okay, so again, now look into this max term. Actually, how this max term is coming. This is min term number 0. I call this as max term number 0. Max term I will write capital M. Okay. How this has come? By taking the complement. De Morgan's apply kiya tha na? This is F bar. When you take the complement, you get F. Okay. So this was min term small m0. This is max term m0. And what is this? It is the complement of the min term. And not only this one. Every max term is just the complement of corresponding min term. Every max term is the complement of corresponding min term. So no need to remember max term. Okay, you can just directly take the complement of any min term, you can get a particular max term. Okay, you can get a particular max term. Okay, every max term is the complement of the corresponding min term. Okay, corresponding min term. Now, important thing is, I have written the function once in the form of min term list. इसको क्या बोलते हैं? इसको बोलते हैं min term list. इसको बोलते हैं min term list. Okay, now here there are the max terms multiplied. Okay, so this is m0. I can now write down this function f is equal to how much? This is max term m0. चलो यहाँ लिखते हैं. Let me take space here. Okay, it is m0. Okay, next is what? Okay, this is corresponding to m1 का complement. Okay, that is capital M1. Okay, then a bar plus b plus c bar, that is m4. Okay, a bar plus b bar plus c, that is m6. Okay, and they are multiplied. So how can I write the shorthand form? How can I write down the shorthand form of this? The function m here is product, the product symbol. Okay, this is mathematically product symbol. Product of the capital M. Capital M means max term. Here I have written summation m. Small m means max term and they are added. Min terms are multiplied. Okay, product of min terms. Which min terms? Okay, 0, 1, 4, 6. 0, 1, 4, 6. This is known as the max term list. This is known as the max term list. Everybody clear? This is known as the max term list. Okay. Now dear, if you notice the min term and max term list, min terms are 2, 3, 5, 7. Let me write down both of them together. Okay. What were the min terms? 2, 3, 5, 7. Summation min term 2, 3, 5, 7. Same function, same prime number detector. Same function, no change. Okay. Is product of the max term 0, 1, 4, 6. Okay. Now look into both these lists, dear. Look into both this list and what can you observe from both of these lists? What can you observe from both of these lists? What is happening? Yeah. What can you observe from both the lists? Tell me. I think it thoda sa stuck ho gaya hai. What can you observe from both this list? Please tell me. Okay. The numbers 2, 3, 5, 7 are here. The missing numbers. Missing number means 0, 1, 4, 6. They are in the min term list. Okay. So you can convert a max term list to the min term list very easily. Okay. Given a function in the form of min term list, max term list can be obtained by listing those integers in the range which are not included in the min term list. Those integers which is not in the min term list. Of course, the integers up to 2 power n minus 1. Like 3 variable, 0 to 7. Na? Okay. You cannot go beyond 7 because 3 variable, the listing is up to 0 to 7 maximum. Okay. So the list, the numbers are just complement of each other. Achha. Now, next result with respect to the min term and max term list. Okay, need not derive it here because in this revision we cannot derive everything, but yeah, important results zarur dekhenge. Suppose two different functions are given in the form of min term list. Okay, now suppose the question is f1 plus f2. What you have to do is just take the union of both the sets. And if it is f1 into f2, take the intersection of both the sets. If the functions are given in the form of maximum list, okay, reverse kar denge. Reverse kar denge. Rules will be reversed. Let's take an example here. Okay, suppose the function summation m1246 and summation m3467. Okay, determine f1 plus f2 and second is f1 into f2. And second is f1 into f2. Second is f1 into f2. Tell me dear, what could be the answer? Okay, so what is f1 plus f2? As I told you, plus means take the union of both the sets. Okay, union means all the integers which are in A or B or both. Okay, how do you take the union of the list? So 1, 2, 4, 6. Okay, so 1 aayega, 2 aayega, and then 3, 4 will also come. Okay, 3, 4 is common, that will come. Okay, and then you have 6 and then you have 7. Okay, the numbers which are common like 4, 6, they will come, and they will also come. Acha, 4 miss kar diya kya maine? Sorry. Okay, 1, 2, 3, 4 and 6, 7. The numbers which are common, that will also be written once. Okay, the numbers which are in A or B or both, that is f1 union f2. Okay, that is the answer for f1 plus f2. Now f1 into f2 is f1 intersection f2. Okay, and that is given by intersection means common elements. And what are the common elements? 4 and 6 are the common elements. The summation of the minterms 4 and 6. It is summation of the minterms 4 and 6. Okay? 4 and 6. Okay, it is only 4, 6. Correct, ji? That's it. Okay. These have very simple derivation but not required. Na? Write down. आप केवल results पे focus करते चलिए. ठीक है? अच्छा, next question. Now suppose the function may be given in the reduced form. Suppose the function may be given in the reduced form. In the reduced form. Okay, can you write down the minterm expansion? How do you write down the minterm expansion? That is also important. That is also important. I'm telling you, na, some concepts we can directly revise. For some concepts, I will refer to the question. Okay, my idea is to revise the complete subject in one shot. Okay. Okay, dekho. So, what are the minterms corresponding to it? So, dekho, what you can do is, okay, you have the term PQ. Now, PQ can be written as, okay, PQR plus R bar. Then I will shortcut बताऊंगा. Okay, the basic thing is you want minterm, and minterm means what? Minterm means every particular, in every product term, all three variables should be coming. Okay, all three variables is coming and it is a 3-variable function. It is a 3-variable function. So, PQR plus R bar. That means it is PQR plus PQR bar. Now, what is PQR? 111, and what is 1? This is PQR bar 110, that is 6. Like this we can find the minterms. Okay, अब हम directly क्या करेंगे? इसको आप ऐसे कीजिए. Okay, this is I explained for one term. Okay, this is I explained for one term. Okay, let us write down PQR. Okay, and the first term is PQ. Okay, next is QR bar and next is PR bar. Okay, we know the rules. P and Q are direct coming up. Direct means 1, 1. Okay, R. What is R? Don't care. R is not coming up means it could be either 0 or 1. That is not specified here. QR bar. Q means 1. R bar means R is 0. Complement means 0. P is not coming up here. PR bar. P is 1. R bar means R is 0. Q is unspecified. Okay, so Q is taken as don't care. Okay, now when I say don't care, it means either 0 or 1. So 110. 110, 111. ये हो गया. X can be 0 or 1. So 010 or 110. And what is this? Okay, 100 or 110. ठीक है. So like this is 6 and 7. अगर integers में लिखें तो 2 and 6. And this is 110, that is 4. And then again 6. Again 6. Overall, okay, there are some things repeated, but that is okay. You are getting 2 and 4 and 6 and 7. Overall, when you combine, you should get 2, 4, 6, 7. You should get 2, 4, 6, 7. My answer is option number A. Okay, इस तरीके से कर लीजिए. My answer is option number A. Clear? 2, 4, 6 and 7. That is what my answer will be. That is what my answer will be. Okay. Now guys, yeah. Okay. let's go back to the K map. उसके बाद आएंगे logic gates and all discuss करेंगे. Okay. Yeah. So we already revised the 3 variable K map. Let us complete the K map problems. Okay. Similarly, okay, now let me discuss the 4 variable K map. Let me now discuss the 4 variable K map containing 4 variables A, B and C, D. The values of A, B written vertically, the value of C, D written horizontally. Again, gray codes will be followed to 0, 0, 0, 1, 1, 1 and 1, 0. Gray code. Again 0, 0, 0, 1, 1, 1 and 1, 0 because of the gray code. And then when you start writing the minterms, na, what will happen? 0, 0, 0, 0 is M0. 0, 0, 0, 1, M1 minterm will come. 0, 0, 1, 1, 3, 0, 0, 1, 0 is 2. Okay, so last 2 columns because of gray code again swapped. 0, 1, 3, 2. ये पहले 3 आएगा फिर 2 आएगा. Okay, then 0, 1, 0, 0 that is M4. 0, 1, 0, 1 that is M5. 0, 1, 1, 1. 0, 1, 1, M7. 0, 1, 1, 0 that is M6. 0, 1, 1, 0 M6. ठीक है. Now look into this. 1, 1, 0, 0 directly 12 आया. Okay, directly पहले 12 आया. Okay, then 1, 1, 0, 1 that is M13. Okay, 1, 1, 1, 1, 15. 1, 1, 1, 0 that is 14. Now come to the last row. 1, 0, 0, 0. 1, 0, 0, 8. 1, 0, 0, 1, 9. Okay, 1, 0, 1, 1, 11 and 1, 0, 1, 0 is 10. So देखो last 2 columns are anyway swapped. 3, 2 पहले, then 7, 6, 40, 15, 14, 11, 10. Similarly, because of the gray code, okay, the last 2 rows are also swapped. Okay, so you stopped at 4, 5, 6, 7, 8 यहाँ नहीं आया, 8 goes last. 8, 9, 10, 11, then 12 वाला row आया, 12, 13, 14, 15. Clear? The last 2 rows are also swapped. Okay, now, okay guys, good to know that you are liking the revision. Okay, जब खत्म होगा तब stop करेंगे. Let's not count the time. Okay, but in between I will give you the breaks. Okay, now look into A dear. Where is A high? Okay, these 2 combinations. मतलब this is my region corresponding to A. What about B? ये हो गया 0, 1. This is B. Okay, then CD. Okay, C. These 2 are places where C is high. Okay, so this is C and D. Okay, in दोनों में D high है. Center 2 columns. Okay, so I will write it here. That is D. Clear everybody? This is how we write down the region of every variable. So last 2 rows A, center 2 B's. Last 2 column C, center 2 column D. Okay, example से समझेंगे तो better fit होगा. Okay, better fit होगा. Okay. Come on, do this example quickly. All right, so I think time to touch 150. Time to touch 150 likes, isn't it? Time to increase the motivation. So we are close to 150. Time to touch the 150 likes. Come on, guys. Okay. It's almost maybe 1 hour bhi nahi hua hai, but that's okay. Obtain the simplified POS form. Okay. Okay. Yes, sir, and we'll decide that. Okay, देखेंगे जैसा flow होगा. चलो तो 0, 1, 4, 5. Number 1 is keep filling the midterms. Okay, 0, 1, 2, 3 नहीं है. Then 4, 5, 6, 7. Then directly come to 8, 9, 10, 11. Okay, 10 पे stop कर दिया है वहाँ पे. I think 11 नहीं देना चाह रहे हैं वो. That is okay. Now, what are the possibilities? I told you can make groups of 2 power n. Okay, so here एक बार region भी लिख देते हैं. This was A, this is known as the B, this center last 2 columns is C and center 2 is known as the D. And now let us come here. Okay, make larger possible group. Okay, the more the number of groups, more will be the reduction. Okay, so like this is completely adjacent. Adjacency means what? Either horizontal or vertical. Okay, diagonal does not mean adjacency. So this is completely a group of 4 quad. We call it as quad. Okay, similarly this is also a group of 4 variables. If they are repeated, you can repeat them. If you want to repeat, you can repeat. Okay, no problem. ऐसा मत सोचना कि ये दोनों use हो चुका है तो I should be making a pair. No. Okay, you can repeat if you want. Okay, you can repeat if you want. Here this comes. Okay, here this comes 1, 1, 1, 1. Clear? 1, 1, 1, 1. Now, what about these 2? Okay, guys, in the K map, as I told you, first and last columns are also adjacent to each other. Why? What is adjacency? Any 2 boxes differing in single bit. Any 2 boxes differing in single bit, they are adjacent. तो देखो ना, ये है 0, 0. First wala 0 0, then 1 0, only one bit of difference na. So first and last columns are adjacent. Similarly first and last row will also be adjacent. ठीक है, तो यहाँ पे first and last column adjacency use करेंगे. So these two can be paired up because they are adjacent. This is also paired up. Okay, chalo, now let us write down the corresponding answer. Okay, so where is this quad coming into? Okay, this is clearly above A. Outside A means A bar. This is inside B. Okay, acha. With respect to C, dear, 50% hai. 50% not allowed. With respect to D also, it is 50% in D, not allowed. Okay, either completely in or completely out. So that is A bar B. Okay, next aa jayenge. Look into this quad, dear. Okay, now this is A. This is completely outside A. Outside A means again A bar. Okay, now dekho B. Okay, this is B. 50% in B, not allowed. Okay, dekho, ye hai C. This is outside C, totally outside C. So A, C bar. Okay, and D में भी देखोगे, D में 50% is there, 50% not there. Okay, so we have A bar, C bar. Okay, now let's come to the pair. Okay, let's come to this pair. This is only a group of two. Okay, देखो, with respect to A, it is inside A. Okay, the center two rows are B. It is below B, outside B, B bar. In C, half is there, half not allowed. In D, देखो, this is center to column D, but it is totally outside D. Okay, outside means you will write down D bar. Okay, so what is your answer now? Your answer is, for F, the first term I can write A bar B, then I have A bar C bar, and then I have A B bar D bar. हो गया जी? Okay, हो गया? Okay, हो गया? अच्छा, ये POS ठीक है, अभी मैं दोनों बता रहा हूं आपको, ठीक है? Let's solve both. Simplified SOP and POS. चलो, let's solve both. Let's learn one more concept here. Okay, दोनों ही solve करते हैं यहाँ पे. This is SOP. Okay, this is SOP. Okay, this is SOP. ठीक है, so number one, this is the answer complete. I just went in the flow. I wanted to explain you the SOP first. But let us, good point. Let us, with the same question, let us learn the SOP and POS. Okay, so everybody clear? This is the SOP form. This is the SOP answer. यहाँ पे कोई doubt है तो बोल देंगे. अच्छा, please remember that. Please remember that. Okay, when you made a quad, it is a 4 variable function, huh? But when you made a quad, you only got 2 variable term. So how many reduced? 2 variables reduced. This was a pair. Please listen to this. This is a pair. Okay, you got a 3 variable answer. Means how many reduced? Only 1 reduced. C gayab hai. Only 1 reduced. Okay, only 1 reduced. So whenever you take a group of 2, na, ठीक है, थोड़े से कुछ points को add on करेंगे यहाँ पे. Dear, whenever you take a group of 2, whenever you take group of 2, okay, that is going to reduce how many variable? That reduces 1 variable. Okay, if you take a quad, okay, that reduces 2 variable, right? If you take a group of 8, octa, that will reduce 3 variables. Okay, so always remember, in general, कभी कभी छोटे छोटे points पे question आता है कि whenever you take a group of 2 power n, that is going to reduce n variables. That is going to reduce n variable. ठीक है? Yeah, we'll discuss prime implicants also. Essential prime implicants and prime implicants. Don't worry. अभी discuss करेंगे उसको. Okay, so group of 2 power n will reduces the n variable. A group of 2 की power n will reduces the n variable. Clear everybody? Okay, hope that is clear. चलते हैं next. Okay, reduces n variable. Okay, now same example. Okay, same example. SOP is done. Now let us come to the POS answer. Simplified POS answer. Now dear, I know for POS some of you might be following the grouping of zeros. Okay, but I always try to remember the simplest. Explanation. Sometimes the simplest explanation is almost always the right explanation. Okay, just take dialogue tha. Forget this one. Okay, so what is this now? What is this? The F is given to you. A POS ke liye approach. What is the F given to me? Write down the F. Okay, 0, 1, 4, 5, 6, 7. 0, 1, 4, 5, 6, 7. Okay, and after 6, 7, I have 8 and 10. Okay. To be simple, let us follow the group of 1 only. No need to group zeros. Okay, but what to do for group of 1s? First start with F bar. Acha, the min terms which are missing in F, they will go to the F bar, na? They will go to the F bar. Okay, so what is F bar? That is summation of the min terms. So they go 2, 3, 4, 5, 6, 7, 8, 9, 10 is there. Then 11 to 15. 11, 12, 13, 14, 15. Okay, this is what f bar is. Clear? This is what f bar is. Okay, now I will like to make the k map. I'm just making the k map corresponding to f bar. Just pay attention. I am just making here the k map that is corresponding to f bar. A regular k map grouping of ones ke saath. This is AB, this is CD. Okay, now let's fill the minterms. Okay, for f bar. Okay, this is f bar k map. So this is 2, this is 3, and 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15. Okay, just the invert of this. Okay. Okay. Now, acha, we know the regions also. Okay, this is A, this is known as the B, this is known as the C, this is known as the D. Okay. Chalo. Now, what is this? Again, I am able to make a quad here. These two don't take alone because upar bhi ones hai, so better take quad, because I've told you, na bigger group you take, more number of variables you reduce. Here, these two can be again paired. Okay, only these two are alone. Okay, there is no quad with them. At least a pair can be taken. Now write down each and every answer, dear. Write down each and every answer. Okay, what is this? This is above A, above B, and within C. A bar, B bar, C. Okay, what about this quad? Is quad ko likhenge. So this is in A and in B. Correct. Look into this quad. This quad is in A and in D. Okay, but this is not the final answer. This is the answer for f bar. Okay, now one step extra. Rather than making grouping of zeros, I follow grouping of ones. Okay, I follow grouping of ones. Okay, I write down f bar, and f bar is equivalent to A bar, B bar, C plus A bar, B bar, C plus AB plus AD. That is f bar. Now you get f. Now you get f. Question is for f, na? How do you get f? De Morgan, by the duality method. Okay, A bar will become A, B bar will become B, C will become C bar, and product term tha, now it will become sum term. Okay, C ki jagah C bar. In plus will become into A into B will be A bar plus B bar. Again plus becomes into A into D, that is A bar plus D bar. That is known as the, now look into this. This is known as the simplified. Right, everybody? Reduced form है क्योंकि K map से निकाला, but what type of form? POS form. POS form. Okay. Each of the terms is some term, and then you are taking the product of it. POS form. This is a product of some form. This is a product of some form. So go with this. Okay, it will be easier. It will always be easier. And what was this? This was the simplified SOP form. So both are obtained. For the same question, both are obtained. So just follow the grouping of ones. No need to change the K-map method. What is only one line extra in this method? Okay, that is the complement. But taking the complement, how much? Maybe 10 seconds. If you remember the duality logic, especially if you're solving by the duality logic, how much? I think maybe 10-15 seconds extra. But method is same. So you remain to one particular fixed method. Grouping of ones pe chalenge keval. Same K-map, same grouping of ones to be taken. Okay. Next problem. Okay, with the don't care. Let us also incorporate the don't care. Let us also incorporate the don't care here. Don't care ko bhi dekh lete hain. How are you going to deal the don't care? Okay, so simplified form of summation PQR is 0, 1, 2, 3. First to min terms ko fill kar denge. 0, 1, 2, 3. Okay, then you have 5, 8, 10, 11. Okay, 5, 8. Okay, then you have 10, 11, 12, 13, 15. Okay, then you have summation of the don't care 4, 6, 7. So 4, 6, 7, 12 and 14. अरे बाबा ये तो पूरा ही आ गया. ठीक है. How to deal with this? Okay, just one is missing. Okay, now what is don't care actually? Before I explain this problem, यहाँ पे तो complete हो गया है. What I will do is I'll take another problem here. ठीक है. Let's try to simplify another problem here. First, let's simplify another problem here. I'll directly draw the K-map and then we'll jump back to that problem, okay? Just एक और problem लेंगे यहाँ पे. Can you solve this problem? Can you solve this problem? ठीक है. Like if I want to write down in the form of question, ये रहा question. Question is summation of minterms. कौन कौन सा minterms लिया है मैंने? 2 लिया है. Then I have 4, 6, 7. I have the 7. I have the 7. Then I have 10, 11. Then I have the 12, 14, 15. ठीक है. बाद में दे लूँगा. बाद. ठीक है. So this is 2. Then 4, 5, 6, 7. And then there are some don't care. So we write it in the form of don't care list. What is a don't care list? Okay. This is known as, sorry, 3. Okay. This is 3, 4, 5, 6, 7. Okay. There are 2 don't cares that I have taken for you. Clear, everybody? There are 2 don't cares that I have taken for you. Come on. So now what should be the answer corresponding to it? Okay. Now, whenever there is a don't care term, it may be treated as either 1 or 0. Not necessary to take it as 1. It may be treated as either 1 or 0. Either 1 or 0 based on your convenience. Okay, what is your convenience? Your convenience is you want to reduce the answer. You can reduce the answer if you have bigger groups. Okay, so definitely if you take these two x as 1, if you take these two x as 1, you definitely get an octa here. You definitely get an octa here. Okay. Now similarly, should this be paired up? Isko pair lena hai kya? What you can do here is, these two is 1. This is already taken as 1. So 1, 1, first and last column adjacent. First and last column adjacent. Ye ho gaya. Acha, now let me add one more don't care here. Please listen to me. Suppose I add another don't care here. Now what to do with this don't care? एक और don't care add किया है. So that becomes 8, 9. Okay, यहाँ पे एक और list में add कर देते हैं. That is 9. 3, 6, 9. What to do with that don't care now? What to do with that don't care now? Okay, is it necessary to take this don't care? Is it necessary to take this don't care? If you take this don't care, what are you going to achieve? What are you going to achieve? You are going to unnecessarily create an extra term. Na? See, this min term is already covered. It is not compulsory to cover don't care. Otherwise, you're creating an extra term. Not necessary. That is wastage. Okay. So what I want to tell is not necessary to take don't care. If you feel it is helping you, please take it. Otherwise, neglect it. So isko neglect kar denge. Isko neglect karenge. Now, what is the answer for this particular term? Okay, let me again write down the regions for you, dear. Okay, we know that this corresponds to A, this corresponds to B, this corresponds to C, and the center to column is D. Now, what is the answer corresponding here? This is complete octa. Octa means a group of 8. It should reduce 3 variable. It is only within C. It is only within C. It will only contain C. A, B, D will be reduced. Okay, और ये है quad. Okay. With A 50% hai. With B it is completely in B, and this is D, so it is outside D. It is outside D. Okay, so what is my answer, dear? My answer is equal to C plus B D bar. Please check out whether this is your answer, C plus B D bar. No, A D bar, no, B D bar, dear. Please check it out. C plus B D bar. C plus B D bar. Correct hai? Is this what is the answer you're getting? Tell me there. Okay. And if this is correct, if this is correct, now let's go back to the next problem and tell me what can be the answer here. What can be the answer here? What can be the answer here? Please tell me. What should be the answer for this one? Now see, dear, यहाँ पे there are 2 possibilities. If you take all the don't cares as 1, okay, you may take all the don't cares as 1. Okay, you have one quad. Okay, you have one quad. Okay, you can have another quad. Okay, and you can have a third quad. Listen to me. First is making 3 quads. Here 3 quads are possible if you take all don't care as 1. If you take all don't care as 1. Okay, that is the BD bar, na? That is what is BD bar, right? Okay, so yes, guys. Okay, one of your favorite dashing Joshit sir is here with us. Okay, the ninja technique Joshit sir. So yes, guys.
Yes, so hi everybody, welcome.
Can you boost up their confidence for gate 24?
Sir, I think now it's the high time when they should be super duper boosted, because there is no time for demotivation, I guess. And the way they have
demotivation सोचने का time नहीं होना चाहिए.
वो भी time नहीं होना चाहिए. And the way you all have put your all the hard work, and also the Rakesh sir, the man, I have used the word by the way, right? So with the help of him, you have learned so many things. Now there is not a question about the demotivation. So why to worry about that? So I think this is the best time, and I would also say this is the time that you should enjoy and don't think about the result. Just focus on the process, I would say, sir.
Yes, exactly.
Right? About how you have to perform in that 3 hours. That's everything which matters.
That matters, and that is why you should give more and more mock test. और आपको मैं honestly बताता हूँ. Okay, my thing, and I think same applies to sir also. Okay, when we were in the last month of preparation, ना, actually कभी हमें पता ही नहीं था कि motivation और demotivation क्या होता है. And if you are a true gate aspirant, you will just keep preparing.
Right.
सोचने का time है, मतलब you are not actually preparing, so you should not have time to think whether you are motivated or demotivated.
Yes, there is just one thing I would tell everybody who thinks that I'm not giving the test because if I get low marks, I'll be demotivated.
Yes.
Because this happens too many times. The student give the test and they get less marks and they are demotivated, and now they think that we will not give any test. We'll just simply revise the subject through notes, or we will watch YouTube classes, and that's it. We'll directly go into the classroom. I'll just quickly tell you a short story. I will take your 5 minutes, sir.
Sure.
So I'll tell you this company I'm sure you all know about, Samsung. So what Samsung does, I'll tell you one thing very quickly. The manager, what they did, there was a cell phone, sir. So they wanted to launch that cell phone in the market. But before that, what they did, they selected 100 employees. They gave them all these 100 cell phones and said, take 1 month. And after 1 month, tell us the report and tell us what are the problems that you have faced. That's simple. So after 1 month, then all of them came to the manager and told him that, okay, someone said, okay, it's perfect. There is no problem. Someone said that its camera is not good. Someone said it's hanging. Now the manager have 20 issues. 20 people have told him 20 unique issues. Now there are 2 options with the manager. First, he should be sad that my team has worked day and night and still there are 20 bugs in that cell phone. Or he should be happy about this one thing, that thank God the cell phone is not launched for the public right now. He still have time to make it even better. So I think he'll be happy.
Correct.
So
that is what outlook is. I've told you multiple times, guys. If you are getting low marks right now, na, you should be happy.
Right.
ठीक है. Happy does not mean कि party करने लगना, but you should be happy about the fact that you are scoring low, and if you are true aspirant, you will investigate why you scored low.
True.
ठीक है.
Basically, there is a limitation of everything. Like, I have a capability of doing something at a particular extent. I can drive my car up to a particular speed. I can't go beyond that, even if that is the capability of my car. Similarly, the mistakes that you can make, there is a certain capability of yours. So make whatever mistake you want to make in the test only. Don't wait for the main examination in February. That's
Correct.
Simple, sorted, and I won't take much of your time. Please enjoy the class, and again hit the like button, share this video with all of your friends who want this amazing session. Thank you so much.
Thank you sir for joining. So yes guys, ठीक है. So chalo guys. Yeah, so we were on to 3 chords, and I think one more chord is coming, and I'm going to tell you the alternate method, which you can make the answer in just 1 marks. Okay. So guys, very clearly, what is the answer by this? Okay, I have taken all the don't cares as 1. Okay, ये जो first chord है, that is above A. I'm not writing the region right now. That is above A. Okay, and then this chord, center 2 rows is B. So that is B. Okay, sorry, plus लिखेंगे. That is plus B. Next, this particular chord, it is within C, the last 2 columns. So that is C. And then, okay, the center 2 columns are D. ये जो fourth chord है, that is outside D. Done हो गया. So I've taken all don't care as 1 because they are helping me. Now alternate method. Alternate for this. Alternate देखना, please see. Now, in any K map, whether it is 3 variable, 4 variable, 5 variable, where you have maximum boxes filled, okay, and only few boxes, like 1 or 2 boxes are just empty. Except 1 or 2 box, if everything else is empty. Apply a simple logic. Okay, the box which is empty can correspond to F bar. The box which is empty, that corresponds to F bar. Okay, apply this technique when you have only fewer box, like 1 or 2 or 3 maximum empty, rest all is filled. Okay, so what is this minterm? यहाँ पे 9 आता है ना? This is the place for 9. Okay, F bar. Okay, so what is this? This is F bar, and this is nothing but corresponding to minterm 9. And what is minterm 9? 1001. 1 0 0 1 A B bar C bar D. Okay, so dear, what is F? ये तो हो गया ना one line में. No need to make these many quads. Okay, just take the complement of this. So it is A bar, then plus B, then plus C, then plus D bar. Done. Same answer. No. It is not 13. Get 24. 13 तो ऊपर आएगा. Gray codes. You are into gray codes. 1 0 0 1 9 ही तो हुआ. 13 तो ऊपर आएगा. Gray codes में last two rows are also swapped. Be very careful. This is 100% 9. No confusion. No doubts. Okay, जी. So we still get the same answer. We have to get the same answer, ना? Question तो same ही है. Methods कितने भी study कर लो. Answer has to be one and only. Okay. Chalo, quickly. 5 variable also. Sometimes it may be the possibility that you get a 5 variable K map here. Okay, you may have the possibility of getting the 5 variable K map. Okay, 5 variable K map. Okay, now what do we do for 5 variable K map? We take two 4 variable K maps which are just mirror image or replica of each other. Okay, but for one of them, upper variable, upper means MSB को split करेंगे. Okay, for one of them MSB 0, for one of them MSB equal to 1. Okay, and the remaining 4 variables, okay, like 5 variables are B, A, B, C, D, E. Suppose this is A, B, C, D, E. A को split करेंगे. B, C, D, E to be fit in 4 variable K map in the regular method. Okay, like gray code 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is the replica. Okay, only thing is for the first K map MSB A0, for the second K map A will be treated as 1. Okay, and if that is the case, dear, this corresponds to 0 के साथ read करेंगे तो 0, 0, 0, 0, 0, M0, then definitely M1, then again gray code to 3 and 2 are swapped, तो M3 and M2. Okay, तो ये तो same रहेगा like 4 variable, then M4, M5, 7 and 6 swapped. Okay, then 8 will come. Swap होगा, नीचे आएगा ना. 8, 9, 11, 10. Then 12 will come above again because of gray code. So this is also swapped. 12, 13, 15, 14. Okay, but now as soon as MSB becomes 1, अगर MSB का value 1 here dear, तो 1 0 0 0 0. What is 1 0 0 0 0? 16 होता है ना. So here you directly start with 16. This is known as 16 and then keep continuing with the gray code pattern. 16, 17, swap करेंगे 19, 18. Okay, then 20, 21, then 23, 22 swap. Okay, 24 should come last because of gray code swapping again. So 24, 25, 27, 26. Okay, ये आ गया 28, 29, 31 and 30. 31 and 30. 31 and 30. Okay. Okay, now let us implement a problem based on this. Applying the simplified POS form. Okay. Chaliye. So again, the procedure is same. Let us fill all the minterms. Okay. So 0, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. After 15, go to the second K map. After 15, go to the second K map. Okay. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Acha, after this, what to do? After it is nothing great. Same type of pairing you will do. Okay, same type of pairing. Region. Now, this is not ABCD. This is BCDE. So, B. The last two rows is B. Then you will get C. Center two rows. Last two columns D. Then this is E. Same applied here also. This is B. Okay, just ABCD ki jagah na BCDE you will just copy. This corresponds to E. Okay, now tell me. Okay, now same type of pairing you are going to follow here. Okay, just the very same type of pairing you are going to follow here. Same type of pairing you are going to follow here. So, dekh lete hain. What type of pairing you can follow? Have a look into it. This is definitely a quad. This can only be made as a pair, no other choice. Okay, and this is again a pair. If I come to this next K map, this is again a quad. Another pair, another pair. Okay, now let us start naming the pairs and quads. Okay, this is the quad which is D and E mein fit ho raha hai. This is D and E. Perfectly fit in DE. Correct hai. ठीक है. Now what about this pair? One by one I will write down the answer. This is B, Okay, outside D, B D bar E bar. And what about this pair? This is above B, inside C, inside E, B bar C E. Okay, चलिए यहाँ पे आ जाएंगे. This is the same D. Okay, about this pair, this is B bar. ये भी same है. Okay, B bar C E. Perfect. And this particular pair, this is B, C, D. Okay, but when you write down the answer, okay, all the left answers will be multiplied by A0. Now A0, what is the code? If A is 0, you take A bar. If A is 1, you take A. So what should be the final answer, dear? Have a look into it carefully. Have a look into it carefully. My answer is going to be, okay, first, whatever is the answer from the first K map, multiply by A bar. Multiply by A bar. Okay, so DE plus, okay, B D bar E, B D bar E bar actually, plus next क्या है? B bar C E. Okay, B bar C E. Okay, plus A. अब यहाँ पे आ जाएंगे again DE. Okay, then you have BCD and actually B bar C. Now can you have one more analysis here? Dear, DE is common to both. If DE is common to both, A bar plus A will be equal to 1. So A bar plus A will be equal to 1. A bar plus A will be equal to 1. DE common liya, so A bar plus A will be reduced, na? So final answer, okay, DE will come alone. Similarly, these two is common to both. Okay, B bar CE. Okay, only thing is B, then you will have the answer A bar, B D bar E bar. Okay, and next you will have the answer A, B, C, D. Now clear? A, B, C, D. A, B, C, D. ठीक है. Perfect. Clear? So after writing the answer also, now see if these two terms are common. So if you take common, A bar plus A will be 1. One just extra step. Okay. Chalo. So next answer then, crystal clear. Very good guys, very good, very good. Let's keep rolling ahead. Okay, and now a topic which many of you were looking for, that is a prime implicants and essential prime implicants. Prime implicants and essential prime implicant. Okay, okay. What is prime implicant or essential prime implicant? Ek example lete hain pehle first of all. Okay, let's understand this through an example. Okay, starting with the 3 variable case. Okay, starting with the 3 variable case. Let's understand this peacefully. This is A, this is BC. Okay, well, we'll go to 4 variable also then. Okay, now 0, 2, 3. Okay, 0, 1, 2, 3, 4, 5, 6, 7. ठीक है? What if K map? What if K map if complete 1 all boxes? The answer is 1. If complete 1 means function is always 1 independent of the variable, the f equal to 1 is the answer then. Trial mail. Okay. Now dear, please listen to the story here. Okay. Please listen to the story here. Okay. Let us understand the prime implement and essential prime implicant through K map only. Okay. Through the K map only. Okay. Through the K map only. Listen to me. Okay, this is one possible pair. Okay, this is one possible pair. Okay, this is next possible pair. Make all possible pair, because when you write down the answer for every pair, na, it is a product term eventually. Bhai dekho kya kiya. Okay, like this is a pair. Okay, B bar CE, that is a product term. Okay, now like suppose you take any pair. Okay, here I take any pair. If I take a quad, it may be a single term also based on reduction. This was a quad, B D bar. So whenever you try to make the groups, either pair or quad or etc., you will be getting some product terms. What are you getting? You are getting product terms here. Okay, like if I take this pair. Okay, what is this pair corresponding to? Okay, this is A bar and B. This is a product term. What is this pair corresponding to? Okay, this is known as A. See, this is also a product term. Listen to me very carefully. There is a twist going to come up. Okay. Now, should I take it alone? Should I take it alone? Why to take alone? First and last columns are adjacent, so why to take it alone? Okay, you can also pair it. Okay, and when you pair it, again you get a minimized product term, and that is outside A bar, and outside C bar. Now the very important point, the catch here is, what about this? इसकी बात करते हैं थोड़ा सा. What about this one? Tell me. Although if I remove it, all my minterms are covered. Okay, but right now I'm not trying to write down the answer by K-map. I'm just explaining PI and EPI by the K-map. Okay, so when I take it, okay, चलो इसको consider करते हैं. Okay, when I take it, okay, this also makes a pair. Okay, and write down the answer of the pair. Okay, this is in B and C. This is also a product term. देखो यहाँ पे. A product term, any product term implicant will be known as a prime implicant if it cannot be combined. With any other ones. Okay, if it cannot be combined with any other ones. Okay, so okay, this is a product term. Can you combine it with something? Please tell me. Can you combine it with something? Okay, suppose there was a 1 here. Imagine karna. Okay, suppose there was a 1 here. Okay, then you will not take the pair. Pair will make a quad. Pair will make a quad. Okay. Okay. But can you combine it with anything else? No, you cannot combine with anything else. It is the final product term, you can say. It is the final product term. Okay, that is also known as an implicant. So what basically an implicant is? Any product term implicant is a prime implicant if it cannot be combined with anything else. So that means it is a puzzle problem. Okay, whatever pair or quad you can search, that is a prime implicant. Every possible pair. Okay, not only pair. Okay, it may be quad, or it may be octa, or any group, any possible group which cannot be further combined, okay, is known as a prime implicant. So how many prime implicants I have? ध्यान देना, how many prime implicants I have, whether it is essential or not उसकी बात बाद में करेंगे. So how many prime implicants I have? I have A bar C bar, वो पहला लिखा हुआ है. Then I have A bar B. Okay, then I have AC, and then I have BC. Clear, everybody? I have 4 prime implicant. Sometimes they only ask you the number, how many PIs are there. So there are the 4 PIs. Clear? There are the 4 PIs. Acha. Now, how many of them are essential? Let us understand the essential prime implicant. Okay, let us understand the essential prime implicant. Now, essential क्या होगा? To highlight the essential prime implicant, na, what you will do is you will highlight those minterms, like this is a minterm which is covered only under one group. But what about this minterm? सुन लेना एक बार, then I will take up your doubts. What about this minterm? Look into this minterm. This particular minterm is coming, okay, into this group also, into this group also. So it is covered by 2 particular prime implicants. If you miss any one prime implicant, it can be saved in the other. Okay, it can be saved in the other. So if you by chance miss this, okay, it will be saved in BC. Suppose if you miss this prime implicant, this minterm can be saved in the A bar B. So there is a particular minterm which is there in 2 groups, which is there in 2 prime implicant. If you miss one of them, it can be obtained in other. If you miss the other one, it can be obtained in the first one. Clear, everybody? Okay, so I will call both of these prime implicants are non-essential. But if I come to this one, please look into it. Okay, please look into it. This minterm is covered only under one prime implicant, and by chance if you miss it, by chance अगर आपने इसको छोड़ दिया, okay, by chance if you miss it, then what is going to happen? Then this minterm is also lost. This minterm is also gone. Are you getting it? Okay, and if this minterm is gone, the function definition will change. The function says minterm 0 bhi aana chahiye. Function will change. The function will change. Okay, So that is not the correct way. So that is why this particular minterm, again listen to me carefully, this particular minterm which is covered only under a single prime implicant, I will highlight that minterm. Okay, and the prime implicant corresponding to it will become essential. The prime implicant corresponding to it will become essential. Okay, similarly now let us trace it. Okay guys, let me complete, then I will take the doubt. Please let me complete PIs and EPIs once and then I'll take the doubt. Thoda samajhte hain isko. Okay, this is covered under 2, don't highlight. This is also covered under 2. ये इधर भी है और ये इधर भी है. So don't highlight this minterm. Look into this minterm. Look into this minterm. This is also covered under a single group. This is also covered under a single prime implicant. Clear? So that is to be highlighted. Which prime implicant? This is AC. So this is also essential. You can't miss it, because if you miss AC, this is lost. You cannot lose any minterm. Okay? So इसलिए इसको highlight किया. Now this particular minterm, it is highlighted vertically also, horizontally also. This is covered under 2 groups, so don't highlight it. Okay. So how many minterms I highlighted? Okay. 2 of them. The prime implicant, the group corresponding to those minterms are essential. So like A bar, C bar and AC, they are essential. So if I write down the EPI list, abhi story mein aur kahani baki hai. If I write down the EPI list, it's going to be only 2. And what are the 2 EPIs? A bar, C bar and AC. A bar, C bar and AC. Okay. Now these are the 2 EPIs, dear. So can I now say that function is equal to summation of EPIs? Function equal to A bar, C bar plus AC. Okay, chalo dekhte hain, can I say it or not? Dekhna. I have told you that there are only two essential EPIs. I am telling you that there are only 2 essential EPIs. Okay, one is the A bar, C bar. Okay, ye raha A bar, C bar ke minterms. If you include A bar, C bar, these 2 minterms will come. If you include AC, where is AC, dear? AC means, kaun sa tha AC? Oh, AC is this one. Okay, these 2 minterms will come. Ye jo horizontal row hai. Okay. Is this the correct answer? Is this the correct answer? I don't think it's the correct answer. If you take it as the correct answer, then dear, 1 minterm is still missing. 1 minterm is still missing. Bhai, ye kahan chala gaya? This has gone missing. So this is not the correct answer. So definitely answer is not A bar, C bar plus AC. Answer has to include 1 more term. Okay, to cover this particular minterm. Are you getting it? Okay, to cover this minterm. So what should be my answer? What should be my answer? So my answer will be equal to A bar, C bar plus AC. See, essential to anyways, essential ka matlab hi kya hai? Zaruri. Okay, so you cannot miss it. So I have taken all the essential terms. Zaruri term to le liya. A bar, C bar plus AC. Plus what? Now, to cover this minterm, okay, to cover this minterm, what are the options with you? You have 2 options. You have 2 options. Either A bar B, either ye wala le lijiye, theek hai, or vertical wala, that is BC. Okay, so A bar B or BC, these are optional. A bar B, theek hai, or next kya tha? A bar B or BC. Okay, so definitely this will come. But can I say A bar B is essential? Can I say A bar B is essential? I cannot say it is essential, na? I cannot say it is essential. It is optional. Okay, either A bar B or BC. Okay, but these 2 are essential. Okay, these 2 are essential. Okay, so what is my F? I can now generalize and say that F is equal to summation of EPIs. Okay, summation of EPIs plus, now what is this known as? SPI. What is SPI? What is SPI? Let me explain you. Now the prime implicants are categorized into 2 parts. Okay, the prime implicants are categorized into 2 parts. Some of them are essential, some of them are non-essential. Clear everybody? Okay, some of them are essential, some of them are non-essential. So kya kya the non-essential? Okay, kya kya the non-essential? Okay. Okay, 2 of them are essential. So definitely, dear, definitely these two are known as non-essential. Clear? These 2 are known as non-essential. Out of these two non-essential, any one has to be taken in the answer. Any one has to be taken in the answer. Which one? That is your choice. I can have a different choice. You can have a different choice. So that is why, yes, Nishu, two expressions are possible here. Okay, you have to see which of the expression is given in the option. Yeah, it may be a MS2 question also. They may make it as a multiple select question also. Okay. So dear, out of these two, you have to select one and you have to reduce the other. एक को select करना है, दूसरे को reduce करना है. ठीक है. Which one to select? I can have my own choice. You can have your own choice. Nobody stops you. Okay. Okay, you can have your own choice. I cannot tell you कि इसी को select करना है. There is an option. Okay, so out of the non-essential, one of them will be SPI, another one will be RPI. Okay, what is this SPI? That is known as selective prime implement. One which is selected. And what is this RPI? RPI will be redundant, the one which you have reduced. RPI is known as the redundant, the one which you have reduced. That is the redundant prime implicant. That is known as the redundant prime implicant. Redundant prime implicant. Clear, everybody? RPI is basically the redundant prime implicant. Okay. RPI is a redundant prime implicant. Okay. SPI and RPI. SPI and RPI. Cool hai? Chalo, clear. All clear. Let's get moving ahead then. Okay. Okay. Yeah, extra mail. Correct. We can say that prime implicants are all possible pairs or quads that you can make. It's a puzzle problem. Very correct. Treat the prime implicant as a puzzle problem. Okay. Whatever pairs you can find, whether it has to come in the final answer or not. Okay. Whether it has to come in the final answer or not, it does not matter. Okay. But all possible pairs that you can highlight, it is a prime implicant. What is the final answer? Look into it. Final answer is summation of EPIs. Ye compulsory hai. Okay. Plus SPI, selective prime implicants. Okay, out of the EPI, some will be selected, some will be redundant. I cannot write down. See, I cannot say that A bar B is SPI. Okay, because you may say that BC is SPI. That is why I'm not writing which is SPI. That is a choice. That is a choice. Okay, that is a choice. Clear? Okay. Yeah, very soon we'll be planning for CS also. It's under planning, like digital to common hai, but for separate CS also there is the planning going on. Okay, so we'll update you once that is completed. Once that is completed. Let us move ahead. Okay, now 4 variable example, dear. PI and EPI, 4 variable example. 4 variable example. Okay, so digital to common hai, you can attend it. Okay, so let's go to the next. Okay, ABCD. ABCD. Okay, so चलिए 2 3 5 7 0 1. Okay, सबसे पहले क्या करेंगे? Again write down the min terms. 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Now next, treat it as a puzzle problem. Just first of all, treat it as a puzzle problem. Okay, how many groups you are able to make? Okay, whether it is pair or quad. But remember, don't take it as a pair when you have the option of quad. Okay, the final group that you are going to take. The final group you are going to take. Okay, so this is 1 1 and 1 1. Okay, this is a quad. Okay, then this is also another quad. Okay, then these two on the top, these two on the bottom. This is again a quad. Anything else? This one is left. What to be taken? Okay, 1 1 1 1. This is also a quad. This is also a quad. Okay, tell me now what else? Tell me what else? Okay, first of all, 3 to nahi, 4 to maine hi bana diye. Definitely it's not 3, it's 4. 4 I have made in front of you. 4 I have made in front of you. Okay. So it's 4 quad. All possible quads. Okay. All possible quads. Tell me 4 or not? Correct. Any doubts? Okay. This is 4 variables. So let me write this as A. This is B. Okay. Of course, this is C. Center to columns is known as the D. Okay. Now, what is this quad corresponding to? What is this quad corresponding to? This is outside B. Correct. Outside B and inside C. B bar C. Okay. What about this quad? This is A and C. Perfect. Okay. What about this one? Okay. This is B bar and C. अच्छा नहीं, ये तो ले लिया मैंने already, sorry. ये ऊपर से ले लिया. Okay, yeah, let's come to this quad. This is B and D, center के 4 boxes, B and D. And anything else? Yeah, this third row, this third column, sorry, and that is CD. That is CD. How many PIs are there? Okay, 4. Okay, what are the 4 PIs? Let me write down. B bar C. Okay, what was this? ये missing हो गया क्या? This was कौन सा वाला? This is A and C. AC, then you have CD, then you have BD. Clear, everybody? Okay, now how many of them are essential? So I will start highlighting the minterms. Okay, which are alone. This is minterm under 2 groups. Don't highlight. This minterm, dear, is alone. Poor fellow, covered only under 1 group. So please highlight the minterm. Okay, now the group B bar C. Now the prime implicant corresponding to this minterm B bar C. This is essential. Okay. Then this is covered under multiple, 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 but this is covered under single. Yeah, alone hai. Okay, which group? AC, that is also essential. Okay, now this minterm is also covered under single. This is also single, but both of them are under a single group, that is BD. So BD ko ek baar tick karenge. So what are my EPIs? My EPIs will be 3. Okay, and they are B bar C, AC and BD. B bar C, AC and BD. That is the answer. Clear, everybody? That is the answer. Chalo. Okay. So such types of questions can also be there for you. Hope it is now simple and clear. It's a simple procedure if you follow the K-maps to calculate PI and EPI. To calculate the PI and EPI. Okay. Acha, this CD, this is non-essential. Okay, but is it selective or is it redundant? Is it selective or redundant? See, when you cover these 3, see, I'll highlight. When you cover B bar C, okay, these 2 are exhausted. Thoda differentiate lete hain. Okay, these 2 are exhausted. Okay, and these 2 are exhausted. Then what is my next essential? AC. AC mein these 2 are also exhausted. Next is BD. BD mein these are exhausted. So dear, listen to me. When you take these 3 EPIs, see, all of the minterms are exhausted, na? So when you add these 3 API, you get the complete function, reduced form of the function. You don't need any non-essential PI here. So what about CD? That is RPI. Here it is equal to the RPI. Clear? Here it is equal to the RPI. Here it is equal to RPI. Out of the non-essential also it is IPI. It is not to be selected. Clear? Okay. So there is no SPI here. There is only RPI. But that's okay. That's okay. Chalo. Okay, a quick logic gates revision, guys. So I think we should not spend much time on the basic logic gates, but I'm discussing logic gates especially, for 2 reasons, especially for the biggest reason. Let me tell you, actually, the NAND and NOR, the universal gate theory. Okay. Otherwise, what is NOT gate, AND gate, everybody knows there. Isme kya revise karna hai? But just I have taken the slides so that I told you, this PDF will be short notes also. This PDF will also be a short notes for you. So whenever you go through the PDF, your notes will be complete at least. Okay, your notes will be complete. Okay, your notes will be completed. Okay. Your notes will be completed. And that is why I am taking the logic gates. Otherwise, basic logic gates pe dhyan nahi dena hai zyada, because you know it already. Okay, like F. This produces F, which is complement of A. Okay, so if I write down their truth table, if A is 0, F will be 1. If A is 1, F will be 0. Everybody knows it. Okay. Nahi, adding, why to add RPI? If you intentionally add RPI, that means you are losing the intent of the problem, Vignesh. We want to reduce a problem. We want to minimize a function. So if it is possible to minimize by 3 terms only, why you are taking the 4th extra term? Redundant ka matlab hota hai something which can be reduced. So why you are taking? The logic is not clear, na? So please don't add RPI. It is only SPI. It is only EPI. Here, it is only EPI. Clear, Vignesh? समेशन ऑफ ईपीआई 0 क्यों आएगा पूर्णी? नो 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 नो, ठीक है जी. चलो, so then we have the basic AND gate which multiplies f which is equal to a into b. Okay, only when both a and b are high, output will be high. Otherwise, if any of the input is 0, output will be 0. Okay, ठीक है. Then similarly f, we have it as a plus b. F we have it as a plus b. Okay, f we have it as a plus b, and you know, if any of the variable is high, if any of the variable is high, 1 plus anything is 1. So if any of the variable is high, output will be high. Only 0 plus 0 will be 0. Okay, chaliye. Then XOR. Chalo, XOR. Then basically I'm telling you, na, main intent is coming to NAND and NOR basically. The main intent is going towards NAND and NOR. So jaldi se uske taraf bhi jayenge. So what is the XOR gate for 2 input? Okay, it is the gate which produces high output when both the inputs are different basically. Okay, both the input bits are different, and that is why it is also known as an inequality detector. Inequality detector, and see anti-coincidence gate or simply exclusive OR gate. Okay, exclusive OR gates when both the inputs are different, 0 1 or 1 0. Okay, output is high. When both the inputs are same, 0 0 पे 0 है, 1 1 पे 0 है. That is why inequality detector. Okay, and now we know how to read the truth table. Okay, now we know how to read the truth table. Okay, ठीक है. ठीक है. Dot is not there. Dot तो था ना. Then it is a buffer simply. Achha, you are asking that doubt, Ashok. Then it is a simply buffer. Okay. So chalo. So what is this? This is 0 1 a bar b, 1 0 a b bar. So we have a bar b plus a b bar. Simple expression. A bar b plus a b bar. This is the logic symbol for the exclusive OR gate. Okay. Now, yeah, aptly and maths will also come. Don't worry. Aptly and maths will also come. And just a second, I should update you one more thing. Don't worry. Aptly and maths will also be coming for you. Just a moment. Okay, so those who are worried ki where you will get the PDF, okay, it will be in the Telegram. It will be in my Telegram group. I have shared the link. You can join it up. I'll try to share the PDF by tonight only. Okay, and the PDF will be password protected. What is the password? Stay tuned. I can tell any time. I only want those who are listening dedicatedly, completely. If I am putting the energy for 5 hours or 6 hours or 7 hours, itna lage. Okay, only the dedicated students who are ready to put the same energy, okay, they'll get the password anytime. Anytime. I don't know, maybe after 10 minutes, maybe after 2 hours. कभी भी बता सकता हूँ मैं. Okay. कभी भी बता सकता हूँ मैं. Okay, so that PDF will have the password, but where you are going to find the PDF, that I have shared with you. ठीक है. But I want, if I am putting the effort for n number of hours, okay, I want the students putting the effort for n number of hours. Then only my effort, I think, is satisfied and fulfilled. चलिए. Okay, so this is the logic symbol for XOR. Now, with respect to XOR, guys, the basic properties that you should always remember. Suppose I ask you what is X XOR X. But it is like equal inputs, na, X and X. Okay, for equal inputs, XOR will give the 0 output. But if I ask you what is X XOR X bar, so X and X bar are always different, and for different inputs, it is going to produce 1. It is going to produce 1. ठीक है? अच्छा. X XOR 0, ये कितना होना चाहिए, and X XOR 1 कितना होना चाहिए? Yes, I'll take EMFT and control. Control system, guys, Wednesday. Schedule मैंने बता दिया था. Control system Wednesday I am coming live. Okay. For control system I am coming live on Wednesday. तो ठीक है, X XOR 0 पे आते हैं. Okay, what is X XOR 0? Dear, X into 0 bar plus X bar into 0. तो 0 bar हो जाएगा 1. X into 1 will be equal to X. Similarly, X XOR 1. What is X XOR 1? X into 1 bar plus X bar into 1. तो 1 bar 0 हो जाएगा. X bar into 1 will be left. That is X bar. Okay. This is also a way to define an inverter. Okay, to define an inverter through the XOR gate. I mean, if you take a XOR gate, okay, feed one of the input as X and feed another input as VCC, that is logic high. Okay, you get X bar, and that is how you build an inverter using XOR gate. Inverter using XOR gate. Clear? X XOR 1 is X bar. Okay. Now there can be multi-input XOR gate. Those who are looking about odd number detection, some of you I was some of you were looking about the odd parity concept and odd number detector. Here it is. Okay. Okay. So the output of n input XOR gate, if it is multi-input, it can be 3 input or 4 input or 5 input. Okay, the output of n input XOR gate is high if the input string contains odd number of ones. If the input string contains odd number of ones. Okay. Whenever the input string contains odd number of ones. Okay. So देखो, let's understand with respect to 3 input. Telegram link अभी मैंने share किया ना, Vishwajit, just now I shared 2 minutes back. So suppose let me explain you with respect to 3 input XOR gate. Okay, so suppose there are 3 inputs A, B, C, and there is the output of the XOR gate which is F. Let's understand with the truth table basically. Okay, so now the input string should contain total odd number of ones. So total number of ones count कीजिए यहाँ पे. How many? 0. Okay, the output will be 0. But 0, 0, 1, how many total ones? Okay, 1. 0, 1, 0, how many total ones? Ones. 0, 1, 1. 0, 1, 1, how many ones? 2. 2 is an even number. Okay, 1, 0, 0. In 1, 0 also, how many total ones? 1. 1, 0, 1. 2 ones. Okay, so जहाँ पे 2 है, that is an even number. 0 is also counted as even. 1, 1, 0, how many ones? 2 ones. Again dear, 1, 1, 1. 1, 1, 1 means how many ones? How many ones? 3 ones. Okay, so wherever you have odd number of ones, like 1 or 3, output is taken as high. Okay, so output is high here, high here, high here, and high here. That means, remember the golden numbers, very important 3 input XOR, because you are going to see it at many places. Okay, F is known as summation of the minterms. 1, 2, then you have 1, 0, 0, which is 4, then 1, 1, 1, which is 7. Name one very important circuit whose output is 3 input XOR gate. Chalo bataiye. Name one very important XOR, a very important combinational circuit whose output is equal to 3 input XOR. चलो बताइए ना, थोड़ा तो पता ही होगा ना. This is not majority. Majority is something different. वो भी आएगा आगे. Majority circuit also I will explain you. Full adder basically. Full adder, not even half adder. It is the, मैं 3 input की बात कर रहा हूँ ना. Full adder, some output. Clear? चलो ठीक है. So this is done. Okay, now you can expand in the canonical SOP form also. A bar, B bar, C. Okay, that is 0, 0, 1, 0, 1, 0, A bar, B, C bar, 1, 0, 0, A, B bar, C bar, 1, 1, 1, A, B, C. Acha, important point here is, if you take the help of K-map here, okay, this expression which is obtained from truth table, that is a canonical expression. Can you simplify it? Okay, can you simplify it? So just please fill the minterms. 0, 1, 2, 3, 4, 5, 6, 7. Can you simplify? You cannot simplify actually. You cannot simplify this actually because there is no adjacency. I told you that diagonal does not mean adjacent. Okay, diagonal adjacency kabhi nahi lete. Adjacency means either horizontal or vertical. Okay, can't be reduced. No groupings are possible. So this function can't be reduced. That is the last answer. For 3 input XOR, that is the last answer. This cannot be reduced also. Clear? This cannot be reduced also. This expression can't be reduced. Clear? Okay, clear? Chalo, done. Okay. Yes, Vikram. Now, if I want to also revise the XNOR gate. Okay, so 2 input XNOR gate which produces the high output when both the inputs are same. Okay, this is just the opposite. Okay, inversion of the XOR, opposite of XOR, known as equality detector. When both the inputs are, 2 inputs से start कर रहे हैं क्योंकि when both the inputs are equal or same, the output will be high. So equality, coincidence gate, when both the inputs coincide. Equivalence gate, when both the inputs are equal, so it has different names, simply known as exclusive NOR gate. Okay, so have a look into it. Whenever both the inputs are same, that is 0, 0 or 1, 1, the output is high, otherwise the output is 0. So 0, 0 bole to A bar, B bar, 1, 1 bole to AB, that is a logic function. Okay, A bar, B bar plus AB, and that is a basic logic symbol. Okay, and again with respect to XNOR, some properties, देखो X, XNOR X, 0, sorry, 1 hoga because it is the same. X, XNOR X bar different. The different pe XNOR will not produce high output. Similarly, X, XNOR 0 here will be X bar. And X, XNOR 1 will be X. So, inverter using a XNOR. to define an inverter using XNOR, one of the variable is X, another variable is grounded. Okay, this produces X bar and this is the inverter. This is the inverter using the XNOR. Okay. Chalo. If I want to talk about the multi-input, okay. If I want to talk about the multi-input case, okay, the output of n input XNOR gate is high if the input string contains even number of ones. If the input string contains even number of ones. Okay, so XOR gate detects odd number of ones in the input. XNOR gate detects the even number of ones in the input. Detects the even number of ones in the input. Have a look into it. Have a look into it. Detects the even number of ones in the input. It detects the even number of one in the input. Okay. Okay. Correct. Even number of ones. Have a look into it. Okay. Even number of ones. Okay. So 0, 0, 0. It is 0. Correct. 0, 0, 1. 1. 0, 1, 1. 0, 1, 0. How many ones? 1. 0, 1, 1. How many ones? 2. 2 is even. 1, 0, 0. Single one. 1, 0, 1. Again. 2 ones. 2 is even. 1, 1, 0. Again. 2 ones. Okay. 1, 1, 1. 3 ones. So wherever you have even numbers, including 0. Okay. So see. Output is high. Here also output is high. 1, 0, 1 output high, 1, 1, 0 output high. Okay. So what is this function equivalent to in the form of minterm list? Definitely it is 0. Then what do you next have? This is 0, 1, 1. This is known as 3. Okay. Then you have 1, 0, 1, 5. And then you have 1, 1, 0. That is 6. It's just opposite to XOR. Na? XOR had 1, 2, 4, 7. Other than 1, 2, 4, 7. Other than 1, 2, 4, 7. Okay. This cannot be reduced again. Okay. So that means what is the final answer here? 0, 0, 0. I'll write it here separately. A bar, B bar, C bar. Okay, next what do you have? 0, 1, 1. A bar, B, C. Next what do you have? 5. That is 1, 0, 1. A, B bar, C. And next is A, B, C bar. Next is known as the A, B, C bar. Okay. ABC bar. Chalo done. This is the multi-input or 3-input XNOR gate. Clear? The 3-input XNOR gate. Chalo. Now the main thing. Okay, the main thing for which I basically took up the discussion of logic gates. I told you otherwise logic gates you can study easily. Okay, you can study easily. Look into it. NAND and NOR. Okay, the NAND and NOR. Okay, the NAND and NOR. Okay, that too, not directly NAND and NOR, but how to implement the functions using NAND NOR. That is an important area jahan se questions aate hain. Okay, so that area we are going to discuss today. Okay, this is the basic logic symbol of NAND gate which performs the operation complement of that of AND. That is AB whole bar. That is AB whole bar. Okay, so if any of the input is 0, A into B will produce 0, so complement will produce 1. If both inputs are 1, 1 into 1 is 1, complement will become 0. Okay, this is the truth table for the AB whole bar. Yes, universal gate theory, correct. Okay, this is known as the AB whole bar. Okay, truth table also just complement of what do you see in the AND gate. Okay, similarly you will have the NOR gate which produces the complement of that of OR gate, A plus B whole bar, A plus B whole bar. Okay, so that is basically how much? A plus B whole bar. So if any of the input is 1, 1 plus anything is 1, so complement will become 0. 0 plus 0 is 0. After taking the complement it should be 1. It should be 1, correct? Done. So this is done. Okay, this is A plus B whole bar. This is known as what? This is known as the A plus B whole bar. Okay, ji. Moving ahead to the next. Okay, now why? How you can realize NAND and NOR as a universal gate? See, we know that NAND and NOR are universal gates. Okay, so if they are universal gate, okay, they should be able to implement all the 3 basic functionalities. That is inversion, okay, product and addition. Inversion, product and addition. Okay, so there is an important question coming up here. Chalo, let us discuss that also parallelly. Nishu is asking, NAND and NOR, are they associative or not? Please tell me, then I'll explain you. Yes, guys, NAND and NOR, whether they are associative or not. Very important point. Whether they are associative or not. पहले इसको समझ लेते हैं. By the time you also answer. Associative or not? Yes or no बता दीजिए. Okay, yes or no बता दीजिए, then I'll explain you. Okay, so suppose if this is a NAND gate with both the inputs shorted. NAND gates with both the inputs shorted will behave as an inverter. Okay, so this is what? A into A whole bar, and that is basically A bar because A into A is A, na? So this is an inverter. This is an inverter. Okay. Now look into this next case. A into B first fed to a NAND gate. Okay, that produces AB whole bar. Now a NAND gate with both inputs shorted. A NAND gate with both the inputs shorted will behave as an inverter again. Inverter will invert AB whole bar. AB whole bar ka bar. Here what you are going to get is AB whole bar ka bar and complement cancel, double negation case. So answer is going to be AB. This answer is going to be what? This answer is going to be AB. Perfect ho gaya. This is going to be the AB. Okay, so this is an AND gate. This is the realization of AND gate. Okay, and then you have A and B. Okay, first a NAND gate with shorted input. So that will produce the inversion, A bar. Similarly, bottom side it is B bar. Now a final NAND gate. So what should be the output of NAND gate? X into Y whole bar. So what is inputs? A bar, B bar. So A bar, B bar multiplied and then whole bar. And by the De Morgan's law, it is A plus B. By the De Morgan's law, it is A plus B. That is a OR gate basically. Okay, so it is able to realize NOT AND as well as OR. It is able to realize the NOT AND and OR. Okay. And if it can realize plus, into and inversion, it can realize any Boolean function. It can realize any Boolean circuit as well, and that is why it is a universal gate. Okay, it will be able to implement any given Boolean circuit by using sufficient number of the gates. Okay. Right. Suppose now next example. Suppose sometimes ये भी question आता है. How many NAND gates are required for XOR gate? Let us understand this XOR also once. Okay. So let's treat this as the input A and B. First, commonly both they are fed to a NAND gate that produces AB whole bar. Okay. Now AB whole bar again is NANDed with A. Look into this. Okay. AB whole bar ka whole bar. X into Y whole bar. Okay. So what are the two inputs? A and AB whole bar. Similarly, चलो पहले इसको simplify कर लेते हैं. तो again apply the De Morgan's here. If you apply the De Morgan's here, it will be A bar plus AB. Okay, A bar into becomes plus AB ka bar AB. Acha, A bar plus AB. What is the answer? A bar plus AB is A bar plus B. In the beginning, I told you, not here, X plus X bar Y is X plus Y, a variable and its complement multiplied by Y. So complement is omitted, you get X plus Y. Similarly, A bar plus AB. A is the complement of A bar. So this complement will be omitted, you get A bar plus B. Boolean theorems में देख के आए थे हम इसको. Okay, so A bar plus B. Similarly, on the bottom side, what do you have? Okay, you have the NAND of B again with AB bar. So B into AB bar whole bar. This is going to be De Morgan say B bar plus AB. And B bar plus AB is like B bar plus BA. Okay, variable and its complement multiplied by A. So remove the complement, that is B, and you will get the answer B bar plus A. This is removed. B bar plus A. Okay, now again do the NAND. Okay, so this is going to be the NAND of A bar plus B multiplied by A plus B bar whole bar. X into Y whole bar. X into Y whole bar. Okay, so when you open it up here, देखो A bar into A is 0. Okay, first term A bar B bar. Okay, then B into A, that is AB. Last term B into B bar 0. Okay, so what is this? This is A XNOR B ka whole bar, and XNOR complement is XOR. So this is how XOR gate has been built using 4 number of NAND gates. Using 4 number of NAND gates. Okay. Similarly, if you use one more inverter at the output, XOR again converted to XNOR. So this is the XNOR. Okay, just one more gate here. Okay, up to this point already I explained you this is A XOR B. So this is the inverter that is going to produce XNOR. Okay, so for XNOR 5 number of gates. Okay, similar results for NOR gates. I think this is self-explanatory now. If you have any doubts, okay, this is self-explanatory now. If you have any doubts, please let me know. Otherwise, I'll just write down this is NOT. This is going to be OR. This is going to be AND. Okay, any doubts ask me, otherwise I take it as self-explanatory because it's similar to NAND. एक explain कर दिया मैंने. Okay, similarly XOR gate, you will have 5 NOR gates for XOR. Then you will have XNOR gates. Okay. ठीक है. So and this is the count. This is the count as of now. ठीक है ना? Clear है? अगर कोई doubt है तो बता देना. Otherwise that is self-explanatory. So if I talk about the NOT gate, I need each one NAND gate, one NOR gate. AND gate के लिए 2 NAND gates are required. Okay, but 3 NOR gates. For OR gate, as we have seen, 3 NAND gates, but NOR gates are minimum 2. For XOR gate, NAND gates required are 4, but NOR में 5 लगेंगे. Okay, for XOR gate, 5 number of NAND gates, as we have just explained. Similarly, for NOR, it's going to be 4. Now the point to be noted is, suppose whenever you have a SOP expression, SOP involves sum of product. So what are the basic terms in SOP? The basic terms in SOP is min terms or any other product terms. Okay. Absorption cover किया था ना? That is what absorption is, actually x plus x bar by minus v. है ना? So if you have any SOP expression, think. If you have any SOP expression, sum of product. Okay, the basic terms in the SOP are product terms, or it may be min term also if it is canonical form. But ultimately you have a product term, sum of product. If you want to realize a product term, if you want to realize what? If you want to realize the product term. If you want to realize the product term, then what is going to happen? If you want to realize the product term, which gate should be preferred? The basic terms are product. Product means represented by AND gate. So out of the NAND or NOR, which should be preferred gate? NAND, na? Because only 2 NAND gates are required. NOR पे जाओगे तो 3 लगेंगे. NOR पे जाओगे तो 3 लगेंगे. Clear everybody? So that means whenever you have SOP expressions, okay, NAND gates are preferred. Okay, NAND gates are preferred. Okay, similarly, if you have POS expressions, rest all copy. Okay, for POS, product of sum, you will prefer NOR gates. Always remember it. You will prefer the NOR gates. Okay? Clear everybody? Okay. Now chalo. Okay, there is a procedure to implement. Okay, a circuit using NAND and NOR. Okay, if you want, read it up. I will directly explain you the procedure. These notes are for you. Okay, step number 1, step number 2, step number 3, step number 4, step number 5. Okay. But before I explain you the procedure, just one thing you have to take care in the mind. Suppose I want to explain you a NAND gate. What is NAND gate, dear? What is the basic NAND gate? मैं आपको सीधे प्रोसीजर पे हिट करूंगा. Very, very important, but very simple. This is how we implement a NAND gate. And what does the NAND gate builds? It builds A into B. It produces A into B whole bar. That is what it does, na? Okay. A into B whole bar. But by De Morgan's law, dear, A into B whole bar is also known as A bar plus B bar. Okay. So what is another way of looking into NAND gate is, it can also be implemented using a OR gate because it can be built as plus. Okay, but before you use a OR gate, you have to use A bar, B bar. Means you have to complement A and B. And I will represent this complement by bubble. This is the inversion bubbles. Okay, so this is A bar, B bar going to OR gate. This is A bar, B bar. So there are two ways of looking into a NAND gate. First is, okay, AND invert. First you AND and then invert. The second way of looking into is, पहले invert कर दीजिए and then go and OR it. So that is invert OR. That is known as invert OR. That is known as what? Invert OR. Clear everybody? Okay. Now, similarly, if I want to talk about a NOR gate, what will I do? Okay, for a NOR gate, what I will do, the basic representation we have seen, let's copy that first. The basic logic symbol of NOR gate, okay, OR followed by a bubble, and this implements A plus B whole bar. But again, if you apply De Morgan's, it is A bar into B bar, right? So it can also be realized using into, and into bole to and. It can also be realized using AND gate, but the inputs to the AND gate should be not AB, it should be A bar, B bar. AB nahi lagana hai, A bar, B bar, and again to build the complement, I'm using this inversion bubbles. Okay, A bar multiplied by B bar. Both of them are NOR. The first structure is known as, okay, the first structure will be known as OR invert. First you OR and then invert. और नेक्स्ट पॉसिबिलिटी इज कि डियर पहले इन्वर्ट कर दीजिए और देन एंड कीजिए. इट इज इन्वर्ट एंड. It is invert and. It is known as the invert and. It is known as invert and. Clear everybody? Done hai ji. This is invert and. So let's move ahead to the next. ठीक है, invert and. Now, before I build any big question, तो देखो मैंने यही यहाँ पे बोला है, to represent any circuit using NAND gates, what you can do, place the inversion bubble at the AND gate output. Suppose you are given an AND gate, अगर output में bubble लगाया, तो it becomes a NAND gate. और suppose you are given an OR gate, okay, so you place the bubbles at the input. In a circuit, you may be given AND gates and OR gates, or both of them. Whenever you have AND gate, place the bubble at the output. It is an AND gate. But suppose in the circuit you are given an OR gate, then also you can convert to NAND. How do you convert to NAND? Place the bubbles at the input. Because that's what I was explaining you, that both of them are NAND gates, isn't it? Both of them are NAND gates. ये भी तो NAND है, ये भी NAND है, ये भी NAND है. Everybody please look into it. Similarly, if the question is implementing a circuit using NOR gates, that was NAND. Implementing a circuit using NOR, तो place the bubbles where? OR gate के output पे bubble लगा देंगे. This is also NOR, everybody. And if AND gate is given in the circuit, wherever AND gate is given in the circuit, place the bubbles at the input. That is also a NOR gate. Both of them are NOR gate. That is the first thing I have explained you. Both of them are equal to the NOR gates. Both of them are equal to what? Are equal to the NOR gates. Clear hai? Hope it is clear. Both of them are equal to the NOR gates. ठीक है? Now, what is the next theory? Let's explain through a question. Let's not be theoretical. Approach समझाता हूँ मैं. Step number 3, 4, 5 ना. I'll explain you the approach. Suppose there is a circuit given to you with some number of AND OR gates. Okay. Suppose there is a circuit given to you. ठीक है? Yes, Vikram. The number of NAND gates required to implement the following circuit is how much? Number of NAND gates required to implement the following circuit is how much? Okay. This question is given in the form of AND OR circuits and I want the number of NAND gates. Of course, the question basic meaning is minimum number of NAND gates. ठीक है? अच्छा, if nothing is mentioned, assume that the variables are available only in the true form. I'll write down this important condition. Assume that the variables are available only in the true form. Assume that the variables are available only in the true form. Only in the true form. ठीक है? चलो, so what is the way? Okay, wherever I see a AND gate, dear, I will place the bubbles where? At the output. AND के output पे bubble. Again AND gate, output bubble. That's it. Wherever I have a OR gate, I will place the bubbles at the input. Okay. I will place the bubbles at the input. ठीक है, this is done. Now, this is also a NAND gate. This is a NAND gate. Bubbled input के साथ OR gate. That is also a NAND gate. अच्छा, sorry. This is 2. Then this is 3. And this is 4. As of now, 4 are there. Okay, but you are placing a bubble. Physically, what does it mean? यहाँ तो आपने diagram में place किया. Physically, a bubble means an inverter. You are introducing an inverter within a circuit that can spoil the functionality. I mean, that can change the functionality. Spoil नहीं बोलूँगा. That can change the functionality. You have to implement the same function. You should not be changing the functionality. To implement the same function, how many NAND gates are required? But because you are placing inverters in between, that has the possibility of changing the logic of the circuit. But look into this path, dear. Now, very important point is look into this path. You have placed two bubbles in series. Bubbles means inverters in series. Inverter in series. They cancel each other. Inverter in series. मैंने बोला था ना step number 3, 4, 5. I am explaining them orally. Okay. So whenever bubble automatically comes in series, they cancel each other. So don't worry about them. You have introduced two inverters, but they cancel their logic operation. I mean, suppose the output here was F. Okay. Output after the bubble F bar. Output after another bubble F hoga na. Output after the next bubble will be F only na. So what does it mean? You are getting F here, you still get F. You don't need to do anything. You can place two bubbles in series, okay, without changing the logic of the function. Without changing the logic of the function. ठीक है जी? Without changing the logic of the function. Next चलते हैं. Okay, next चलते हैं. Okay, anywhere else you have inversion automatically happening? No. Okay, so now this is an extra inverter. This is an extra bubble. So what will you do with the extra bubble? Okay, to complement this extra bubble, dear, you have to place here an extra inverter. You have to place here extra inverter, and one inverter is equivalent to one NAND gate. One inverter is equivalent to one NAND gate. Everything to NAND gate only. Okay, NAND gate only. Okay, so one more inverter here. So 1, 2, 3, 4, and this is your count number 5. Fifth NAND gate coming up. Fifth NAND gate coming up. Similarly, now don't draw everywhere. हर जगह draw नहीं करेंगे. Look into this. Here also one more inverter needed. Number 6. I'll just write down the count. Here also, ये चलो first question है तो यहाँ पे मैं बना देता हूँ. But actually you should just count. This is also one more inverter. Number 6 coming up. Here also one more inverter needed. Number 7 coming up. Answer should be dear 7. Some of you were telling 6. Some of you were telling 8. Answer 7 हुआ. 8. अच्छा sorry हाँ 8th है ना. I am sorry हाँ. One more is here. Correct answer 8. Those you are telling 8. The correct answer is 8. Yeah, perfect. Correct answer is here not needed. Here not needed. Okay. Simple story is place the bubbles. If two bubbles in series, they cancel each other. Nothing to be done. But if by chance there are single bubbles left, okay, you have to complement it. You have to add an extra inverter. That means you increase the count by 1. You increase the count by 1. Clear everybody? You have to increase the count by 1. क्या हुआ dear? Everybody getting tired क्या? Attendance dropping. Baba, only this much you want? Stop. Tell me when to stop. I will stop. Tell me when to stop. I will stop. No problem. ठीक है. Look into this. Next question. Assuming that the inputs are available only in the true form, that's what I told you. Okay. Number of two input NOR gates. Again, this is the question, but non-NOR gates. Okay. Number, of course, means minimum number. The minimum number of two input NOR gates required to implement the following circuit. The number of two input NOR gates required to implement the following circuit. The following circuit. Number of two input NOR gates required to implement the following circuit. Okay. Implement the following circuit. Tell me. I'm now using NOR gates. Okay. Using the NOR gates. So let's do it quickly. Okay. Let's do it quickly. Chalo. So what is it? Okay. NOR gates में convert करना तो where to place the bubble? At all the OR gate output. At all the OR gate output. I have placed the bubbles. Okay. Okay. I have placed the bubbles. Place the bubbles at all the OR gate output. 1, 2, 3. Wherever there is AND gate, place the bubbles at the input side. AND gate, input bubble. Everything is done now. Okay. Everything is done now. Okay, now look into it. This is number 1, this is number 2, number 3, number 4, number 5. All of these are NOR gates. Okay, all of these are NOR gates. Okay, now automatically series, so you don't need to do anything. They cancel each other. Here it is alone. So here there will be a 6th. I'm not drawing now, but I'm just writing there will be a 6th gate here. Okay, this is again series. No problem. This is also series. Okay, no problem. Okay, so only 6 here. Answer is 6. Answer here is 6. Answer here is 6. Clear everybody? Answer here is 6. Okay. Answer here is 6. And previous का answer भी लिख दे. The previous answer was 8. ठीक है जी? Yeah, it is 7. Sorry यार. देखो. Look into this B bar. Okay, now there comes the very important point. Okay, there comes the very important point. Okay, assuming that the inputs are available only in the true form. What does it mean? Assuming that the inputs are available only in the true form. Okay, only in the true form. That means B bar is not available. Okay, this B bar is not available, and to generate B, okay, you will again use an inverter. Okay, using a NOR gate. One inverter is one NOR gate. That will be fed here. That is B bar. Clear? That is B bar. So this is number 7. That's what the very important thing I told you in the beginning only. Na? Assuming that the inputs are available only in the true form. only in the true form. Only in the true form. So if you need the complement of any input by chance, that also has to be generated using an extra inverter. That is one more NOR gate. Okay, 7. Okay, perfect answer is 7. Okay, next question, dear. Now, the Boolean function y equal to a plus bc is to be implemented using two input gates of only one type. कौन सा gate है ये नहीं बोला है. The Boolean function a plus bc is to be implemented using two input gates of only one type. Okay, what is the minimum number of gates required? Which one type? Which one type? Tell me. Which one type it should be? Can you tell me, please? Okay. Of only one type. So which one type? That you are going to tell me. देखो, it is clearly, देखो, BC product term, then added with something. Okay, sum of product. So which one type? Prefer NAND. Prefer NAND. But before you draw the NAND circuit also, you have to go for the basic circuit using AND OR gates. Using the AND OR gates. Okay, so A plus BC. Okay, A, B, C. B and C are ANDed. So there comes an AND gate. And this has to be ORed with A. Okay, A plus BC is going to come up here. Okay. A plus BC is going to come up here. Okay, this is the output F. This is the output F. Okay, now this is the basic logic circuit diagram. Okay, now what to do? Now what to do? Again apply the bubbles method. Again apply the bubbles method. Output में NAND gate है ना, AND के output पे bubble and OR के input पे bubble. This is NAND gate number 1, this is NAND gate number 2. Okay, then you have these two in series, so don't need to do anything but one extra bubble. One extra bubble means on this path there will be one more gate. Answer is 3. So which gate type not mentioned, so you can prefer NAND, na? That's what you must be knowing. You can prefer NAND. Clear, everybody? You can prefer 3. ठीक है. NOR से करके देखिए, answer will be more. Try with NOR, answer will be more. That is why the question is minimum number of gates. Okay, minimum, because it is SOP, minimum will be obtained by NAND. NOR say you can build, but that will not be the minimum, that will not be the reduced answer. Clear, everybody? Chalo. Now next question. Okay, now with respect to logic gates, let us cover one more variety of question, that is with respect to delays. Okay, that is with respect to delays. Okay, delay based question. All the logic gates, very simple question but delay based है, तो थोड़ा सा इसको भी मैं cover करूँगा. Okay. ठीक है. All the logic gates shown in the figure have a propagation delay of 20 nanoseconds. Okay. Let A equal to C equal to 0 and B equal to 1 until time t equal to 0. At t equal to 0, all the inputs will flip and remain in that state. The output Z equal to 1 for how much duration? Okay. Output Z equal to 1 for how much duration? Let's see if you need a break. I will give you. Don't worry. थोड़ा सा और बढ़ते हैं अभी इतना जल्दी नहीं. थोड़ा सा और बढ़ते हैं. Okay. So now see, the output Z equal to 1 for how much duration? Output Z equal to 1 for how much duration? So initially given है, let A equal to C equal to 0 and B equal to 1 until time t equal to 0. So let me draw A and C first. Okay. Let us very carefully draw the A and C first. Okay. A and C. Until t equal to 0. So ये t equal to 0 का थोड़ा सा lining भी बना लेते हैं. Let us say this is t equal to 0. Okay. Let me start with A and C waveform. A and C are 0 until t equal to 0 and then they flip. Okay. Similarly, C is 0 and then they flip, and flip after that remain in the same state. After that they remain in the same state. Okay. At t equal to 0, all the inputs will flip and then remain in the same state. But what about B? B equal to 1 until time t equal to 0. B equal to 1 until time t equal to 0 and then it flips. Then it is going to remain in 0 state. Okay? Chalo, next. Now let us understand the circuit. First of all, विथ रिस्पेक्ट टू बी, चलो एक काम करेंगे बेटर, विथ रिस्पेक्ट टू बी ना, हाँ, ये कौन सा इनपुट है, हाँ बी है, करेक्ट है। ठीक है, with respect to b, let me draw the b bar here. The basic idea of solving the question based on delay is drawing the output waveform for every logic gate separately. Drawing the output waveform for every logic gate separately. Okay, now all the propagation delays are 20. Okay, all the gates propagation delay of 20 nanoseconds. Okay, so this also has delay of 20, this also has delay of 20, this also has a delay of 20, all are in nanoseconds. ठीक है, yeah, it is in CSE syllabus also. CSE में इससे related question पूछे गए हैं. It is just a logic gate question but with basic delay. Okay, so it is totally there in CS. If something is not there in CS, I will tell you. उसको मैं अलग से बता दूंगा आपको. ठीक है, so have a look into it. ठीक है, this is done. Clear? Okay, so now यहाँ पे आ जाते हैं B bar. Okay, let us come to the B bar. Okay, so B starts with 0, B bar will start with 1 automatically. Then it will complement and then it is going to remain in state 1. This is the B bar waveform. After the B bar waveform, you should draw the AND gate output separately. Okay, what is this AND gate output? Suppose the AND gate output is, isko Z bola hai. Suppose this is X and that is A into B bar. Let us draw A into B bar separately. Then we will use the XOR gate. Okay, A into B bar. अच्छा नहीं, sorry, मैंने थोड़ा सा जल्दबाजी कर दिया. Just a second. Even the inverter has a delay, na? Even the inverter has a delay. So listen to me. Listen to me. The point here is, okay, B starts from 1. So B bar will start from 0. It is going to flip. It is going to invert. Okay, it is going to invert. But after a delay, na, how much delay? 20 nanoseconds. Okay, after the delay, that is equal to the 20 nanoseconds. Okay, so let me first draw a 20 nanoseconds line. Say this is time corresponding to 20 nanoseconds. Okay. So after 20 nanoseconds, it will flip. That is what is the meaning of a gate being having delay. Na? After 20 nanoseconds, it will give the response. Response means it will flip the input. It will flip the input. It will flip the input. Clear, everybody? It will flip the input. Okay, so B now becomes 1. It was initially 0, now becomes 1 after 20. This is 20, this is 0 nanoseconds. This is the beginning. Okay. Chalo, now I have B bar waveform. Now I will multiply A and B bar. I will multiply A and B bar. Now AND gate operation है ये देखना. A and B bar. Initially both are 0. Initially both are 0. So output will be 0. So now I am drawing the X waveform, dear. Now I am going to draw the X waveform. Initially A and B bar are both 0. The output will also start by 0. 0 into 0 is 0. Okay, dear. 0 into 0 will be 0. But now look into this, guys. Look into this very carefully. Just concentration is required here. This is 0. This is 1. Okay, 1 into 0, still 0. AND gate, hai na? 1 into 0, still 0. Continue, 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 continue. Now come here. This is also 1. This is also 1. Both of them are 1. What is 1 into 1? 1 into 1 is 1. So AND gate output should be 1. But again, AND gate has a delay of 20 nanoseconds. So AND gate output will also be 1. But from here, 20 nanoseconds. From here, 20 nanoseconds. So let me draw another. This is 20. This is another 20 nanoseconds. This is another 20 nanoseconds, dear. Effectively, this becomes 40. Effectively, it is 40. So after another 20 nanoseconds, okay, the output of AND gate will become 1. Because 1 into 1 is 1. Everybody, 1 into 1 is 1. After that, both are continuously 1. Both are continuously 1. So 1 and 1 is 1. Okay, so this output X will remain to be 1. Okay, will remain to be 1. Okay. Now, dear, next is the Z waveform, which is the XOR of. Which is the XOR of. How will you realize Z? Take Z, XOR of X. That is why I have X separately for you. XOR with the variable C. XOR with the variable C. Okay. So now you have to see X XOR C. X XOR C. Initially both are 0. Initially both are 0. XOR will produce high output when both the inputs are different. So initially they are equal. Equal pe low output. Okay. Z will start with low output only. Okay. Okay. Now look into this, guys. This is 1. This is 0. X और C को देखना है. Okay, this is 0, this is 1. 0 and 1 different. Different means high output. Different means high output. But XOR also takes a delay of 20 nanoseconds, na? 20 nanoseconds, na? Okay, so delay means after 20 nanoseconds, XOR will produce high output. After 20 nanoseconds, XOR will produce the high output. Here at 20 nanoseconds, XOR output is high. Okay, so 1 XOR 0 is high. Here also 1 XOR 0 high. But dear, look into here. 1 and 1. Now they become same. Look into this 1 and 1. Look into C and X. Okay, they become 1. Okay, they become 1. 1 XOR 1, output will be 0. Output will start becoming 0, but it will become 0 after 20 more nanoseconds. After 20 more nanoseconds. Okay, तो ये एक 20 nanoseconds का mark और बना लेंगे 40 plus 20. Okay, the effective time will be 60 basically. Okay, this effective time is now 60, and at this point of time, output is now going to become 0 because of 1 and 1. Same pe XOR will produce 0 output, and now both are 1 and 1. 1 and 1. 1 and 1. So 1 and 1 XOR is always 0, so output will remain to be 0. That is the Z waveform. That is why the output is high for a particular time. How much time? That was the question. Okay, output is equal to high for ये 60 and 20. It starts from 20, ends at 60. Okay, 60 minus 20. The answer is 40 nanoseconds. Clear? Output is equal to high for 40 nanoseconds. Okay, NAT question, output remains high for 40 nanoseconds. Okay. So Nishu, basically maybe waveform or maybe some information about the input will be given to you. Like in this question, I have given you the information. Okay. Okay, I have given you the information. Ki A and C 0 and B equal to 1. It's for initial time. After that they flip. If that information is not given, they can give the direct waveform also. Okay, but something will be given either in words or either in the form of waveform. Kuch to hoga. Nahi, Vishwajit, the logic delay based questions, okay, they have to be taken step by step only. Don't worry, like other problems, if there is a shortcut, I will help you with the shortcut. Don't worry. Okay, but यहाँ पे ये step by step procedure ही होगा. Slightly time taking, but with practice, you will become fast. With practice, you will become fast. Okay, so guys, just a quick reminder about the schedule. Okay, today we are learning the digital electronics. Tomorrow, 10 a.m. you will have analog circuits, and analog circuits will be taken by one and only all your favorite Sanjay sir. Sanjay Rati sir will be taking analog circuits revision marathon tomorrow. Okay? Also guys, as I told you, there will be daily quiz. Okay, there will be a daily quiz. Okay, and now you have to attempt the quiz in the evening. Okay, you will be attempting the quiz in the evening. Okay, how will you join the quiz? I'll give you a basic idea about it. How do you join the quiz? Okay, you can join the quiz using the link which is mentioned here, or you can scan this QR code. You can just scan this QR code. Dear, you can just scan this QR code. You will be redirected to the quiz page. But don't start the quiz right now. If you won't start, then you will lose the session. Okay. Then you will lose the session. Okay, but I am telling you na, daily class, daily quiz and PYQs. अगर आपने इतना किया ना, and past also you have not done much, but starting from today also, daily revision class, daily quiz and PYQ. Still you will become decent. You will become comfortable. Okay, you will become comfortable. यहाँ तो स्कैन कर लीजिए क्यूआर कोड को. नहीं अभी ब्रेक नहीं हुआ है. Or either you can join using the link. You can join using the link. In case you are first time going to the BYJU'S app or BYJU'S website, it will ask you for a sign in. Sign in करके रख लो अभी से. Okay, if you want, you can sign in right now so that at least after the class you can attempt the quiz. Okay. Yes, definitely Gautam. Okay. ठीक है dear. So you can attempt the daily quiz using this link. Okay, if you want, just go to the link, see if it is working file for you, but don't start the quiz right now, because otherwise you will lose the session otherwise. But still, that can be your call whether you want to be in the session right now or go to the quiz. Take care. So this is what you can scan also directly. Telegram link already I shared. I'll share you one more time. Don't worry. Telegram pe you will get the PDF. Don't worry. In the Telegram you shall be getting the PDF. PDF I will share you by end of the day. Chalo, this is the Telegram link. Okay, this is what the Telegram link is. Clear? Okay. Also, one more important thing before we move ahead. Okay. Yes, here it is. Okay, guys, Wednesday. That is 10th of January. I'm sorry. Wednesday, 10th of January. All your favorite. Okay, Abhinav Negi sir. At 7:30 p.m. again on the BYJU'S exam prep app. Okay, so multiple activities on the app like quiz and other things also. Okay, how to ace gate 25 in the first attempt. It's a complete full-fledged detailed workshop, okay, by all your favorite. How to conquer gate 25, that too in the first attempt. Sir is going to be live on the BYJU'S app at 7:30 p.m. 10th of January, Wednesday. Okay, so you can attempt if you're looking for the perfect guidance for gate 25. And also guys, on 14th of January, sorry, it's a date to be corrected here. Okay, you can also appear in the National Scholarship Test for the BYJU'S exam prep, and with the help of this National Scholarship Test, you can get as much as up to 90% scholarships on the GATE and Engineering Services preparation courses. GATE and Engineering Services preparation courses. ठीक है? चलो. Dear, some of you are having the confusion. अभी lunch break नहीं हुआ है. अभी थोड़ा सा और पढ़ेंगे. After some time, I will give you lunch break. Definitely, I will give, because it's going to take time. I know it's going to take time. It's not going to stop right now. Okay, it's going to take time. So don't worry. I'll give you lunch break. Okay. Otherwise, तो बहुत दिक्कत होगा. But not immediately. So let's learn something, some more fundamentals. After some time, I will give you a break. Okay. After some time, I'll give you a break. Half adder. Okay, which is able to add two single binary digits. Okay, say for example, you're just adding 2 bits, A and B. Okay, now we know that, okay, 0 plus 0 will produce 0. If it is 0 plus 1, now we are talking about mathematical addition, not logical OR. It is a mathematical addition. Okay, 1 plus 0 is also equivalent to 1, but 1 plus 1, okay, agar decimal ki baat kare, that is 2. In binary, it is 1, 0. So when you add 1 plus 1, it is going to produce a 2-bit output. Okay, it is going to produce a 2-bit output. Okay, where this is known as the sum. By how do you see? Suppose decimal mein bhi agar aa jaye, you have 17 and 28, 2 numbers to be added. Okay, so 8 plus 7 is 15. Okay, 8 plus 7 is 15. You write down 5 as the sum and 1 goes to the carry. Correct. This is what is the sum. This is what is the carry. Correct, na? Okay. Okay. Then carry is added with the next 8. 1 plus 1 plus 2, that is equal to 4. The answer is 45. Okay. So similarly, when the answer is 1, 0, out of this 1, 0, this 1 is known as the sum bit and this is known as the carry bit. Clear? Okay. And accordingly, we should have 2 outputs whenever we are designing an adder. There should be sum and carry. There should be sum and carry. Okay. But there is no carry in the first 3 stages. Okay. So again, the 2 inputs, 4 possibilities, 0, 0, 0, 1, 1, 0, 1, 1. In the first 3 stages, there is no carry. Okay, sum is 0, then 1, then 1. Last stage 1 plus 1. The sum is 0, carry will be equal to 1. Sum is 0, carry will be equal to 1. Clear? Sum is 0, carry will be equal to 1. And then very easily you can name this Boolean functions. What is the sum equivalent to? Dear, what is the sum equivalent to? Okay, the sum is equal to high when both the bits are different. 0, 1 and 1, 0. Okay, 0, 1 and 1, 0. So definitely the sum variable is nothing but that is equal to A XOR B. Okay, that is A bar B plus AB bar. And carry variable, let me call the carry as C out basically, and the carry will be given as the carry going out to the next stage, and the carry can be written as carry is high only when both the inputs are 1, 1. Okay, only when both the inputs are 1, 1. That is basic AND gate. That is A into B. That is a very basic AND gate, A into B. Clear? Clear? So, if I want to just implement a logic circuit, it calls for a very simple logic circuit. You have a 2 inputs A and B fed to a 2 input XOR gate, and this is going to produce the sum variable. Same 2 inputs, when you AND them, it produces the carry output. This is what is a half adder. This is what is a half adder. Okay. But we all know, guys, half adder is adding only 2 bits of information. Suppose a decimal ka example bhi hai. Okay. 7 plus 8 is 5 and carry 1. But if you're only adding 2 bits, if you're adding only 2 at a time, so and if you use only half adder, suppose decimal se samajhte, so you will be able to add only 1 and 2, na? And only 1 and 2 will get 3. 1 plus 2 will be equal to only 3. And the answer should not be 35. Okay, so at many places you don't want to add only 2 bits. You have to add the carry coming from the previous stage. Okay, so you should actually have a circuit which is capable of adding 3 bits of the information. Which is capable of adding 3 bits of the information, not 2 bits. And the circuit for capable of adding 3 bits of information will be, of course, a full adder. Okay, that performs an addition, okay, on 3 1-bit binary numbers. Okay, and what is that? That addition is in the form of A, B, and C in. Let me call this C as C in actually. Very clear. Okay, A plus B plus C in. Okay, what is C in? Carry that may be coming from some previous stage. Carry that may be coming from previous stage. And what is A and B? A and B are actual bits to be added. They are basically the bits to be added. They are the bits to be added. Okay. Chalo. Now there is a very simple truth table presented here. Okay, so ultimately just keep adding all 3. So 0 plus 0 plus 0. 0 plus 0 plus 0. Sum 0, no carry. Just 0. 0 plus 0 plus 1. Sum 1. Okay, 0 plus 1 plus 0, it is again 1, sum equal to 1. Next, 0 plus 1 plus 1. So it's like 1 plus 1. So 1 plus 1, sum 0, carry 1, like the last example. Okay, 1 plus 0 plus 0, okay, that is only 1. That is only 1, no carry required. 1 plus 0 plus 1, so that is again like 1 plus 1. 1 plus 1, sum 0, carry 1. Again 1 plus 1 plus 0 hata denge, so 1 plus 1, sum 0, carry 1. Come to the last stage, you have 1 plus 1 plus 1. 1 plus 1 plus 1, 1, 1, 1. Okay, so 1 plus 1 is actually 3 and 3 bole to 1, 1. 3 in the decimal, but in binary it is known as 1, 1. Okay, so out of the 1, 1, this should be the sum. The lower bit is the sum. This goes to the carry. Okay, so this will be going to the carry out. Okay, so even sum is 1 and carry is 1. Both sum and carry are equal to 1, 1. Both the sum and carry are equal to the 1, 1. Both the sum and carry are equal to the 1, 1. Okay. Just a second. Yeah, let's continue. Yes, crazy world. Even for civil, marathons will be starting, I think, for tomorrow. Okay, in the civil mechanical channel, Abhinav sir and Dheeraj sir will be starting. And same thing, whether your branch is civil or like ECW or whatever, follow these marathons, attend the live quizzes and daily quizzes and solve the PYQs. Then also you can be comfortable. Then also you can be comfortable in the GATE exam. Okay, so chaliye guys, what is the sum equivalent to now? What is the sum equivalent to? Okay, look into it. Sum is high at. What is the sum output? यहीं से read कर लेंगे. Sum is high at what min terms? 0, 0, 1, that is 1. 0, 1, 0 is 2. Then 1, 0, 0 is 4. And then last min 1, 1 is 7. Guys, 1, 2, 4, 7. These golden numbers are what? Johnson counter bhi aayega, Jashwant. We will cover that. Okay. 1, 2, 4, 7. What are these golden numbers? 1, 2, 4, 7. These golden numbers are known as 1, 2, 4, 7. These golden numbers are known as what? Okay, 3 input XOR. Basically 3 input XOR that we have studied. 3 input XOR that we have studied. And what about the carry output? Okay, what about the carry output? अब इसको अलग से study कर लेंगे. But let me write down the minterm expression here. The carry output is high at सबसे पहले 0, 1, 1, that is 3. And then last में 5, 6, 7. Okay, 3, 5, 6, 7. It is high at 3, 5, 6, 7. It is high at the 3, 5, 6, 7. 3, 5, 6, 7. Done hai? Chalo, done hai. Okay, now let us simplify. We know this 3 input XOR. This cannot be simplified. We are sure that 3 input XOR cannot be simplified. But carry ko to kar sakte hain. Okay, let us talk about the C output. Okay, let us talk about the C output. It is summation of the minterms 3, 5, 6, 7. This summation of the minterm 3, 5, 6, 7 is also given a special name. It is also given a special name. What is that special name? It is given a special name, and that is known as majority function. Now, why it is a majority function? Why it is a majority function? Dekhna yahan pe. Okay, why it is a majority function? Please see here. Look into it. Okay, 3, 5, 6, 7. Look into the input combination 0, 1, 1. Dear, look into the input combination 0, 1, 1. Okay, then 1, 0, 1. Then 1, 1, 0. And then 1, 1, 1. In all of these, how many ones you have? How many ones you have? How many ones you have? Here you have 2 ones. Here also you have 1, 1, 2 ones. Here you have 2 ones. Here you have 3 ones. Okay. Out of the 3 inputs, okay, 2, yeah, maybe 3 are ones. Majority are ones. Majority are ones. Okay. Ones are in majority. Dekho. Ones who were 2, 0 only 1. Minority. Ones who were 2, 0 in minority. Here also 0 in minority. So the output is high whenever you have majority of the inputs as high. The output is high whenever majority of the inputs is high. Agar koi aur combination dekhenge, suppose you look into it, 0, 0, 1. 0, 0, 1, only single high. Okay, so here there is majority of 0. Output is not high. Carry output is not high. Okay, so it is high. This function produces high output when majority of the input bits are high. When majority of the input bits are high, and that is why it is known as majority function. Clear, everybody? I'm not writing it, but understand orally. It produces high output when majority of the inputs are high. That is a majority function. अब इसका simplified expression क्या होगा? First, let me write down the simplified expression corresponding to it. Okay, A, B, C in. Okay, A, B, C in. Okay, 3, 5, 6, 7. Let me fill it up. 3, then 4, 5, 6, 7. Okay, now let me pair. Okay, this is one pair. This is again one dual pair, and this is also a pair. Okay, we know the regions eventually. Okay, this corresponds to a 3 variable K-map. This corresponds to B. This corresponds to C in. Okay, so this is equal to B and C ka product, B, C in. This is in A and in B. Okay, and this is in A along with C, AC. Okay, so what is this C out actually equal to? The reduced form of C out is given by AB plus BC plus AC. AB plus BC plus AC. AB plus BC plus AC. But there is a very important catch here. Okay, it is AB plus BC plus AC, but यहाँ पे एक बहुत important catch है. Understand that catch. AB plus BC plus AC. Okay, so there is one more way of writing the function. Carry out is, okay, summation of the minterms 3, 5, 6, 7. It is equal to summation of the minterms 3, 5, 6, 7. Okay, summation of the minterms 3, 5, 6, 7. What is 3? Okay, 0, 1, 1. A bar B C. What is 5? A B bar C. 1, 0, 1. 6, 1, 1, 0. A B C bar. And 7 is 1, 1, 1. A B C. A B C. Clear? Okay. So what is the C out equal to? What is the C out equal to? देखो अब यहाँ से from the first 2 terms. From the first 2 terms take C common. So you are left with A bar B plus AB bar. A bar B plus AB bar. Take the C in common. From the last 2 terms take the AB common. Then you are left with C bar plus C. C bar plus C will be equal to 1. Okay. C bar plus C will be equal to 1. Okay. So what is the carry output? A bar B plus AB bar. That is what is known as A XOR B. That is what is known as A XOR B. Then into C. Okay. And then plus AB. C plus C equal to 1. Okay. That C plus C bar will be equal to 1. Okay. A XOR B into C. A XOR B into C plus AB. A XOR B into C plus AB. That is the carry output. Okay. That is the carry output. Clear? Acha. Now this calls for a simple implementation of full adders using half adders. Dekho. Okay, what is the half adder circuit? एक बार फिर से देखेंगे. This is what was discussed in the half adder. One XOR gate and one AND gate, that completes a half adder design. Okay, this half adder produces two outputs. Okay, and that is A XOR B and AB. A XOR B and AB. And both of them I am using in the full adder carry output also. A XOR B and AB. तो देखेंगे यहाँ पे. This is one half adder stage. Okay. Okay, this is one half adder stage. Okay, this produces A XOR B and this produces AB. This is another half adder stage. Correct. This is another half adder stage. One XOR gate and one AND gate. That is a half adder stage. Okay, that is a half adder stage. So अब यहाँ पे ध्यान देना. Okay, please pay attention here. Okay, this produces A XOR B. Okay, and now it has to be further XORed with C. So the next variable C coming up here. This is AND gate. A XOR B coming up here to be multiplied with how much? To be multiplied by C. हमें ये चाहिए ना? Okay, A XOR B into C. Only thing is plus AB. So AB is also available here. Take this plus AB. This is A XOR B into C. Feed to a OR gate and let me correct this term basically. This is not the term. This is not the function that we are implementing here. इसको remove किया. The function that we are actually implementing here, A XOR B into C, that is also a carry expression, plus AB. AB यहाँ से आया, A XOR B into C यहाँ से आया, finally one OR gate. Okay, so that is also one thing that you must know. That is also one thing you must know, that for a full adder, okay, for a full adder, you need how many half adders? You have two half adders and one extra OR gate. Two half adders and one OR gate will complete the full adder design. Two half adders and one OR gate will complete the full adder design. Clear? Will complete the full adder design. Two half adders and one OR gate will complete the full adder design. Okay. Now let us go to the simplest design of ripple carry adder. Ripple carry adder, also known as a parallel adder. Also simply known as a binary parallel adder. Also simply known as a binary parallel adder. Okay. Say for example, you are adding two 4-bit numbers. Okay. Say you are adding two 4-bit numbers. ध्यान देना. Okay. You are adding two 4-bit numbers. Let's take the example of 4-bit. So binary parallel adder is the simplest possible adder. It is the simplest possible adder which will implement, okay, the addition of numbers like normally you do. How do you add two numbers? चलो देखते हैं यहाँ पे. So suppose you have 0 1 1 0 added along with 0 1 0 1. Suppose this is what you are adding. Okay, so now come on. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0. Carry going out. Okay, so if any stage is generating a carry, it has to be added with the next stage. Okay, so because incoming carry has to be added, it is sure that I am going to use full adder. Okay, here carry is not generated, but it may or may not be generated. ना ये तो random example लिया मैंने. The carry may be generated from any stage. So like 1 plus 1 is 0 carry 1 and 1 plus 0 is 1. Okay, that is how you normally add 1 0 1 0 1 1. Okay, that is 11. 6 plus 5 is 11. That is simple. Okay, 6 plus 5 is equal to the 11. So this is what 4-bit addition is. So basically what you should do, okay, whatever numbers are to be added, okay, along with the previous carry, that is C in, all of them should be fed to the full adder. Now, output of every full adder, which output? Okay, maybe there is a carry from here. Right now it is 0, but it may be 1 also. Okay, so what is this output? This is the carry output. Carry output of every full adder stage will go to the carry input of the next full adder. For this stage, this is the carry output. For the next stage, this is the carry input. So carry output of every full adder stage will go to the next full adder. Carry input of the next full adder. So cascading होगा यहाँ पे. Have a look into it. There will be cascading here, and this is what is a simple full adder design. Okay, let us call the numbers now. This is an example. Okay, let us say the number 4-bit numbers are A3, A2, A1, A0 to be added with B, and B is given by B3, B2, B1, B0. Add करेंगे A0 plus B0. Okay. Let us say there is some initial carry C0, which is usually 0, but let us assume there is some initial carry. Okay, so this initial carry, okay, is applied to the first full adder. This is known as the LSB stage. This one is the LSB full adder. Okay. Now it computes the sum of A0 plus B0 along with C0. It produces some S0. It will also produce a carry output. Let us say the carry output is C1. Let us say the carry output is C1. What should happen to this carry output? It should be added with the next stage. So that is why what I am doing, whatever is this carry output, it is the carry input to the next full adder. Okay, now next full adder will do A1, B1, C1. Add karenge. Okay, A1 plus B1 along with C1. It produces some S1. Okay, and it produces another carry, suppose C2, that goes to the next stage. So next carry goes to the next full adder and etc, etc, etc. Okay, so these three are added, some S2 and carry C3 plus A3 plus B3 added, some S3, and there may be a final carry which I am calling it as C4. Okay, that is the final output. Okay. Yeah, if not given, okay, C in. The first carry for the LSB full adder will of course be 0 if not given. Okay. That carry is useful if even the two different ripple carry adders are cascaded. Otherwise, it is generally 0. Starting carry is generally 0 only. Okay. And this is MSB. Acha. Now, the ripple carry adder, one of the simplest design. Like normally how you add numbers, same algorithm is implemented. Okay. So, one of the simple advantage of this is it is a simple design and hence easy to design. Very easy to design. Just idea ko put kar diya yahan pe. Okay. And we know how to design full adders. We have to just do the cascading of the full adders. Okay. Flash. Faster ADC is flash only. Manasvi. Okay. Now, please look into it. What is actually happening here is, okay, you only apply the initial carry here, which may be 0 also. But where do you apply the carry? External carry, user. This is not applied by you. This is calculated. But where do you apply the actual carry? The actual carry is applied to the LSB full adder, C0, which may be 0 also. Okay. Then, based on the first full adder computation, okay, this carry is propagated to the next full adder. The carry output of the first full adder will be activating the next full adder. Okay, so I can say that unless and until the first full adder performs the calculation, okay, unless and until the first full adder performs the calculation, next full adder will not be active. Next full adder will not be active. Okay, now next. Okay, this next full adder is going to trigger the next full adder. This next carry triggers the next full adder. It will compute carry C2, which is going to go to the next full adder. Now this will become active. Okay, this also starts computing. Okay, this produces the next carry C3. Okay, upon C3, the MSB becomes active. The MSB full adder becomes active. It starts calculation. It produces the sum, that is S3, and carry, that is C4. So in a way, the carry which you applied only to the LSB stage is propagated, okay, at different points in the circuit up to the MSB. The carry that you applied to LSB is propagated till the MSB. Okay, it's a propagation action, like wave propagates. It's a ripple action happening. Okay, you apply the input at one point, you apply the carry at one point, and that carry is propagated throughout the system. That means the carry is rippling out. The carry is propagating from the LSB to the MSB. Okay, and that makes this design as a slow design. Because unless and until this is complete, ye start nahi karega, then this completes, then this will start, then this completes, then this will start. Okay, so every full adder has to wait for all the previous full adders to complete their calculation. That makes it the slow design. Okay, the carry basically, okay, the carry ripples means propagates. Okay, from the LSB full adder up to the MSB full adder, and that is also one of the reason why it is a slow adder. Ripples bole to you can simply understand as propagates. Okay, like wave action, the carry propagates, okay, from the LSB to the MSB full adder. Acha, then I know it is a slow design. Okay, what is the total time taken to compute the sum? Total time to compute all the bits of the sum. देखो हम क्या बोल सकते हैं? Let us say the okay, let's say the time to compute sum and carry, okay, by each full adder is TS and TC respectively. Okay, it is TS and TC respectively. ये मान लेते हैं. It is TS and TC respectively. It is the TS and TC respectively. ठीक है. So what is the total delay? Okay. What is the total worst case delay, assuming that carry is generated in each and every case, total worst case delay of a n-bit full adder, n-bit triple adder? भाई कितना होगा total delay? of an n-bit triple adder, how much it should be? We know that the final sum bit is produced by the final MSB full adder. Listen to this simple logic. Okay, what is the time to produce the C1? Only when C1 is produced, then only next full adder will start active. Na? So what is the time to produce C1? Time to produce any carry is TC. By any full adder, all full adders are identical. Okay, so time to produce the first carry is TC. Then similarly, time to produce the next carry again TC. Time to produce the next carry again is TC. So at least for the MSB to be active, for the MSB full adder to be active, it is waiting for how many carries? It is waiting for 3 carries. It is waiting for how many carries? It is waiting for 3 carries. Okay, 3 TC minimum. Okay, यहाँ तक तो wait हुआ. यहाँ तक तो wait हुआ. Next. यहाँ तक तो wait किया. Next, then this full adder will be active and it will also take some time to compute S3 or C4. Okay, depending. Sometimes S3 may be taken low, sometimes some takes less time, sometimes carry takes the less time, depends on the design given. Okay, so what is the final delay? Final delay means you have to wait for both of them. Okay, you have to wait for S3 also and C4 also. जो भी पहले आए उसका नहीं, जो last में आएगा उसका wait करना है. So whatever takes more time means maximum of TC or TS. Maximum of TC or TS. So if it is an n bit, here it was 4 bit, so you are waiting for 3 carry. Okay, if it is an n bit, then the total delay, you have to wait for n minus 1 carries. Okay, plus max of TC comma TS. Max of TC comma TS. Max of TC comma TS. Okay. Then you have to, if the delays are differently given, then use the same idea. Okay, जो भी delay given हो, you have to wait for the first carry. Idea इसलिए मैंने आपको बता दिया निशु. Okay, then second, then third, and etc. Sometimes a question are also of the category that maybe delays are equal. Okay, but some specific input combinations are given. Listen to me. There can be a question. Orally बता देता हूँ मैं. Okay, ठीक है. Okay. Now, I hope you understood now Nishu and Manasvi. If the delays are different, what to do? Okay, now understand the next category. Suppose that inputs are given. Suppose A0, B0, 0. Okay, and C0 is also 0. Listen to me. Okay, that's what I'm explaining, Muli, to understand this orally. So suppose these two are 0. Okay, 0 plus 0 plus 0, sum 0, carry 0. So that means there is no carry generated here. So this particular carry stage may not be counted. This particular carry delay may not be counted. The best way when the inputs are given, I will suggest you what to do when the inputs are given. Okay, when the inputs are given, rather than solving like this chain, open up the full adder design. What is the full adder design? What is that full adder design? Okay, this is the full adder design that I've explained you. Okay, 2 half adders and 1 OR gate, and see how the variables are flowing. You have to solve gate by gate, like we solved the logic gate delay question. You have to solve gate by gate. Okay, the gate whose output is being changed. Consider the delay of that gate. Otherwise, discard. Abhi itna time nahi hai because in one session I have to revise the entire things. Okay, but yeah, whatever is the possibility, at least I can tell you orally. Okay? So if specific inputs are given, rather than every full adder, replace it by that complete circuit. 2 half adder and 1 OR gate. Okay? Correct. Gate mein aisa problem aaya. That is why I'm telling you. Just go through that problem once. I've told you, na. I told you. Complete revision of the session plus PYQ plus quiz. Okay. इतना कर लो बहुत हो जाएगा. ठीक है. Definitely you have to attempt the PYQs. So time is about to be 1:30. Shall we go for a break now? Let us time to go for a break now. Okay, let us time to go for a break now because entire sequential circuits and other things also will be there. Okay, so yeah, I think at this point of time I'm calling off a break right now. Not more, yaar. Let's not spend more than 20 minutes right now. Okay. Let's not spend more than 20 minutes. Yeah, 3 hours se upar to ho gaya. It will take another 2-3 hours, I know, easily. easily. Okay, the break for another 20 minutes. Okay, let's resume at approximately 1:45. I think it's 21 minutes from now. Okay. So your timer has started, okay? So guys, kindly stay tuned. If you want to leave, you leave it up. That's your loss, okay? But I'll be coming back another 20 minutes. I'll also have some basic refreshment. You also can have it by that time. We shall resume after 20 minutes. Okay, ज़्यादा नहीं करेंगे, otherwise it spoils the momentum. Chalo, bye bye. See you in the next 20 minutes, okay? All right, back. I'm back, guys. Let me see how many of you are coming back after a lunch break, or whether you feel sleepy after the lunch break. Okay, so first of all, confirm me the audio video, everything fine once we are back. Okay, ji. All fine. So we had a break for say 20 minutes. I think it's exceeded by 2-3 minutes also, but no problem. Okay, chalo, audio clear. Come on, everybody join again quickly so that we start up and move ahead. Move ahead. Okay, ji. Chalo, okay, yeah, let's get started. Okay, so here it is. Let's move ahead towards the decoders. Let us move ahead towards the decoder. Okay, so now I'll be in the combinational circuits. I'll be on, let's target the more important topics. Okay, because we have to move to the sequential circuits also. Okay, I don't want to miss any important topic at least. Okay, so let's cover up the decoders and mux, and then let's move ahead towards the flip-flops and counters. Okay, so decoder. Okay, the minterm generating circuit basically. Okay, the binary decoder. Okay, the outputs of any binary decoder will be the minterms of the corresponding input variables. Okay, will be the minterms of the corresponding input variable, and accordingly we know that for n inputs there will be 2 power n lines. Okay, so that is why there will be 2 power n minterms and hence 2 power n output lines. Okay, considering n input variables. Okay, considering n input variables. So here we have a binary n to 2 power n decoder which takes n inputs and produces all the 2 raised to the power n minterms. Okay, corresponding to it. Such a circuit is a binary n to 2 power n decoder, simply known as n cross 2 power n decoder. Okay, now let's start with the 2 cross 4 decoder. Hurry, probably at the end, because that is not an area from where direct questions are asked frequently. Okay, so jahan se direct question aate, let us try to focus that. Okay, let us try to focus that first, because my priority is to move towards sequential. Okay, sequential, because if that is missed, then there's no point of the marathon. Na? Without sequential circuits, how can we think about digital being complete? Most important area is sequential, flip-flop counter, wahan pe bhi thoda time spend karna hai. Okay, so if you have a basic 2 cross 4 decoder, okay, it will take 2 variables at the input and produces 4 decoder outputs, correspondingly D0, D1, D2, D3. Obviously, what should be the D0? The D0 is going to be A bar B bar. The D1 is of course going to be the A bar B. The D2 is going to be the A B bar, and D3 is going to be the AB. And what is the logic circuit for this? Very simply, I'll draw the logic circuit also. Chalo isko dekh lete hain. That is a basic logic circuit. Okay, there are 2 inputs needed, A, B. Okay, and and the 2 inverters needed to generate the complement of A and B. So A bar B bar to the first AND gate. What you basically need are AND gates here, because you need to multiply. Along with the AND gates, you need inverters for A and B inversion. Okay, so these are the inverters separately available here. Okay, this is A bar, this one is B bar. Okay, this is the inverter. Thoda sa aur clear kar dete hain. Okay. Okay, this is producing A bar B, this is producing A B bar, and this is producing the AB. Very simple logic circuit here. Okay, now important point to notice is that when you take AB00, the truth table format of decoder, when you take the AB00, what is going to happen? When AB00, 0 bar into 0 bar, that is 1 into 1, D0 will be high. Okay, but AB both are 0, B0, A0, AB0, all the other outputs will be low. Only one minterm can be generated at a time. Na? So when the inputs are 0, 0, only the D0 output will be high, rest all will be 0. Similarly, if you feed 0, 1. Oh, there's a typo error here. This is 1. Okay. Similarly, if you feed 0, 1, then what's going to happen? At 0, 1, okay, A bar B, look into it. A bar B, 0 bar into 1 will be high. Okay, but you have taken 0 into 1. One complement will be 0. A is 0. A is 0, all others are 0, very logically, very clearly. Okay, so only one decoder output is high at a particular time, not more than one can be high at a time. So always remember that decoder outputs are mutually exclusive. The decoder outputs are mutually exclusive. ये circuit हमने discuss किया. Similarly, you can discuss the 3x8 decoder, which takes the three variables as the input and produces all particular min terms. Okay, correspondingly, okay, A bar, B bar, C bar. That is the first one. Next is going to be A bar, B bar, C 0 0 1. Next is going to be A bar, B, C bar 0 1 0. Next is going to be 0 1 1. That is A bar, B, C. Next will be 1 0 0 A, B bar, C bar. Next is 1 0 1 A, B bar, C. Next is 1 1 0 A, B, C bar. Next is 1 1 1, that is the ABC. Okay, okay. And similarly, this is the truth table format. Okay, this is what is the truth table format. Okay, for 0 0 0 only D0 is high. For 0 0 1 only D1 is high. As I already explained you, the decoder outputs are mutually exclusive. Only one decoder output will be high at a time. Okay, whenever D0 is high, others are 0. Similarly, when D3 is high, all others are 0. Whenever any particular output line is high, all others will be 0. Outputs will be mutually exclusive only, because only one minterm can be generated to a particular given combination. Okay, yes, you can create that also. That is a very important question. I'll come to that also. Okay, now there can be decoders with the enable pin also. See, basic idea is suppose, look into this 2x4 decoder. Okay, suppose, okay, you apply the input 0 0, you get the D0 as high. 0 1 pe D1, 1 0 pe D2, 1 1 pe D3. So for any input combination, a particular output is high. Only one particular output is high. But what if I am not at all using the circuit only? What if I am not at all using the circuit only? अगर circuit को मैं use ही नहीं कर रहा हूं तो क्या होगा? If I am not at all using the circuit, I am not applied the input, and let's say input not applied means input 0. Let us assume that input not applied means input 0. Okay, so if you are not using the circuit, then also I am assuming AB 0 0. But if by chance AB 0 0, then D0 is high. That means even though you are not using the circuit, one of the output is high. One of the output is high means the circuit is calculating something, then only output is high. Na? So when you are not at all using, still the circuit is active, I can say. Okay, so there should be an option to, enable or disable the circuit. Circuit is always active. So there should be option to enable or disable the circuit. Okay, to enable or disable the circuit. That is why we have the decoders with enable pin. And there are two types of possibility for enable pin: active high and active low. I'll explain you both. Active high and active low. Let's understand this diagram with active high. Okay, let's understand the diagram with active high. So what is the idea of active high? Active high means it will enable the decoder when you supply. Okay, the idea is enable the decoder whenever you supply high, that is 1, on the enable pin. So look into it. Whenever E is 0, that means the circuit is not enabled. So whatever input you apply, maybe 0 0 0 1, kuch bhi apply kar dijiye, none of the output will be produced high. All the outputs will be low. Circuit is disabled. Sorry. Okay, disactive. But when you make the enable pin as 1, okay, then based on the AB, output will be produced like 0 0 per D0, same 0 1 per D1, same 1 0 per D2, same 1 1 per D3. That is the very same thing. That is the very same thing. That is known as the very same thing. ठीक है? That is known as the very same thing. Clear, everybody? Okay. Okay. ठीक है. That is what active high is. Okay. Now, how do you modify the circuit diagram to include active high decoder? Look into the modification. Circuit diagram यहाँ नहीं है. Okay, I have not taken the circuit diagram. I will do the modification here only. Okay. Active high के साथ what should be the circuit diagram? There is only one thing to be added here. Okay. take all the AND gates as 3 input AND gates and take another variable E and feed this variable to all the AND gates. Feed this variable to all the AND gates. ये यहीं पे clear हो गया. Okay. Feed this to all the AND gates. So what I'm doing is, एक काम करते हैं. Let me copy this, है ना? I can at least copy this, ना? Yeah. Just a second, है ना? ये देख लीजिए. चलो. Okay, so how to change the circuit diagram? Very simple is, okay, take, what is happening? Take another variable E and use all the gates as 3 inputs now. Okay, use all the gates as 3 inputs now and feed this enable to all the AND gates. Feed this enable at the input of all the AND gates. So automatically, guys, when enable is 0, AND gate any input 0, output will be 0. So if enable is 0, all the 4 outputs will be 0. If the enable is 0, all the 4 output will be 0 independent of the input. Independent of the input. But if enable is 1, okay, then what is the output of AND gate? That we cannot say directly. That we have to see on the inputs AB. So whenever enable equal to 1, the output produced will be that depending on AB. I mean the circuit will be active. Taking the input AB, it will produce some output. Okay, that is known as the active high enable pin. There can be active low enable pin as well. Okay, active low enable pin as well. And that simply says that enable the decoder. Okay. Okay, when the enable pin is low, it is going to enable, it is going to be active when it is low. Okay, so enable the decoder if E equal to 0. That means if E equal to 1 here, independent of the inputs, all the outputs are 0. Okay, but if E equal to 0, the output will be D0, D1, D2, D3 high based on the value of the input AB, like we discussed earlier also. This one is active low, and to implement active low, what we'll be doing is, again using the same circuit, but rather than that, okay, to all the AND gates, rather than E, you will now feed E bar. You will now feed what? You will be feeding the E bar. Okay, everybody? You will be feeding the E bar. You will be feeding the E bar. So automatically, dear, if E is equal to 1, its complement is 0. If complement 0, all the AND gates take the input 0 and all the outputs will be 0. If E equal to 1, all the outputs will be 0, independent of input. But if E is 0, complement is 1. Okay, so now this reaches 1 here. So what is the output of this gate? We can't say by 1. We have to look into AB. Now the output of the decoder will be that decided by the inputs AB. Clear? So that is what active low. Now to represent active low, this is the symbol. We use a bubble at the input. Okay, not only bubble. See, active low ke multiple representation ho sakte hain. Okay, so if I simply give you like this, this is active high. This is active high. Okay, enable pin with a bubble or E bar. Okay, or even both of them are used. Sometimes students यहाँ पे confuse होते हैं. In some of the questions or some of the books you may find E bar, also bubble. So what is this? Is it active low or active high? This is active low only, guys. This is representation. It is not an operation where you cancel bar and bubble. It is just whether they use bubble or whether they use bar. It is a representation of active low. Even if they use both of them, it is active low only. It is active low only. Please remember, it is basically active low. It is basically active low. Okay, so this one is active high. Okay, these are the representation for active low. Never be confused in the question. Okay, question mein kai baar students confused hote. That is why I am telling it. Okay, so that is active low. Clear? Tell me this answer first of all. Determine the output of the following logic circuit. Determine the output of the following logic circuit. 3 inputs ABC and the corresponding 8 minterms are available. The corresponding 8 minterms are available here. Okay, some of them are used, okay, as an input to the OR gate. Finally, what is the final see, when I say output, by default it means the simplified output, minimized expression. Okay, so what should be the minimized expression here? Okay, so D0 corresponds to the minterm M0 basically. Okay, then you have D2, that is M2, D3, that is M3, that is D6, that is M6, and D7, that is M7. Okay, so what is the function F equivalent to? Function F is addition of all of them, because you're using a OR gate means it is plus. Okay, M0 plus M2 etc. So let me write down the minterm list, and that is summation of the minterms 0 to kaun sa hai? Then 3, 6, 7. Then what is the simplified expression? Nothing, na? We will feed to the K map. We will feed it to the K map. Okay. 0, 1, 2, 3, 6, 7. Okay, now if I pair, this is one quad and this is a pair. Okay, these are the two groups available. Okay, we all know the names. This is 3 variables, so this corresponds to A, this is B, and this is known as the C. And what is this? This is completely within B, and this is the pair outside A and outside C, A bar, C bar. So what is the answer? The simplified expression here is B plus A bar, C bar. Everybody? B plus A bar, C bar. Check it out if that is correct. B plus A bar, C bar. Okay, ji. B plus A bar, C bar. Done. Okay, so such question can also be expected. So guys, if any such question is coming from decoder, what is this? It is basically, either your Boolean logic test or K-map test. Okay, decoder is just to read what minterm combinations are used, but mostly it is a basic Boolean knowledge sometimes, or or K-map knowledge. Very basic. It takes you towards the fundamental only. It takes you towards the fundamental only. Okay. Chalo. Now let me go back and talk about this question. यहाँ से start करते हैं. Number of 2x4 decoders required to implement a 4x16 decoder. Need not derive it, need not give the answer in the form of circuit diagram. We are here to revise and let us talk about the methods of solving it. Okay, but this is an important question. Number of 2x4 decoders, okay, required to implement a 4x16 decoder. Okay, a small decoder. How many small such decoders will be required to implement a big decoder of the form 4x16? Okay, of the form of 4x16. So, देखो, how many output lines are available here? Okay, you have to see for the big decoder, now how many output lines are available? 16. And for the given decoder, it is 4. I'll tell you the simplest shortcut method. Divide 16 by 4. Required output lines and given output lines. Okay, 16 by 4. Okay, I can write it like this. This is the number of required output lines. Okay, and this is the number of required input lines. Okay, so 16 by 4 is 4. Okay, 16 by 4 is 4. Okay, then 4 by 4. Okay, whatever is the answer obtained, keep dividing by 4. Recursively keep dividing by 4. So 4 by 4 is 1. Okay, next 1 by 4. Now that is 0.25. We know that the count will not be negative, or count will not be fractional also. Okay, so dear, whenever you get the fractional value, just take the floor. Just take the floor of it. Okay, now floor means the integer below it. Basically take the floor. So what I will do in every step, I will say that take the floor. In every step I can say you take the floor, but 1 ka floor 1 hoga. Only thing is 0.25 floor will be 0, and whenever you get answer as 0, stop here. Okay, stop here. Then what is the answer? It is the addition of 4, 1, 0. Eventually the answer would be 5. Clear everybody? Answer will be 5. Okay, ji? Yeah. So many of you are coming up with 5. Great. The answer is gonna be 5. Chalte, next. Okay, so that is what is the logic I have explained you. Okay, that is what is the logic I have explained you. Okay. Okay, if it is a fraction, take its greatest integer. Greatest integer means GIF function only. GIF or floor function. Greatest integer less than or equal to that value. Okay. यस यस विवेक्रम मक्स पे भी आएंगे, ठीक है, ठीक है जी. So GIF or floor function, the function I explained you. If this is clear, answer me one more. How many 2x4 decoders required to implement 5x32? Vishwajit, can you elaborate your question? Tell me. The number of 2x4 decoders required to implement 5x32? Okay, again, start. 32 by 4, 8. Jab tak integer hai, no problem about floor and all. 8 by 4, 2. 2 by 4. (32 by 4 is 8. Okay, 8 by 4 is equal to 2. Okay, 2 by 4 is equal to 0.5. And when you take the floor of 0.5, it's gonna become 0. It's going to become 0. 13 kaise aa gaya? No, it's gonna be answer that is 10. I know some of you are confused about 11. No, it's gonna be 10. The simplest answer will be 10. Okay. Okay. No, it's gonna be 10 only. Draw the circuit diagram, you will understand. Okay. You have to use all the combinations here. Acha, it can even be, why only 2 cross 4? It can even be number of maybe 3 cross 8 decoders for building up, say for example, 6 cross 64 decoders. Number of 3 cross 8 decoders for 6 cross 64. For 6 cross 64. Okay. Same technique. You have to worry about output lines. Required output line 64 given is 8. 64 by 8 is 8. Then 8 by 8 is 1. Okay. Then 1 by 8, 0.125. And then I start taking the floor. Fractional value hai. And that's gonna be 0. So answer is 9. Answer is going to be 9. Okay. Okay. That's what, no, Vishwajit. Ye 3 cross 8 bhi aa gaya. Okay. That is what given 3 cross available is 3 cross 8 and you need to build 6 cross 64. Any such question can be there. Don't worry. Okay. Done. Clear. Chalo. Okay. Now mux. Okay. The next and the most important part of combinational circuit, it is a multiplexer where you get a lot of questions. Okay. So multiplexer. Okay. For multiplexing different input signals on a single output line. Say you have 2 power n input lines. Okay, but only one channel to transmit. Only one channel to transmit all these inputs, all this information. Okay, these input lines are nothing but information. You have multiple information, 2 raised to the power n informations. Okay, but you have only one channel for transmission. Okay, I call it as one output here. Okay, so only one information at a time can be transmitted through one channel. We can use here time division multiplexing. Okay, then until evening it is there, Dragon. We can use a time division multiplexing here basically. Okay, so you know at a particular time only one information, after some time next information, after third time next. Okay, so at a particular time which information is transmitted? For that I need to have a control section. I need to have a control section, a control body which will decide at a particular time which information is to be transmitted. Those control section here is in the form of select lines. N select lines can make 2 power n combination. That is why I am using n select lines. Okay, so basically idea is to multiplex. Basically you can assume time division multiplexing. Okay, multiplexing 2 power n signals into one channel using these control or select lines. Using n control or n select lines. Okay. Okay. Chalo. This is how it will look like for a 2 cross 1 mux. Let's learn 2 cross 1 then 4 cross 1. Slowly build karte. So what is the idea? I have 2 informations here, I0, I1. Okay. So how many select lines? I have 2 power 1 inputs. Okay, so how many select line? Only one select lines, and that one select line here is S0 and the output is F. Okay, one of the information I0 or I1 will be transmitted through this circuit and produced in the output F. Which one information depends on the select line. So if the select line is 0, I will be transmitting I0. If the select line is 1, I will be transmitting the information I1. That means output will be I0 for S0 equal to 0. Output will be I1 for S0 equal to 1. So how will you write down the logic functionality? Very important, you should be able to write down the logic functionality here. So what is the output F equal to? Dear, what is the output F equal to? What is the output F equal to? Okay, देखो, output F is equal to I0. but only when S0 is 0. Now when a variable is 0, what do you use in the function? When a variable is 0, you will use that complement. Okay, so that is S0 ka bar. That is S0 ka bar. Okay, when the variable, okay, now output is equal to I1 when the S0 is 1. Okay, so I will use S0 very clearly. When S0 is 0, ये वाला term खत्म हो जाएगा. 0 bar into 0 bar is 1. Output will be I0. But when the S0 is 1, 1 complement is 0. This is gone away. 1 into I1, answer will be I1. Okay, answer will be I1. Okay, so this truth table will be implemented by this logic functionality. Clear, everybody? Okay, so here it is the circuit diagram also. I told you, na, S0 I0, S0 bar I0 plus S0 I1. Okay, S0 bar I0, S0 into I1 added, get the final answer F. You get the final answer F. Similarly, 4 cross 1 mux, you have 4 information. Okay, so to multiplex 4 information, okay, 4 is like 2 square 2. This is 2 power 2 cross 1 mux. So how many select lines I need? I'll be needing here 2 select lines. They are S1 and S0. And based on the value of select line, like 0, 0, I0 will be transmitted. 0, 1, I1 information transmitted. 1, 0, I2 is transmitted. 1, 1, I3 is transmitted. Clear? Acha ji. Achha. So what is the logic function? Because in solving the questions, you will be using this. How to write down the logic function. Okay, so F will be equal to I0. F will be equal to I0. But when both select lines are 0, 0 and 0, 0, you write down bar. So S1 bar, S0 bar. Okay, next will be equal to the I1 at 0, 1. At 0, 1. S1 bar, S0. Next there will be the I2. Okay, S1, S0 bar, 1, 0. And next will be the I3. I3 will be available when both the select lines are 1, 1. So S1, S0. Okay, that is the logic functionality. Clear? But for solving questions, you should be able to write this. Many questions will be solved by this logic functionalities also. Yaad nahi rakhna hai. Don't remember, but you should know how we are writing it from the very basic of this truth table. Okay, similarly, you can have a 8 cross 1 mux, that is 2 power 3 cross 1 mux, which will be using 3 select lines. The 3 select lines are S2, S1 and S0. Okay, based on the combination of select line, like 0, 0, 0, of course I0, 0, 0, 1, I1, 0, 1, 0, I2, etc, etc, up to 1, 1, 1, it's going to be I7. So what is the logic functionality for this? Ye likh dete yahi pe. The logic functionality of this will be I0 is at 0, 0, 0. So 0, 0, 0 ke liye what do you write? Bar, 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 S2 bar, S1 bar, S0 bar multiplied by I0. I1 is with 0, 0, 1. So 0, 0, 1, I1. Next is 0, 1, 0. Okay. 0, 1, 0, I2. What is the next? 0, 1, 1, I3. What is the next? 1, 0, 0, I4. Next, 1, 0, 1, I5. Next, 1, 1, 0, I6. Next, 1, 1, 1, I7. Next, 1, 1, 1, I7. Okay. ठीक है. This is what it is. Now, logic realization using mux. Okay. Because Vishwajit, even that can implement any particular logic circuit. Of how many multiplexers are required? Okay, sometimes, only the factual information can be there, and then I will go to the question also. Again, I'm repeating, we need not derive the information here. Uska time nahi hai. But yeah, if you want to implement a function of n variables, okay, that can directly be done by connecting the n variables to the n select lines. How many to the n select lines? So that means what type of multiplexer I'm using? 2 power n cross 1 mux. That can implement a function of n variables if you are using only 0 or 1 at the input lines. Okay. But if you use one more variable at the input lines, okay, so you can implement a function of n plus 1 variable. You can implement a function of n plus 1 variables where n variables at the n select lines and 1 variable at the input line in either true or complement form. Okay, in either true or complement form. Okay, then there can be a function of more than n plus 1 variable, of course, if you are using extra logic circuitry. Now, how to put it? What type of basic question? यहाँ से कभी-कभी basic theoretical question भी आता है. The idea is, okay, you have a 2 power n cross 1 mux. Okay, okay. You have a 2 cross n power 1 mux with number 1 instance, with number 1 instance, no extra gates, not even inverter. Okay, then you can have a function of, then you can implement a function of n variables, because the n variables can be supplied to the n select lines only. Okay, then next case, okay, next case, if you use a inverter, if one inverter, okay, with one inverter, okay, then you can realize a function of n plus 1 variable where the extra 1 variable will be applied to the input lines. Okay, but for that I need an inverter, na? Because that extra variable may be in the form of true or complement. It may be a or a bar. Anything can appear in the function, na? Okay, so that is why we need one inverter. And then you have, suppose, extra logic gates, any extra logic gates. Okay, then you can realize a function of more than n plus 1 variable, greater than n plus 1 variable. Okay? So that depends. If they tell you only 2 power n cross 1 mux is available, only 2 power n cross 1 mux is available, okay, then only a function of n variable can be realized. But if an inverter is allowed, function of n plus 1 variable. Okay? If extra logic gates are allowed, then it can be any number of variables. So that depend karta hai. More the number of gates you use, more the number of variables you can incorporate. So this has no limit, but at least these two you should remember. Okay, at least these two you should remember. But now how you are actually going to implement? Isko samajhte hain pehle. How you are actually going to implement? Okay, implement the Boolean function summation m2357 using a 4 cross 1 mux with BC at the select lines. Using a 4 cross 1 mux with B and C at the select lines. Using a 4 cross 1 mux with the B and C at the select lines. B and C at the select lines. Bataiye. Okay, so what is there at the select lines is BC. What is there at the select lines is BC. Okay, the simplest method, let us come to the direct method, and that is the implementation table. Okay, the method that we are going to take up here is the implementation table. Okay, so dear, if B and C are at the select lines, okay, so what is there at the input lines? Input lines pe kya jayega? Okay, A or A bar, of course. What is there at the input lines? A or A bar? A or A bar? A or A bar? Clear? Ab dekhiye. The implementation table will be so that it will have 2 rows and 4 columns. Why 4 columns? Because I need to decide 4 inputs, na? I need I0, I1, I2, I3. 2 rows. 2 rows corresponding to A bar and A. Okay, there will be 1 row corresponding to A bar, there will be 1 row corresponding to A. But what minterms to be written here, that is not fixed. That depends on question. Here, I am using A at the input line. So tell me what are the minterms where A is high? And A bar. A bar means, when do you write A bar? When A equal to 0. Na? Yahi minterms se samajh ke aaye hum log. Okay, so what are the minterms going to come up here? Where A is 0. What are the minterms going to come up here? Where A is equal to 0. Where A is equal to 0. So dear, agar ek bar hum truth table ko bana le. Okay, agar hum ek bar, let me just write down, for your clarity, let me write down these variables 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now dear, what are the combinations where A is 0? What are the combinations where A is 0? The first 4 combination. What are the combinations where A is high? Last 4 combination. बस यही आके कॉपी कर देंगे. तो फर्स्ट 4 स्ट्रेट फॉरवर्ड 0 1 2 3 एंड देन नेक्स्ट 4 4 5 6 7 here. This is only the implementation table. Okay, now starts the question. What is the question? Okay, the question is, function is summation m2357. Let me write down the function also here. 2 3 5 7. Next is, what is next? Okay, whatever minterms are given, please bubble, please highlight here, bubble kar dijiye, circle kar dijiye. Let us circle here. So 2 and 3 and then 5 and then 7. Whatever are the minterms given, please circle here. Okay, now look into the first column. I0, nothing is circled, neither A bar nor A. So it is 0 plus 0. What is 0 plus 0? Is 0. There is a circle, there is a minterm corresponding to A. So write down A here. There is a minterm corresponding to A bar. So please write down A bar. You have to just see which minterm is coming. But in the last column, both are circled. Means both A and A bar are coming. What is A plus A bar? If both are coming, A plus A bar, that is 1. That is 1. So simple logic is, if both are coming 1, if none of them is coming 0, otherwise see which circle is there, either A or A bar. Okay, if both are absent 0, if both are present 1, otherwise it will be A or A bar based on the row. ऊपर है तो A bar, नीचे है तो A. Clear everybody? So this is I0, I1, I2, I3. So how is your answer? Let me draw the circuit diagram corresponding to the answer. Okay, your answer is, ये देखिए, या चलो यहीं पे बनाते हैं ना already. Okay, already we have that picture. Yeah, let's see. I'll place the answer here. Okay, this is going to be my answer. See the answer. Okay, what is there at the select lines? Okay, B and C. So write down B and C at the select lines. What is at the input lines? Okay, that we have calculated. 0, A bar 1. 0, A bar 1. And that is why I need an inverter. I told you, na? Inverter will be required. Okay, so 0, this is A. Okay, this is A. With A, I need an inverter also. And this becomes A bar. Okay, this is 1. Okay, and this is 0. 0 means ground. Or you can write 0 also, whatever. Okay, this is 0. Okay. So now see, you have a 4 cross 1 mux. 2 power 2 cross 1 mux. 2 power 2 cross 1 mux. 2 of the variables go in the 2 select lines. 1 will go at the input line. And that is why you are able to implement a 3 variable function. You are able to implement a 3 variable function. Clear everybody? Okay, so if one inverter is allowed, then you can use a function of, you can build a function of n plus 1 variables. You can build a function of n plus 1 variables if extra inverter is allowed. Okay, n select lines and 1 goes to the input line. ठीक है. चलिए, A भी आ सकता है select lines पे. So if that is the case, have a look into the next question. Implement the function with a 4 cross 1 mux using AB at the select line. So what is there at the input lines? Okay, so what is there at the input lines, dear? If A and B go to the select line, so input lines may contain C or C bar. Either C or C bar, or maybe 0, 1. Okay. So what is the implementation table now? Okay, what is the implementation table now? ये तो सीधा answer बनाएंगे यहाँ पे. And the select lines are AB. Okay, this part is known. We have to decide this actually. We have to decide this. Okay. चलो जी, so implementation table बनाएंगे. All the concepts of mux, all different types of concepts of mux, all of them are very important. Okay, this is known as the implementation table. This is known as the implementation table. This is known as the implementation table. So chalo, implementation table again. Okay. I0, I1, I2, I3. This is known as what? There will be 2 rows corresponding to C bar and C. But now, once again, if you full 0, 1, 2, 3, this goes wrong. Many students, that is what is the mistake they will do. They will write down 0, 1, 2, 3. They remember only one implementation table. You don't have to mug up implementation table. You have to understand the logic behind this. Here, those minterms should be coming up where C is actually 0. Where C is actually 0. So if you again read this, na, where C is 0. So where is the C 0? Ye raha C 0. Alternate. Okay, that is 0, 2, 4, 6. 0, 2, 4, 6. Okay, 0, 2, 4, 6. And then alternate 1, 3, 5, 7. Alternate 1, 3, 5, 7. It is going to be C. Okay. Now, given function. Let me write down the given function here. What is the function? It is 1, 3, 4, 6 given to me. 1 and 3 and 4 and 6. 1 and 3 and 4 and 6. So, here are 1, here are 3, here are 4, here are 6. Second row, C. Second row, C. First row, C bar. First row, C bar. Okay. So, C, C, C bar, C bar. That should be the answer. C, C, C bar, C bar. Okay. C, C, C bar, C bar. Say this is C. नहीं, पहले दो में C है ना? Let me check the answer. First two C. Okay. Okay. Dear, this is C. This goes here. Okay. The same variable C goes here. But I need C bar. That goes to I2. I3. Okay. C, C, C bar, C bar. Clear. That is your answer. With the select lines AB, at the input lines you have C or C bar either. Okay. So you have to be careful. The implementation table, you don't have to mug up. You have to make based on what is at the input line. What is at the input line? They will not specify. They will specify select line. And they will 100% specify, because without it you cannot solve. Na? Okay, so what is there at the select lines? They have to specify it. They have to specify it. Clear everybody? Achha ji. If this is clear, next question then. Ye bhi ho gaya. Okay, yeah. Now some questions in the mux are directly calculate the output. They are very simple but very frequent. Okay. Calculate the output of this mux. Come on, tell me. Determine the output of the following circuit shown below. Very simple, na? Let us start. 2 cross 1 mux, even more simple. Okay, 2 cross 1 mux, even more simple. Select line 0 pe I naught aayega. This 0 means I naught. Okay, so what is the output that you obtain here? Pehle isko dekhte. What is the output that you obtain here? Select line 0. Okay, so that is x bar. Okay, x bar pe aayega y. Select line 1, that is x. Okay, then I1, but I1 is 0. So this is simply x bar y. Okay, now let's come here. What is the output here? The output here will be select line 0. 0 means z bar. Select line is z here. Okay, z bar pe aayega I naught. And what is there at the I naught? X bar y. Okay, plus select line 1. Select line 1 means z. Okay, then the complement of this will come. Acha, the complement aayega na iska. So let me call this as f. Okay, let me say the output of this multiplexer is f. Okay, the output of this multiplexer is f. Okay, so what is coming here is, let me rewrite this. Okay, select line 0, z bar pe I naught, that is f. But if select line is 1, z, okay, you will get f bar here. Okay, f bar. Okay, so basically, okay, z bar f plus z with f bar. Okay, z bar f, okay, and z with f bar. So this is nothing but z XOR f. Z XOR f. Z XOR x bar y. Okay, chalo isko open chahe to open kar lete hain. Okay, so let's try to simplify it. So this is z bar into x bar y plus z into f complement. And what is the f complement? When you take the complement, x bar y complement will become x plus y bar. Basic De Morgan's. Okay, basic De Morgan's. Now if you rearrange it, do we have the options? No, we don't have the options. So let's rearrange it. Okay, the x bar y z bar, okay, plus xz plus y bar z. See the possibility if there is any reduction by chance. See the possibility if there is any reduction by chance. Okay. Okay, so x bar y z bar 0 1 0, that is the minterm number 2. Okay, 0 1 2 3. Then x into z. Okay, this is x z y. Okay, so x into z 1 1, y bar into z, y bar into z. Okay, no, it is already reduced. No, it is already reduced form only, because even if you make the pair, okay, this is xz, this is y bar z, okay, and this cannot be paired. Okay, this cannot be paired. X bar y z bar. Okay, done. It is reduced only. But just I was checking it to be sure. So this is the answer. Clear, everybody? Okay, answer should be x bar y z bar plus xz plus y bar z. Correct? Eh? Yeah, some of you are coming up with the same answer in the comment box. Good one. Next question. Okay, now what is the Boolean function realized by the logic circuit shown here? By the logic circuit shown here. A, B. I'm not sure what are the variables. Data is missing here, but of course, let's take it as C and D. Okay, I'm going to take it as C and D only. Okay, it should be C and D. Then you can go by the basic. There also implementation table is there, Rakesh, but I think let's go with the basic truth table there. Okay, that will be more simpler. No need to form so many tables. Form the shortcuts for the questions which are more and more frequent. Okay. Chalo, tell me. Yeah, let's take C and D here. Ab bataiye yahan pe. Okay, again, it's a reverse question. You don't have to design a circuit using mux. A mux and a circuit is given to you. What is the function realized by it? Okay, and that too in the form of minterm list. In the form of minterm list. So, dekhiye. Let me start reading it first. Okay, so F. When the select lines are 0, 0 means A bar, B bar. Okay, A bar, B bar pe I naught aayega, that is C. Okay, what is the next one? Okay, what is the next one? A bar B, 0, 1 to be multiplied by D. What is the next one? A B, select lines. A B bar, 1 0 pe aayega, I2, that is, what is the I2? This is C, this is C bar. And then the select lines, that is 1 1, A B. Select line, that is 1 1, A B multiplied by C bar D bar. Okay, this is C bar D bar to the AND gate. So C bar D bar is the output. C bar D bar is the output. Now we can directly say what are the minterms coming up, dear. Okay, what are the minterms coming up? Okay, 0, 0, 1 and X. D is missing here, na? Okay, so missing means 0, 0, 1, 0 or 0, 0, 1, 1. Okay, then what is this A bar? A is 0. Okay, B is 1. C is missing. D is 1. Okay, so 0, 1, 0, 1. दो केस बनेंगे 0, 1, 1, 1. Okay, A, B bar, C bar 1, 0, 0. Like in the beginning, I told you how to calculate the minterms. Okay, 1, 0, 0, X. D is missing here. So 1, 0, 0, 0, 1, 0, 0, 1. Okay, and this is all present. 1, 1, 0, 0. Okay, so what are the numbers coming up, dear? Dekho, 2, 3, 5, 7. None of them is repeated. Okay, so no problem. 2, 3, 5, 7. Okay, then 8 and 9 bhi aayega. Ye ho jayega. And then 12. So it's D. It's option D. 2, 3, 5, 7, 8, 9 and 12. It's option D. Correct, Vishwajit and Nishu. Correct answer D. Ashok, recheck. It's not C. It's option D. Okay, yeah, Manasvi, correct. Okay, so yeah, now you have a 8 cross 1 mux. 8 cross 1 mux. 8 cross 1 mux. A combinational circuit using a 8 cross 1 multiplexer is shown in the following figure. What is the minimized expression for the output Z? What is the minimized expression for the output Z? Minimized expression for the output Z. Tell me. Minimized expression for the output Z. Okay, first of all, let us calculate the output Y. Then Z to baad mein nikal lenge. Okay, because this is the LSBC complemented and Z is equal to C bar plus Y. So main focus first Y nikal lete. What is Y? Again, 0, 0, 0 pe I naught aayega and I naught is equal to 1. Okay, so dekho, I naught is 1. Only consider the ones. Okay, because if I3 is 0, even if you take the select line 0, 1, 1, I3 will come at 0, 1, 1. A bar BC, it's going to be multiplied by 0. Okay, so isko discard kar denge. Discard and take this as 1. Okay, so Y can basically be taken as summation of the minterms 0, 1, 2. Okay, 0, 1, 2 and 6. 0, 1, 2 and 6. Now if you want, solve it through the Boolean laws or solve it through the K-map. Okay. Okay, you have 0, 1, 2, 3, 4, 5, 6, 7. Okay. Clearly reduction is possible and the variables, input variables are A being the MSB, this is B and this is C as always. Now I start the pairing. This is a horizontal pair. Oh, sorry. This is clearly horizontal pair and this is a vertical one. Okay, this is known as B into C bar. Okay, and this is known as how much? A bar multiplied by B bar. Okay, so what is the Y equal to? Okay, A bar, B bar plus B, C bar. But the output Z is equal to Y plus C bar. Okay, the output Z is Y plus C bar. The output Z is equal to Y plus C bar. So output Z is Y. Y को copy कर देते हैं. A bar, B bar plus B, C bar. Okay, plus C bar. From the last two terms, dear, C bar will be common. Last two terms C bar common लेंगे तो 1 plus B is 1. 1 plus B is 1. So my answer is A bar, B bar plus C bar. Please check out here. A bar, B bar plus C bar. A bar, B bar plus C bar. Check out this one, everybody. Okay. All right. So A bar, B bar plus C bar. Done. Next question. What are the minimum number of 2 cross 1 multiplexers required to generate a 2 input AND gate and a 2 input XOR gate? Now क्या बोला है? Okay, minimum number of 2 cross 1 multiplexers. There is no other gate mentioned, means you cannot use it. Means you cannot use it. Okay, now required to generate a 2 input AND gate and a 2 input XOR gate. a 2-input AND gate, a 2-input XOR gate. 2-input AND and 2-input XOR दोनों निकालना है यहाँ पे. तो देखो how will you do? Okay, for a 2-input AND gate, and I have only 2 cross 1 multiplexer. I have only a 2 cross 1 multiplexer. 2 cross 1 multiplexer means 2 inputs to be multiplexed having a single select lines. Okay, this is I0 and I1. Okay, but this one is the AND gate is very simple. What you can do is AND gate बोले तो A into B. Okay, feed anyone on the select line. Suppose I feed A as the select line. Okay, I feed A at the select line. Okay, अब देखो, if the select line is 0, A bar के साथ I0 will come, but there is no A bar term here. So make the I0 as 0. But if the select line is 1, A, then I1 will be taken. So take I1 equal to B. This will produce AB. Done na? Very simple logic. Okay. Okay. Again you see A bar into 0. That is gone away. A into B. That is the AND gate finished. Okay. So for AND gate it is definitely 1. For AND gate it is 1. For XOR gate? Okay. For XOR gate? Now it implements what? It implements XOR gate. I want A bar B plus AB bar. A bar B plus AB bar. अब देखो ध्यान देना. Okay, A bar B plus AB bar. Please pay attention. Okay, you may think, okay, select line 0, A bar. With A bar I need B here. Okay, so this becomes A bar B. This becomes A bar B. Plus select line equal to 1A. With A I need B bar. Okay, so I feed B bar here. Okay, so ये तो हो गया. Okay, ये तो हो गया. Okay, A bar B plus AB bar. A bar B plus AB bar. ये तो हो गया. One only? नहीं. How comes this B bar? For this B bar, I need one inverter, na? I need inverter, and only mux is given to you. So you need a mux. You need another mux to implement the inverter. Have a look into it. Okay, select line S0 पे. I want to invert B. देखिए ये रहा B. Okay, this is B. Okay, now with B what you are going to do? Okay, I want B bar. So if B is 0, okay, I0 will be 1. I1 will be fed as 0. So look into it. Na? Select line 0. That means B bar into 1 into I0. Plus select line 1 B into 0. B into 0 is 0. So answer is simply B bar. Answer is simply known as the B bar. हो गया? Answer is simply known as the B bar. So this is how the inverter has been implemented. So how many multiplexers? Actually 2 multiplexers. Okay, actually 2 multiplexers. So answer is option number A. For AND it is 1. For XOR it is 2. For XOR it is 2. For AND it is 1. For XOR it is 2. For AND it is 1, for XOR it is 2. ठीक है, चलो done है. 1 and 2. Just look into it. Very simple explanation it is. हाँ जी. The minimum number of 2 to 1 multiplexers required to realize a 4 to 1 multiplexer. Minimum number of 2 to 1 multiplexers required to realize a 4 to 1 multiplexer. How do you solve this? Same logic as decoder. Okay, but here you calculate the, okay, with respect to input line 4 to 1. Okay, so this is the required number of input lines. You need to build a mux with 4 cross 1. That is the 4 input lines, and these are the given input lines. These are the given input lines. The rest is the same logic. Divide the required by the given. 4 by 2. Okay. 4 by 2 is directly an integer 2. Okay. Then you divide 2 by 2. That is again an integer 1. Then you divide 1 by 2. And if it is a fraction like 0.5, take the floor value. Answer is 0. So now add all of them. Answer is 3. Correct issue. Here also floor value. आंसर विल बी 3. ठीक है, आप बना के देख सकते हो सर्किट डायग्राम. Okay, how a 4x1 mux can come out of a 2x1 mux. There will be 3 required. Okay, but we need not derive here. Okay, but method is same as that what I explained you for the decoder. Okay, method is same as that what I explained you for the decoder. Okay, now dear, time to jump to the latches and flip-flops and then the counters. To the latches, to the flip-flops and then the counters. Okay, just a moment. Just a moment, dear. Hanji guys, okay, so time to move ahead towards something most important. Okay, time to move ahead towards something most important. Okay. See, encoders, comparators. See guys, I told you the first priority with respect to GATE exam is covering those areas from where you have highest chances of getting the direct question. I know encoders, comparators, code converters hai. Okay, but the areas from where you have the highest chances, like multiplexer is the area where you have a very high chance of getting the question. Then decoder se bhi question aate hain. Similarly, okay, the things will be incomplete before the latches, flip-flops and the counter. So that is why now first I'm starting with the latches and flip-flops. Okay, okay. So you know, in whatever time I have, okay, in whatever time I have, I'll try to cover at least something which is most important. Okay. I'll to cover maximum, but something important at least should not be missed. Okay, otherwise you spend this much of energy morning to evening or afternoon. Okay, so that should be worth. Okay, that should be worth. And that's what, guys. One more thing I told you at the end month, na, it is all about being selective also. In the end month, it is all about being selective. See, if you have by chance not studied some important topics now, you can skip it. You should study complete syllabus, but if you are in the last month and you have not studied the syllabus, then you are left with no choice. So last month you have to be very selective also. Very selective also. Okay? So चलिए आते हैं यहाँ पे. The SR latch or the NOR gate latch, starting with the fundamental latch. Okay, that is the NOR gate latch. Why it is the SR latch? Okay, and I'm first of all starting with the unclocked latch. I'm first of all starting with the unclocked, and then what is the clocking? वो भी बताता हूँ मैं आपको. So let us start with the concept of unclogged latch. The concept of unclogged latch. The concept of unclogged latch. Okay. Why do we need clocking? वो भी देखेंगे. But look into it. This is NOR gate latch. What is a NOR gate functionality, dear? What is a NOR gate functionality? We know. Okay. If any of the input is high, if any of the input is high, okay, 1 plus anything is 1, but when you take the complement, since it is NOR, okay, complement will be 0. Okay, then if both the inputs are 0, okay, 0 plus 0 is 0, complement will become 1. Only when both the inputs are 0, output will be high. If any of the input is 1, output will be 0. That is what is the fundamental NOR gate. That is what is the fundamental NOR gate. Okay. Now there are two NOR gates, okay, with the feedback connection. A crisscross feedback connection is there. Okay, now understand this way. Okay, let us understand this way. So this is what was for revision. Okay, let me take the particular specific format, okay, for the SR values and the Q output. And also let me write down Q bar output, no worries. Okay, let me start with the value. Okay, suppose S equal to 1, R equal to 0. Normally we start the truth table with 0, 0. Okay, I am starting with S1 and R0. So what is going to happen? Okay, dear, if S is 1, if any input for a NOR gate is high, output will be 0. So if S is 1, I don't want to check this, because if any input high, output will be low. Okay, this 0 comes here. And what is R? R ko 0 liya hai. For the first NOR gate, both the inputs are 0. And if both the inputs are 0, output will be high, Q will be high, and Q bar is 0. Clear, everybody? Okay, so corresponding to the input S1 and R0, I am getting Q and Q bar as 1, 0 respectively. As 1, 0 respectively. Okay. Next हम देखेंगे. Now next let me make it as 0, 0. Next let me make the input as 0, 0. Okay. So S was 1, now it is made to 0. Okay. So now S is equal to 0. Okay. If S is equal to 0 but Q equal to 1, Q equal to 1 will come here to the second NOR gate. NOR gate any input high, output will be 0. Okay. Output 0 runs here. R is also 0. Okay. What is the NOR of 0, 0? What is the NOR of 0, 0? It's going to be 1. 0, 0 per NOR 1 aayega. That means Q also remains to be 1 and there is no change in Q bar also. There is no change in the Q bar also. Okay, that means the output does not change here. Next condition. Now next, S equal to 0. Now let me raise R. Let me raise the R equal to 1. Okay, so now R is equal to 1. Okay, so now let me remove it. New calculations. R is 1, S equal to 0. Any input high, output will be 0. Output will be 0. This 0 comes here. Okay, NOR of 0, 0, it's going to be 1. NOR of 0, 0, that is going to be 1. Clear? That is going to be 1. Okay, now 1 comes to the above NOR gate. Okay, NOR gate, both the inputs are high, output will be 0. No issues, na? Okay, no issues. Okay, so now this time I have Q0 and Q bar equal to 1. Okay, now again let me make R0. For a reason I am considering it 2 times 0, 0. Okay, because maybe you interpret that if SR0 output is 1, 0, output Q equal to 1, Q bar equal to 0. No. Okay, let us again take the SR0, 0. Okay, so SR0, 0, R ko again 0 kiya. Okay, but Q bar was 1, 1 comes here. Okay, 1 comes here, dear. What is going to be the answer? Okay, NOR gate any input high, output is 0. This remains to be 0. This 0 is already here. Both inputs to the NOR gate 0, 0. Both inputs 0, 0. Output will be 1. Okay, so Q bar is 1. Okay, so Q is 0. Q bar is 1. Q is 0. Q bar is 1. So देखो, SR equal to 0, 0. Sometimes the output. Okay, sometimes the output Q1, Q bar 0. Sometimes the output Q0, Q bar 1. So what is the correct conclusion here? The correct conclusion here is the output is copying the previous state. Output is copying the previous state. It is holding to the previous state. Okay, if previously Q was 1, it remains to be 1. If previously Q was 0, it remains to be 0. That is why when you apply the input 0, 0, this device is said to be in the hold state or same state. Okay, the device is said to be what? In the same state. This is same. Same means same as previous. This is also same. Same bole to same with respect to previous. But when you apply S1 and R0, okay, the Q equal to 1, that means the device is set. Divide value, the device value becomes 1, the device is set, and this is said to be set state. Which input sets it? The S input sets it. That is why it is named as S. I can name it as AB also, no? I can also name it as AB. The reason we name it as SR, because suppose it is AB. Suppose it is AB. So whenever A is 1, then the device is set. So that is why A is known as the set input. A is known as the set input. We call it as S directly. Okay. Similarly, okay, which input? Suppose B equal to 1, the device becomes reset. Look into the value of Q, 0. The value of Q, that means the device is now reset. The device is now reset. The device is now reset. So which input will reset it? B input. That is why I call it as a reset input, simplified as R. That is the reason we call it as SNR. Okay. That is the reason we call it as SR. Okay, G. Okay. So that is the reset state. Now one combination is missing here. And what is that one combination? Okay. What if you apply both the inputs as 1, 1? What if you apply both the inputs as 1, 1? Okay, if you apply both the inputs as 1, 1, okay, RB1, SB1, nor get any input high, output is 0. Here also nor get any input high, output is 0. Q and Q bar, both are 0, 0. They should be complement of each other, na? They should be complement of each other. Both become 0. Okay, both become 0. This is known as invalid state. This is known as invalid state. Now this is not previous, it is invalid. Q and Q bar are both becoming same, they should be complement of each other. Every latch will have two outputs. Okay, one is true and one is the complement. Acha, the big problem is not that they are same. The big problem is that once the device enters the invalid state, okay, its next state becomes indeterminate. Okay, when we do the detailed analysis, we come to know that when the device enters the invalid state, its next state becomes indeterminate. The next state cannot be predicted, whether the next state is going to be set or reset, or it may be oscillatory also. The device may go into unstable and oscillatory zone. Unstable and oscillatory zone. Okay, here toggle nahi aata Manasvi, that comes in the JK flip-flop. Okay, so in SR, both the inputs should not be high. User has to take care not to apply both the inputs as 1, 1, otherwise the device enters into the invalid state, and that is one problem of SR latch, and that is why we overcome the problem in the JK latch. We will overcome this problem in the JK latch, don't worry. Okay. So the conclusions, whatever we have discussed here, the quick conclusion is that whenever S1 and R0, the device is set to be set. Okay, it is set to be set. Whenever S0, R1, R bole to reset to, device will be reset. Reset means Q equal to 0, set means Q equal to 1. Whenever both the inputs are 0, okay, the device remains in the previous state. It is holding the previous value just like memory. Okay, and when S equal to R equal to 1, this is an invalid state. User should not apply this input. User should be careful not to apply this input. Okay. Now, the first type of latch that you have considered is an unclocked latch, as I told you. Unclocked latch, okay, which is also known as the category of asynchronous sequential circuit. This is an asynchronous sequential circuit. This is the asynchronous sequential circuit where inputs can be applied, where inputs can affect the system at any point of time. Okay. Inputs can be applied at any instant. अब देखो problem समझना. Ultimately, it is built using logic gates, and they are the NOR gates. Okay, they are the NOR gates. Every NOR gate will have a delay. Let us assume that this NOR gate has a 10 nanosecond delay. This NOR gate also has a 10 nanosecond delay. Okay. Okay. Initially, your device is reset. Initially, your device is reset. Yeah, let us say initially your device is already set. Okay. Initially, your device is set. यहाँ से start करते हैं. Your device is initially set. Okay, let us start from here. Okay. Then, at t equal to 0, that is your beginning time. Okay. At t equal to 0, you apply the input 0, 1. You want to reset the device now. Clear? What is your objective is? Now you want to reset the device. You want to reset the device. And to reset the device, what will you do? You will apply S0 and R1. Okay. You will apply the S equal to 0 and R equal to 1. To reset the device, you will apply the S equal to 0 and R equal to 1. Clear? Okay. You will apply the S equal to 0 and R equal to 1. अच्छा. Then after some time, अच्छा, चलो पहले एक बार यहाँ से पूरा ट्रैक करते हैं. Okay, S equal to 0 and R equal to 1 you apply. Okay, S equal to 0, R equal to 1. Okay, now R equal to 1, output of first NAND gate will become, any input 1, output will be 0, but this will become after 10 nanoseconds. So Q will become 0, but after 10 nanoseconds. Okay, then this 0 runs here. ये 0 यहाँ पे आया. Inputs to both the inputs to the NOR gate is 0, the output will be high. But again after 10 nanoseconds, so total 20 time. Okay, Q bar भी 1 होना चाहिए ना, Q0, Q bar 1. So total time required to complete one operation here is 20 nanoseconds. The total time required to complete one operation is 20 nanoseconds. Okay, so your device will reset, but it takes a time of 20 nanoseconds. Everything in the world takes time. Okay, what happens? You are unknown about these timings. Okay, and it is an asynchronous circuit. Inputs can be applied at any time. What you do is, at t equal to suppose 8 nanoseconds. At t equal to 8 nanoseconds, you make R0. आपने क्या सोचा? I applied 0 1, the device becomes reset. Okay, and then at t equal to 8 you make r 0. Yeah, maybe you don't make it intentionally, maybe noise affected it, maybe there is some glitch in the input, maybe there is a glitch in the input, there is some noise, there is some disturbance, and r becomes equal to 1, and that happens at 8 nanosecond. Will the reset state occur? The time to reset 20 nanoseconds, but only and only after 8 nanoseconds. Only and only after 8 nanoseconds. Okay, the input again changed to 0 0 0 0 means same. Achha, same means where you left? You left with the set state. I told you, na, initially it is set. Okay, so what is the output you are going to get? You are going to get 1 0. You will think circuit is working wrong. You will think circuit is working wrong because it was set. Okay, you think it was set. Now it is set. It is still set, and you are maybe imagining that the circuit doesn't work. Is there a problem with the circuit, or is there a problem with the input, or is there a problem with the timing? Basically, there is no problem with the circuit, because every circuit needs some time. If you don't give enough time, it's not going to respond as it should. Clear? Okay, you tell me revise the digital. I have made a plan for 5 hours today. Okay, of course we are exceeding 5 hours. I will take 6 hours, 7 hours, that doesn't matter. But if you say complete in 1 hour, how much will I complete in 1 hour? Can I satisfy you? You also can't understand. Suppose you say devise the digital in 1 hour. Okay, even 6-7 hours will not be perfectly complete. But suppose I need 6-7 hours to cover at least the important areas. Okay. But you say complete in 1 hour, what will happen? Nothing. Neither I will give something productive, neither you will gain something. Kuch nahi hoga na. That is what it is. So the circuit takes a time of 20 nanoseconds to reset, and you change the input at 8 nanoseconds, and inputs can be changed at any point of time. That is what is the problem of asynchronous circuit. That is what is the problem of asynchronous circuit. Okay? So that fundamentally means is, okay, I should be taking care that unless and until one cycle is complete, okay, I should not allow the input to change. I should be blocking the input. What I should do? I should block the input coming into the circuit. Okay, even if this input is changed by noise, suppose noise affected it, it should not come inside the circuit. Even if somebody externally is changing the input, it should not enter. It's like a room and the door should be closed. I am teaching here, I close the door of the studio. I don't allow anybody to come in so that I may be distracted. Na? So I have closed the door. Say for example, I don't want anybody to come so that by the time I complete my class, I don't want any disturbance. Same thing should happen here. By the time 20 nanosecond is completed, by the time, okay, the circuit completes a particular operation, it should not allow other inputs to enter. Even if the input changes by noise or by intentionally, but that should not come inside the system. That is the idea we want to develop, and now we'll use the clocking to implement that. Now we'll be using clocking to implement it. Okay, we'll be going towards, rather than asynchronous, A cut kar denge, we'll be going towards synchronous circuits, where inputs can be applied only at limited times. Inputs can be applied to the circuit only at limited times. Okay, so next what I'm starting is a clocked SR latch. Okay, now which is synchronous sequential circuit. Okay, and synchronization is achieved with the help of clock. This particular synchronization is achieved with the help of clock. And look into it. Okay, this is the same NOR gate latch. Okay, but an additional layer of security is added here. That is basically like a gate. Basically like a door, you can say. Okay, there are two AND gates here, and both of them have the input that is CP. What is CP? It is the clock pulse. What is CP? Clock pulse. Commonly, most commonly, a 50% duty cycle square waveform. Not necessarily 50%, but yeah, commonly I'm taking 50%. It can have any other duty cycle also, but yeah, it's a waveform which continuously keeps on triggering between 1 0 1 0 1 0 1 0 1 0 1 0, so that whenever clock is at 0, dear, what happens? Whenever clock is at 0, okay, both the AND gates produce the output also 0. Okay, so now this is what is your actual S input, and this is what is your actual R input. Don't forget. Okay, means internally. Chalo, let me call it as S1 R1. So what happens if the clock pulse is 0? S1 R1 are both equal to 0. S1 and R1 are both equal to 0. And if S1 R1 equal to 0, 0 0 pe kya hota hai, dear? What happens at 0 0? What happens at 0 0? The device remains in the previous state. Independent of whatever be the input, even if you change the input here, that's not going to affect the device calculation. That's not going to affect the state of the device. Are you getting it? Okay. That's not going to affect the state of the device. Okay. So let me call this as S1 now. Let me call this as R1 now. So what is happening dear? Very simply, if the CP equal to 0, S1 equal to 0, R1 equal to 0. Both of them are 0. Okay, device remains in the same state. Okay, independent of input. Device remains in the same state independent of input. Device remains in the same state independent of input. That means inputs are blocked. Inputs are blocked. Inputs does not affect the output. Whenever clock pulse is 0, it's like door closed. Okay, clock pulse equal to 0 is like door to the circuit is closed. ऐसा बोल दीजिए कि एक दरवाजा है और वो दरवाजा closed है. Okay, that door is closed. Okay, that door is closed. That door is closed. Clear everybody? That door is closed and nobody can enter. But if the clock pulse equal to 1, so periodically, okay, clock pulse will be 1 and 0. So at a particular time it will be 1, and whenever the clock pulse is 1, what is going to happen? A clock pulse equal to 1, S1 will be equal to S, R1 will be equal to R. Okay, the S1 will be equal to S, the R1 will be equal to R. Okay, S1 equal to S, R1 equal to R. Okay, and now your device, okay, will produce what output? Depending on the SR value, the external SR value. The device responds, okay, to the external SR values जो आपने apply किया है, to the external SR inputs. Now that means the input, now it's like door open. Okay, door open, आ जाइए. Door open, come inside, inputs come inside. Okay, so CP equal to 1, door opens and inputs can enter. It's like this clock is like a door. Okay, a door to sequential circuit where the inputs can be allowed, where the inputs cannot be allowed. Okay, the boundary is decided by the clock pulse, and such a circuit, okay, where inputs can be applied only at specific times. What are the specific times? These are the specific times. Okay, it may be the case you want the input to be available, okay, inputs to be applied at only for some duration and then blocked for most of the time. So you can change the duty cycle of the waveform. Okay, if you want, you can change the duty cycle of the waveform. आपको लगता है कि just for maybe 10 nanoseconds I will take the input, and for rest of the 90 nanoseconds the circuit will be performing. It needs more time to perform the calculation. So for most of the time you can make it 0. Rest everything depends on what actually you are computing, how much time you need to compute. So the duty cycle may be affected. Not a problem. You can decide your duty cycle. You can decide for how much time to accept the inputs, for how much time to decline the inputs. The clock, design of clock is totally in the user's hand. Design of clock totally in the user's hand. ठीक है जी? Okay, user's hand. ठीक है? So that is what is the clocked SR latch. This is what is the concept of clocking. Okay, now let's complete the characteristic equation and characteristic table for the SR latch. First starting for SR, then let's go to the JK and D and SR latch as well. Okay, let us go to the others as well. चलो इसको देखते हैं. Have a look into it. Okay, have a look into it. देखते हैं यहाँ पे dear. Okay, so we know that whenever SR is 0, 0, look into it. Whenever SR is 0, 0, what does it mean? Okay, the next state is same as the previous. Now I will call Q as the current state and Q plus as the next state. When I say Q, it means current. And when I say Q plus, it means next, upcoming state. Okay, but dear, when SR is 0, 0, whatever is the current value, that will only be followed. Na? Okay, if 0, copy 0 here. If 1, you copy 1 here. Clear हो गया? Clear हो गया? चलो, next. Now, S0, R1. What is 1? What is 1? R input is 1. R input 1. R is reset. Reset. So, whatever may be the previous state, independent of it, देखो, device is reset. At both the places it is reset. It will not depend on the previous now. Okay, device will sure reset. Okay, next combination, dear. I'm just explaining you this. Next combination, 1, 0. इसको देखेंगे. Okay, S is 1. Okay, and if S is 1, S stands for set, तो device should set. तो ये देखिए, ये रहा set and set. Whatever may be the previous doesn't matter. The output is set now. Okay, because you have applied S input. You have applied S input. Now, what about this, dear? Both the inputs 1, 1. I told you something about 1, 1. 1, 1 corresponds to invalid state. User should not apply 1, 1. User have to take care not to apply 1, 1. Okay, because that is a problem of SR latch. It goes to invalid state, and then moving after the invalid state, it may go to the indeterminate state. It may go to unstable oscillatory state. It can go to any unpredictable zone. So I don't want to device enter into invalid state. So as a user, you should apply not to apply this input. Okay. There is a solution to this invalid. We will talk about that. But for SR latch, you should not apply the input. So a particular input which will never be applied, a particular input which never comes, the output corresponding to it. If an input combination doesn't come, the output corresponding to it is treated as don't care. Na? यही तो don't care का concept होता है. Those input combinations which are not going to occur, the output corresponding to them is taken as don't care. The output corresponding to them is taken as don't care. The output corresponding to them is taken as don't care. Is taken as don't care. Okay? So that is why X is the don't care. Now very simple. What is next to be done? Next K map. यहीं पे बनाते हैं. ये लीजिए इसका K map बनाते हैं और आंसर को लिखते हैं. Okay. The inputs are Q SR. ABC नहीं है. The inputs are Q and then SR. Okay. I'll start filling up. We know that this is A. Like this is Q. This is S. This is known as R. Okay, so 0, 0, 1, X. Okay, 1, 0, 1, X. Only fill up the ones and the don't care. No need to fill the 0. And now start grouping and pairing. Chalo, great, great. All of you are enjoying. Great. Vishwajit, Manasvi, Nishu, all great. Dekho yahan pe. Okay. This is, I told you, no, don't care is your choice. You can take it as 1 or 0, whatever you feel. So I treat it as 1 so that I make a quad. This quad is completely within S. Now this one, don't take it alone. First and last column adjacent. Okay, adjacent. Okay, so I have taken it adjacent with the last column. This comes in Q and also outside R. So R bar Q. Okay, so what is the next state equation? Okay, what is the next state equation? Q plus. Okay, Q plus, and that is known as S plus R bar Q. Okay, that is known as S plus R bar Q. Okay, with the condition SR should be 0. By SR equal to 0 means SR can be 0, 0 or 0, 1 or 1, 0. Okay, it may not be 1, 1 because if SR is 1, 1, product will not be 0. So, a condition likh diya maine. This ensures that 1, 1 doesn't come. Okay, this is known as what? This is known as the characteristic equation. Characteristic equation of the SR latch, S plus R bar Q. And this is the graphic symbol. Okay, this is S, this is R, and this is the clock pulse. Since it is a clock pulse, okay, it's a latch. Now, abhi hum latch mein, next we'll go to the flip-flop. As I told you, the door opens, the device responds till the clock pulse equal to 1. Till the clock pulse equal to 1. देखो, इसको भी समझ लेते हैं. The device responds to level 1 of the clock. The device will keep responding till the clock pulse equal to 1. That clock pulse equal to 1 means door open. Okay, the device or the circuit which responds to a particular level of the clock. Okay, which responds to a particular level of the clock. Such circuit is known as level triggered. Level triggered circuit. Okay, it responds to a particular level of the clock and that level I have chosen to be 1. That level I have chosen to be 1. It responds to a particular level of the clock and till the time clock is at level 1, the circuit will keep taking the input, keep producing the output. That is level triggered circuit. The next category will be edge triggered. Okay, uski baat karte hain. But right now let's continue. Let's have some modifications with this SR latch. Okay, let's quickly go to the clocked D latch now. Let us quickly go to the clocked D latch. Let us go to the clocked D latch. Let us go to the clocked D latch. So chalo, dekhte hain. Let us look into the clocked D latch. So what is going to happen here? Diya dekho. Clock pulse. Again, you know the role of clock pulse now. Okay, and this is SR latch only. I will modify it to make it to the D latch. So clocked D latch is just a modification of the SR latch. What do you do? Okay, take the S input. Okay. Okay, connect it to some external variable D. Take the complement of the D and feed it to the R line. feed it to the R line. Now see what is going to happen here. Okay, of course to understand the operation, okay, we will be assuming clock pulse equal to 1, because if clock pulse equal to 0, we know nothing is going to happen. Okay, if clock pulse equal to 1, now you see if D equal to 0, then what happens? If D equal to 0, your S will become 0, but D complement goes to R. R becomes 1. Okay, so that is the reset condition, na? Reset condition का मतलब Q plus is equal to 0. The next state of the device will be 0. Clear? ठीक है. Next, अगर D का value 1 लिया, okay, if you take the D equal to 1, then what is going to happen? If you take D equal to 1, then S will be equal to 1. Okay, but D complement, that is R, will be equal to 0. That is the set condition, and set condition means the next state will be equal to 1. So very simply, what is the next state? What is the next state? The next state Q plus is 0 if the D is 0. The next state Q plus is 1 if the D is equal to 1. So I can simply say that the next state is just following the input. The next state is just following the input. No need to make any truth table here. It is very simple analysis. Q plus equal to D. Q plus equal to D. Directly you can say the characteristic equation. What is this known as? Characteristic equation. Okay. In the clock, like SR latch, S stands for set, R for reset. वो मैंने explain किया था. Like in D latch, what does D stands for? In the D latch, what does D stands for? D basically stands for, there are two arguments here. Okay, we can call it as a data copy latch. Okay, we can call it as a data copy latch. Okay, or we also call it as a delay latch. We also call it as a delay latch. Okay, we also call it as a D latch. Okay, D latch. D latch. So the weightage analysis we have done multiple times in the other session also, but let me tell you, for double E it is 4 to 5 marks, not even 5. For double E it is 3 to 4. For computer science 5 to 6. For electronics around 9 to 10. Yeah, at least 8. Okay. I repeat, double E 3 to 4 marks, because double E you have the mixed subject analog and digital electronics. Analog is coming up tomorrow. Okay, for computer science around 5 to 6 marks. Computer science में पहले कम होता था, but recently past 3-4 years you see 5 to 6 marks. And for electronics it is easily 9-10 marks, या minimum 8. Okay, for electronics. चलिए. Okay, the clocked D latch. Okay, data copy latch or the delay latch. Okay, or the delay latch. The data copy latch, also known as the delay latch. Now, why data copy? Because whatever data you apply here, okay, same is copied to the output. It is just copying the input. Okay, it is just copying the input. But what about the delay? Why it is a delay latch? Simple reason is, okay, whatever you apply here, it is going to hold the value, reproduce it after some time here. Okay, as I told you, Q plus equal to D. Whatever you apply here, same value is appeared here. Okay, but the same value is appearing here after a particular time, after a delay. Why delay? Because even when you open the clock pulse, the variable is going to flow through multiple gates, okay, inverters, then this AND gate structure, then NOR gate structure, and finally it is going to appear to the output. Finally it is going to appear to the output. Clear everybody? Finally it is going to appear to the output. Okay? So the data is reproduced as it is, but after a particular delay. So it holds the device, it holds the data for some time and then reproduces it to the output line, okay, after a particular delay. We also call it as a delay latch. ठीक है, ये कैरेक्टरिस्टिक टेबल हो गया. ऑलरेडी आई टोल्ड यू Q प्लस इक्वल टू D. ओके, सो इसको देखने का नीड ही नहीं है. ओके, वॉट एवर इज द D, 0 1 0 1, सेम इज कॉपी टू द Q प्लस, सेम इज कॉपी टू द Q प्लस. ठीक है, ओके, ठीक है, चलो. Okay, this is the basic graphic symbol again, showing that it's a clock pulse, level triggered clock. Again, whenever the clock is at level 1, the device will respond, otherwise it will not respond. Okay, characteristic equation already मैंने बता दिया था, that is the Q plus equal to D. Okay, now coming to the clocked JK latch, okay, which is the modification of the SR latch to remove the, okay, to remove the problem of invalid state. What is the problem with SR latch? Invalid state. To remove the problem of invalid state, okay, the clocked JK latch has been designed. What does JK stand for? Anybody? Any guesses? JK में JK stands for, by the time I will draw the modification. ये तो SR latch ही है. Now I'll draw the modification here manually. So what do? We take one more feedback connection from output Q, okay, and feed it to the first AND gate. Okay, and now we call this input as K input. We take another feedback connection from Q bar and again feed it to this AND gate. So AND gates here should be 3 input AND gates. Okay, and this S input will be now named as J input. No, this is not Johnson. Johnson is different. Johnson बाद में आएगा. Okay, yes, these are basically J and K dedicated to the name of the persons who overcome the problem for, okay, to overcome the problem for what? To overcome the problem for invalid state of SR latch, and these two persons are Jack and Kilby. These two persons are Jack and Kilby. If you only talk Jashwant with C, it has D latches have multiple advantages. But if you only talk with respect to even data copy, okay, it is better in the sense it is being controlled by a clock. You have to look into difference. It is a controlled circuit, okay, which can be controlled by clock. Okay. So Jack and Kilby. Okay, Jack and Kilby. Okay, so now guys, let's not derive it. Okay, हर चीज को derive करेंगे तो time will be exceeded. So what are the conclusions here? You should just remember the conclusions are very easy, यार. See, the main thing is understanding this latch. मैंने इससे start किया ना. If everybody understands this one, then there is no problem at all. There is no problem at all. Okay, बाकी सब तो just automatically can be derived. So within 2 minutes you can derive what happens with the JK. I'll write down here when J equal to K equal to 0, when both are 0, 0, Q plus will be Q. Okay, most of the combinations are same as SR. Most of the combinations are same as SR. Okay, if J is 1, K is 0. देखो J किसकी जगह लगाया मैंने? In place of S. Remember, like SR only. So what happens at S equal to 1? What happens at S equal to 1? Set state will come. Okay, J0, K1. K बोले तो R. What happens at R equal to 1? What happens at R equal to 1? Reset. Q plus will be 0. Okay. And then when both the inputs are 1, 1, which was invalid in SR, this produces a new state here, and that is known as the toggle state or complement state. That is toggle state or complement state. Okay. So देखो, this is same state condition. This is set condition. This is reset condition. And this is toggle. Okay, the Q plus equal to Q bar, whatever is the current value, that is going to toggle. Toggle बोले तो complement. This is the introduction of another state that is known as toggle state or the complement state. Toggle state or the complement state. Clear? This is the characteristic table again. Okay, rest all is same. देखो, आप again tally करके चल सकते हो. Okay, at 0, 0, okay, same state. Okay, if 0, copy 0. If 1, copy 1. Okay, next. J0, K1, reset. J0, K1, reset. Independent of the previous state. Okay, next देख लेते. Okay, 1, 0. J1, K0. J1, K0, that is set. This is set. Independent of previous. It is set. Okay, the change that you will observe here is, this 1, 1. The change that you observe here is this 1, 1. Okay, what happens at 1, 1? Okay, it was invalid in the SR latch, so we treat it as don't care. Okay, but here 1, 1, okay, it is a complement. If 0, complement will be 1. If the Q is equal to 1, complement will become 0. Okay, complement will become 0. Okay, 0 पे आ गया 1, 1 पे आ गया 0. ठीक है? Okay, so now when you again take the K map corresponding to it, that is corresponding to it, so, and let me start filling it up. This is Q, this is the input J, this is going to be the input K, filling it up 0, 0, 1, 1, then 1, 0, 1, 0. Okay, let's start making the pairs. This is one pair, and bottom also, first and last column adjacent, take it as a pair. This is clearly within J but outside Q, J Q bar, and this is in Q but outside K. अच्छा, ये K मैंने गलत लिख दिया है. Okay, this is outside K, but inside Q. Okay, K means what? K means the center 2. Just a second. K means the center 2. Okay. Just a second. ठीक है. This is what it is. Done. Okay, so what is the characteristic equation coming out to be? Q plus is equal to JQ bar plus K bar Q. JQ bar plus K bar Q. JQ bar plus K bar Q. Okay. Chalo, one quick discussion T latch and then we move towards the flip flops as well. Okay, this is now the clogged T latch. This is what is the clogged T latch. Okay, the clogged T latch coming up here now. Okay, have a look into it. Okay, have a look into it. Okay, clogged T latch is just a small modification of the JK latch where you commonly tie, you short both the inputs J and K, put J and K both equal to the 1. Put J and K both equal to the 1. Okay, sorry, put J and K both equal to the T. Okay, okay. Commonly short both the inputs and call the input now as T. Okay, now we know what is next. We know what is next. Okay, so if T equal to 0, this is going to be simple. If T equal to 0, that means JK are both equal to 0. That is the same state condition. Okay, but if T equal to 1, J and K are equal to 1 and J and K equal to 1 means toggle condition, and that is the reason we call it as the T input. T standing for toggle. T standing for toggle. Ki whenever T input is 1, the device will toggle. Okay, otherwise device will not do anything, but whenever T equal to 1, the device will toggle. Okay, I'll write it here only. Whenever T equal to 1, I'll write down the table here only. I think it is missing here. QT and Q plus. Okay, whenever T is 1, okay, device will toggle. 0 will become 1. Okay, whenever T is 1, device will toggle. So Q1 becomes 0. Now see, T0, no change. 0 ka 0. T0, no change. Q1 to Q plus equal to 1. This is the truth table. So definitely it is a truth table, same as XOR. Okay, when both the inputs Q and T are different, output is high. Okay, so Q plus is definitely Q XOR T. Okay, that is Q bar T plus QT bar. Okay, Q bar T plus QT bar. Next. Okay, next. Next, now let us learn the race around condition also. Next, let us learn the race around condition also. Race around condition. Race around condition ko dekhte hain. So what is the race around condition here? What is the race around condition here? Let us see the race around condition here. Let us see the race around condition here. Okay, let's understand with respect to a JK latch. Okay, latches are level triggered circuit. Okay, latches are level triggered circuit. ये हमने clear किया था. Okay, now let's have a look into this timing diagram. Okay, we know that the circuit is level triggered. Okay, till the time clock pulse equal to 1, it will keep performing. It will keep calculating the answer. ठीक है? What I have done, suppose I want to toggle the device. My objective is to toggle the device. Okay, this should be K. Okay, both are not J. This is K. My objective is to toggle the device. Okay, and to toggle a device, I will make both the JK equal to 1. That is what we do. That to toggle the device, we want JK equal to 1. Okay. Now, with respect to it, let me draw the Q waveform. Okay, initially assume Q equal to 0. Initially assume Q equal to 0. Okay. Initially assume that the Q equal to 0. ठीक है? चलो, तो Q को 0 मान लिया. Okay, Q को 0 मान लिया. Okay, now the device will toggle. Okay, but okay, you have made the JK11, but is the door open? What is this clock in the synchronous circuit? Level triggered, but the clock is like what? Clock is just like a door. If the door is closed, here door is closed. So whether you made the input 1-1, that is not going to come inside. They will only come inside when the door is open. When the door is open. Okay, so the output is not at all going to change until this point. The output is not at all going to change until this point. Okay, till this point output is not at all going to change. Output is not at all going to change. अब क्या करना है? Okay, now here output becomes equal to 1. Okay, here the output becomes, here the clock becomes equal to 1. Door is open. Door is open. Now the inputs will be seen, and inputs are now 1, 1. They will be welcomed inside and the circuit will reset. But of course, circuit will also have a time to reset. Na? Let us assume that the device takes a time of how much? यहाँ पे मैंने 20 रखा है ना? Let us assume that the device takes a time of 8 nanosecond to reset, to perform one operation. Assume it. Okay, let's assume a value. Okay, so starting from this point, this is the point when door is open. Okay, starting from this point, okay, after 8 nanoseconds, suppose this is 8 nanosecond, device now toggles. Now the problem with level triggered circuit again. Level triggered, the device will respond till the clock is at level 1. Clock is at level 1 means door open. Okay, what is this? This is like a door open to you. Okay, now when the device has toggled once, listen to the very, very important point. Okay, when the device has toggled one, what is going to happen? जब एक बार device toggle हो गया ना, door तो अभी भी open है. Door is still open, and if the door is open, inputs 1, 1 are still welcomed. Level triggered, unless and until the door is open, inputs are welcome, most welcome. Okay, so toggle is occurred, but door to abhi bhi open, and door to open hai, so inputs can again come. And what are the inputs? I left the input at 1, 1. Okay, so again toggle can occur. Okay, so again toggle will occur. But again time to toggle will be 8 more nanoseconds. So I come here up to 16 nanoseconds. Again a toggle will occur, and this goes up to the 16 nanosecond. Clear? This goes up to the 16 nanosecond. This goes up to the 16 nanosecond. Okay, ये चला गया 16 nanosecond तक. Now what is next? This goes up to the 16 nanosecond. What's next? What is next going to happen? So देखो, next what is going to happen na? After 16 nanoseconds, again the door is open. Again the inputs 1, 1 accept. Okay, welcome. And if the inputs are again welcome, the device will again try to toggle. But the time to toggle is 8 nanosecond. Okay, but door will be closed at 20 nanoseconds. Okay, so one more toggle will not occur actually. Because the time to complete toggle is not available. In between, door will closed. Okay, so this is what is the final output. Now, if some user who does not know the internals of the circuit, that user will look, I started with Q equal to 0. My device was initially reset. To toggle the device, I applied 1, 1, so it should be set. But at the end, I am again getting a 0. What a user may think that the circuit is not performing. The circuit is not operational. But is it the case that the circuit is not responding? No, dear, circuit is definitely responding. Actually, it responded twice. The circuit has responded twice. To be honest, circuit has responded twice. Sahi bola jaye to. Circuit has responded twice. Okay. And that is why double toggle occurred, and that is why you get the same output. Okay. So problem is not with the circuit. Problem is somewhere with the timings. Okay. Okay. Now what is the possibility to avoid this condition? देखो problem क्या हुआ? That the time to delay is 8 nanosecond. Okay. Time to delay is 8 nanosecond. At 8 nanosecond, okay, one delay occurred. You applied the input. Okay, you applied the clock at t equal to 0. Okay, and this is going to active till 20 nanosecond. But the toggle occurred at 8 nanosecond. Okay, now as soon as when toggle occurred, ultimately it's a feedback circuit, a sequential circuit. Okay, this appears here and clock is still active. Clock bhi yahan pe ja raha hai na. Clock is still active. Okay. Now look into these two inputs there. Okay, one of the input is coming from Q and one of the input is from clock. अच्छा, if the clock went 0, अगर clock 0 हो जाता, Suppose if the clock goes zeros only after 8 nanosecond, then double toggle will not occur, but clock is there for longer time. Okay, yeah, maybe if the delay was not 8, maybe if the delay itself was 18 nanosecond, if this comes at 18, if this comes at 18, then also double toggle will not occur. By if one toggle itself, if one toggle occurs at 18 nanosecond, the next toggle will occur at 36, but clock goes off at 20, so only one toggle will occur. Clear, na? Then only one toggle will occur. So it depends basically there. I'm telling you two possibility. Either this was 18 or either the clock goes at 8 only. Okay. So it's a timing combination race. Okay. Between two variables. One is the output variable and one is the input clock variable. There is a race going on between, okay, our output variable and the clock input variable. This is known as a race around condition. Why around? Because the race is between an input variable and a variable coming through a feedback path around the circuit. Around the circuit. Okay. It is a race around condition. Okay. Now, as I mentioned, okay, okay, one of the method to avoid is, okay, maybe the clock delay, okay, maybe the clock goes off only at 8 nanoseconds at 10 nanoseconds. Suppose if the clock goes off only at 10 nanosecond, not 20. If the clock goes off only at 10 nanosecond, then double toggle will not occur. And double toggle occur at 16, but the clock goes off only at 10. So double toggle will not occur. So one way is adjusting the time period of the clock, means frequency of the clock. One of the ways playing with the frequency of the clock. But the problem is the same clock may be going to other parts of the circuit also. Okay, maybe going to the other parts of the circuit also. Okay, so देखो, one way to avoid it. Okay, the clock must have a time period according to the propagation delay through the latch. Okay, but this might affect the operation of the remaining circuit. Okay, this might affect the operation of the remaining circuit. Thus, there is a clock, okay, which goes to the JK latch also. Same clock goes to some other circuit also. If you change the time period of the clock, this circuit may be at fault. This remaining circuit may be at fault. So we don't take that risk. But the proper solution is, okay, use master slave or edge triggered flip-flops. Okay, use master slave or edge triggered flip-flop. Okay, those devices which will not be level triggered now, but they will only be responding to. They respond only to the transition of the clock, not to the level of the clock. Only respond to the transition of the clock, not to the level of the clock. Okay, not to the level of the clock. Not to the level of the clock. Okay. Okay, that means, देखो, there are three possibilities here. देखो, there are the three possibilities here. The first one is basically a latch, level triggered circuit. The first one is a level triggered circuit, that is a latch, which responds, okay, till the clock pulse is at 1. Till the clock pulse is at 1. The door is open till the clock pulse is at 1. Okay, that is what we were discussing till now. The next category is flip-flop, which will not respond to the level of the clock, but that will respond to the edge, transition of the clock. Now, transitions are of two types. Okay, 0 to 1 or 1 to 0. Okay, the type of device which will respond to the 0 to 1 transition, that is also edge triggered. We call it as positive edge triggered. Positive edge triggered flip-flop. Similarly, there can be a device which responds to the negative edge of the clock. What is negative edge? Transition from 1 to 0. What is negative edge? Transition from 1 to 0. Such a device is known as negative edge triggered. Okay, such a device is known as the negative edge triggered flip-flop. Such a device is basically known as the negative edge triggered flip-flop. Clear? Negative edge triggered flip-flop. Okay, so there can be transition. Okay, the devices which will respond to the pulse transition rather than the pulse duration. Okay, there can be positive edge triggered flip-flop, there can be negative edge triggered flip-flop, as I explained you. All right. Okay. Chalo. Okay. Now have a look into the design, okay, of master slave flip-flop, okay, in which we call this as master flip-flop and we call it as the slave flip-flop. Okay, what is slave? Gulam. So why we call master and slave? Abhi wo samajh mein aa jayega. But let me know, guys, if you are feeling tired now. I see the attendance dropping. If you feel tired, let me stop. I know it's more than 5.5 hours, but if you feel tired, then we can stop. This is going to be the PDF password. I'm not stopping immediately. Don't worry, I'm not stopping. Okay, but this is going to be the PDF password. Okay. In between, okay. In between, let me tell you the PDF password. Master, just randomly crafted. Okay, master slave ka master. Everything in small. Master, that's going to be the PDF password. Okay, PDF password. Okay, master. Chalo, done hai. Okay, so you can access the PDF using this master. Okay, now let's come back here. Individually, both of them are latches. This is the master latch. This is the slave latch. This is a master latch. This is a slave latch. This one is a master latch. This one is a slave latch. Okay, now both of them are fed with the opposite polarity of clock. I mean, this is fed with clock. The other one takes the clock pulse. Okay, here I apply clock. Here I apply the clock bar. Okay, here I apply the inversion, that is the clock bar. Okay. Okay, so dekhna now. What is going to happen now? Suppose if clock equal to 1, then what happens? Okay, if clock equal to 1, then what happens, dear? When the clock is equal to 1, master is computing. Okay, master is computing. This is the master latch. Okay, clock equal to 1 means this is on. Okay, so at clock equal to 1, master on, slave off. Correct. Master on, but slave will be off. Acha. A master produces Y. Because the master is on, it computes Y. ठीक है ना? What is the output of the master? Y. That output will be calculated. But what is the final output of the circuit is Q. That is unaffected because the final output is the output of slave and slave is disabled right now. Okay. So slave is off, Q unaffected. Okay. Now make the clock equal to 0. If clock equal to 0, master will become off. Okay. Now since the master is off, this is off. So external inputs are not going to enter the system. Because the external inputs are applied to the master latch and external inputs will not enter the system. Okay. External JK inputs are now blocked. Because master off, they are blocked. Now slave will be on actually. Now the slave is on. Okay, now what is the role of the slave? Now have a look into the characteristic equation of the slave. Okay, have a look into the characteristic equation of the slave. Slave ki characteristic equation ko dekhna, dear. Okay, so what is going to be the characteristic equation of the slave? It is given by J Q bar plus K bar Q, but what is there on the J? Dekho, J Q bar plus K bar Q. What is there on the J? J equal to Y. Okay, j q bar plus k bar. But what is there on the k? It is y bar. So y bar ka bar, okay, will be y common, q bar plus q equal to 1. Okay, so q plus is basically equal to the y. Q plus is basically equal to the y. Okay. Q plus is basically equal to y. So what is the role of slave? Okay. Whatever is the y which is calculated by the master, it copies to the output. The role of slave is to copy. Gulami karna. जो मास्टर ने कमांड दिया उसको फॉलो करना. Master has given the command y, it will just copy that command. It will just follow the commands. That is why this is known as slave. That is why this is known as slave. I hope you get the literal meaning also. Slave means gulam. Whatever master commands, it will just copy. It will just copy. It will just copy. Okay, so it will just copy. Okay, the master commands. It will copy the master output. Okay, to the q. Okay, as I mentioned, q plus will be y. Okay, that is why this is known as slave. Okay, that is why this is known as slave. So when are you getting the output, dear? When are you getting the output? When the clock made the transition from 1 to 0. इससे पहले मैंने clock 1 लिया. Now I take the clock 0. Prior to this clock was 1. Now the clock becomes 0. Now the clock becomes 0. Okay. Okay. Earlier clock was 1. Now it becomes 0. And that is why. Okay. This is a response. Now here. Here, y is computed. Now, when the clock becomes 0, here, output q is obtained. So, देखो, y तो intermediate variable है. User is not bothered about intermediate variable. User will see that when is the output occurred. When is the output occurred? When is this output occurred? User will find that this output has occurred, okay, when the clock made the transition from 1 to 0. And now when the clock has made the transition from 0, I told you one more thing. When the clock is 0, master is off. So further new inputs will not be affecting the system. Okay, further new inputs will not be affecting the system. Okay, new inputs will not be affecting the system. Okay, so these are blocked. Okay, these inputs are blocked. Okay, so that means agar even if one toggle occurred, okay, even if one toggle occurred, another toggle will not occur because inputs are now blocked. Inputs are now blocked. Clear, everybody? Okay. Here Q is obtained. Okay, and the inputs are blocked. And the inputs are blocked. And the inputs are blocked. Acha, listen to me now. Listen to me. Listen to me. Very carefully. Listen to me very carefully now. चलो अच्छा उस पॉइंट को बाद में डिस्कस करते हैं. अभी चलते हैं आगे की तरफ. Okay, so these are the difference in the graphic symbol. Okay, now till now for latch we were representing the graphic symbol by a clock pulse. We were representing the graphic symbol by a clock pulse. Okay, but here we represent by a triangle meaning edge triggered and triangle with the bubble meaning negative edge triggered. Okay, these are the graphic symbols of positive edge triggered and negative edge triggered. So whenever you see the triangle, it means edge triggered device. This is positive edge triggered. This is negative edge triggered. Positive edge triggered, negative edge triggered. Clear, everybody? This one is positive edge triggered. This one is known as the negative edge triggered. Done. अच्छा जी चलते हैं. ठीक है, done है. Okay. Now, first of all, let me explain you what can be the state diagram for. Okay, let me explain you the state diagram for JK flip flop. चलो JK flip flop का समझाता हूँ. How do you draw the state diagram for JK flip flop? Any flip flop can be in two states, either reset or set. Okay, any flip flop can be in two states, either reset or either the set. Q equal to 0 or Q equal to 1. Okay. Now state diagram means you have to show every state transition based on the value of the input. Okay, so if the input is 0 0, if the input is 0 0, what happens in the JK flip-flop? If the input is 0 0, what happens? The device remains in the same state. Okay, so if the input which is specified on the arrow, input is 0 0, okay, if the Q was 0, it remains to be 0. If the Q was 1, that also remains to be 1 if the input is 0 0. If the input is 0 0. Now if the input is 0 1, okay, if the input is 0 1, what is 0 1? Take 0 0 ले लिया. Now what is 0 1? J0K1 reset. J0K1 reset. Okay, the device will be in the reset state. If it is already reset, it will remain here. But if it is set also, na, when you apply the input, which input? When you apply the input 0 1, okay, the device is going to reset. Even though it is in set, it will come to the reset state. Okay. Next is 1 0. Next is 1 0. Okay. Next is 1 0. What is 1 0? J1K0. So if J equal to 1, device will set. So if it is in reset, take the transition to the set if the input is 1 0. If it is by chance set, it will remain in set. Okay. So like, what is the meaning of the comma here? Sorry, input was 1 0. What is the meaning of this comma? That whether the input is 0 0 or 1 0, same transition will be there. Okay, 0 0 means anyway same state. 1 0 means set state. So because already you are in set, you will remain in the set state. Okay, for both of the input, you will have the similar transition. That is the meaning of comma. Comma specifies different sets of input for which same transition is followed. Okay, next 1 1. What is 1 1? 1 1 bole to toggle. Okay, so if the device is reset, it will go to the set state. So same transition at the input 1 1. So comma karke likha. And if the device is set, it will come to the reset if the input is 1 1. If the input is 1 1. Okay. So for the input 1 1, I have shown the toggle. I have shown the toggle. Okay. No, invalid SR ke liye hota hai. JK ke liye it is valid. This is JK. Similarly, can we draw for T flip flop also quickly? Let us draw for the T flip flop also quickly. T flip flop, only one input is there, na? But state again can be 2. It can be in 2 state, either 0 or 1. Q equal to 0, Q equal to 1. आएगा काउंटर भी आ रहा है विश्वदीप जल्दी. Okay, either Q equal to 0, Q equal to 1. Now simple, if T input is 0, device will remain in the same state. ये तो बहुत simple हो गया. If T input is 0, device will remain in the same state. But if T input is 1, device will toggle. Okay, toggle. 0 becomes 1. Yeah, if you are in 1, it will become 0. 0 becomes 1, 1 becomes 0. 0 becomes 1, 1 becomes 0. Zero becomes 1, 1 becomes 0. That is what it is. Clear everybody? Okay ji. Okay. That is what is the answer. Okay. Now I'll give you homework to draw the state diagram for SR flip-flop and D flip-flop. Draw the state diagram for the SR flip-flop and D flip-flop. Okay, SR flip-flop and D flip-flop. Okay. Now there can be miscellaneous questions on the state diagram. Have a look into it. Okay, a gate 19 question. Intentionally a gate question I have taken here. What is the state transition diagram? You should be able to solve such questions also. You should be able to solve such questions also. Okay, and there is one more good question. जो recently आया था. I'll see. I have it in the PDF. No, I will take it question from my directory. Don't worry. There is one recent very good question on state diagram. वो भी discuss करेंगे अभी. Okay, last में 1 means कहाँ? हाँ. Sorry, that's a typo error. Undoubtedly, this is 1. 0 पे no change and 1 पे toggle. Okay, yeah, please do it quickly. For any given circuit, it's a combination of D flip-flop with the multiplexer, a 2x1 multiplexer. What state transition diagram will be followed? Just a minute. Huh? Okay. Okay, so let's check it now. Let's check it if you have solved by chance. Chalo. Okay. So, A is the specified input here, okay? All the transitions are marked with respect to A. So, this is what your input is. This is the input A. Okay, and the state Q means the state of the flip-flop automatically. Okay, now first let's analyze this circuit. Okay, what is going to happen? See, what is the next state? Dekhna yahan pe. What is the next state? Q plus. Look into this circuit. Look into the circuit. Because it's a D flip-flop, so what is Q plus? We know the transition equation. For D flip-flop, Q plus equal to D. Okay, Q plus equal to D. Now D is the output of this NAND gate. Okay, where the input of the NAND gate, one of the input is Q and another one is coming from the output of the multiplexer. Suppose of the output of the multiplexer is Y. Okay, so that is the NAND gate output Q into Y whole bar. So D is equal to Q into Y whole bar. Okay, D is equal to Q into Y whole bar. Now further, what is the value of Y? Further, what is the value of Y? अब देखो depend करेगा. Okay, Y, it may be equal to Q or it may be equal to Q bar. That depends on the select line. Okay, the output of the multiplexer depends on the select line. So dekho, if the select line is equal to 0, the I0 will be selected. So Y will become Q bar. So Q into Q bar ka whole bar. Okay, Q into Q bar ka whole bar. Ye kitna hua? Q into Q bar 0, 0 complement is 1. Okay, if the select line is 0. ठीक है? But if the select line is 1, then it is Q into Q. If the select line is 1, I1 will be selected, which is Q. So Y is Q into Q ka whole bar. That is simply Q bar if A is 1. Hope that is visible. ठीक है? Okay. यहाँ पे A लिया है 0, यहाँ पे A लिया है 1. फिर से लिख दिया, ठीक है? So now let me summarize it here. If A is equal to 0, what is the next state? Dear, look into it. If A is 0, next state is all automatically 1. Q plus is 1. Okay. But if A is equal to 1, the Q plus is equal to Q bar, that is toggle. Q plus equal to Q bar, that is toggle. Okay. Now, I don't look at the option here. Very easily we can draw it. Na? Okay. Dekho, if the input is 1, toggle karenge. If the input is 1, you will toggle. 0 becomes 1, 1 becomes 0. But if the input is 0, you will go to the Q plus equal to 1. This is known as set condition and this is known as toggle condition. Okay, if the input is 0, see, if you're already in the set state, you will remain in set state. Sorry, for the input 0. But if you are in reset also, you will go to the set state if the input is 0. So यहाँ पे 0, 1. Now, I told you options. Okay, you can take input by comma, or if you want, you can show separate lines also. Normally, it is good to show with comma. Why? To make the number of lines more. But in the option, I think they have shown with the 2 different lines. Ye raha. Yeah, correct answer looks like C. 1 पे toggle है, perfect है. And 0 पे set state है. Perfect answer is B, dear. Have a look into it. Yeah, B. Correct, Rishwajit. Correct, Bhanu. Yes, B is the correct answer. So good question here. Sorry, C is the correct answer. आपने B बोल दिया क्या? C. Okay, Bhanu and Vishwajit, check. It is not B, it is C. It is C. Nishu, correct, C. B तो ये रहा. This is C. C, correct, Krish. The answer is C. ठीक है जी. Ultimately, analysis of the circuit put into the state diagram. ठीक है. अच्छा, जैसा कि मैं बोल रहा था, there is one good question that I want to discuss here. That is gate 22, 2 marks. MSQ question. Okay. Gate 22, 2 marks MSQ question. I have opened it in my dictionary. In my system, I have opened it. I'll draw the state transition diagram. There are 3 states given to you. Okay. The 3 states given to you A, B, C. Okay. From A to B, you can make a transition, but with some probability P1. Okay. From B, you can remain to B with some probability P2. From B, you can come back to the state A with the probability P3. Okay. From A, you can go to the state C with some probability P4. With C, you can remain in the state C with probability P5. From the C, you can go back to the state A with some probability P6. Okay. And with the A, you can remain in the same state A with the probability P7. Okay. Now here, every transition is associated with the probability. Every transition is associated with the probability. The transition may or may not occur. If it occurs with the probability P1. Okay. So here, P1 to P7 are transition probabilities. They are given to you as transition probabilities. Very good logical question mixed with the state diagram. Okay. Okay. Now, which of the options are correct? Multiple select question hai. Okay. There are 4 options. One or more may be correct. One or more may be correct. P2 plus P3 is P5 plus P6. Option number A hai. P2 plus P3 is equal to P5 plus P6 is P5 plus P6. P1 plus P3 equal to P1 plus P3 equal to P4 plus P6. Okay. Option number C. P1 plus P4 plus P7 equal to 1. P2 plus P5 plus P7. P2 plus P5 plus P7 equal to the 1. Alright, this is the question. Oh, let me also check. So if we are close to 250 likes, let's target it, guys. Come on. Let's target. It's been now almost 6 hours of the session. And yes, let's target the 250 likes, just 12 short of it. Alright, guys. Chalo, aa jate. Okay, so which of the options is correct? Now, what can happen with respect to any transition? Okay, with respect to any state. See, suppose you are in state A. Okay, suppose you are in state A. Dekho, dhyan dena. Suppose you are in the state A. Suppose you are there in the state A. Okay, what can happen? Okay, your next state may be A, or you may go to B, or you may go to C. That is what can happen. Na? Okay, from A, okay, you can remain to A. From A, you can go to B. Or from A, you can go to C. This is the list of all possible outcomes. Okay, you remain in A with the probability P7. You remain in A with the probability P7. You go to the B with the probability P1. You go to the C with the probability P4. Okay, but this is the all possible outcomes. Okay, this is all possibilities. I am writing here with respect to state A. Okay, so sum of all possible outcomes. Sum of all possible outcomes is 1. Na? The sum of probabilities of all possible outcome is always 1. So P1 plus P4 plus P7 is 1. At least option number C aa gaya. Same thing you must try for B also. Same thing you must try for B also. So similarly, B to A, B to B, B to C. Okay, B to A. You go from B to A with the probability P3. Okay. You remain B to B with the probability P2. You go from B to C. Now there is no arrow from B to C. That means that particular event cannot occur, and something cannot occur. If something cannot occur, its probability is 0. Its probability is 0. Okay, so here P2 plus P3 will be 1. Sum of probability of all possible outcomes is 1. Okay, similarly with respect to state C. Okay, from C you can go to A, from C you can go to B, from C you can remain in C. C to A transition probability P6. C to B transition, there is no C to B transition. Something which cannot occur, probability 0. And C to C, you remain in the state C with the probability P5. And again, list of all possible outcomes. P5 plus P6 equal to the 1. P5 plus P6 equal to the 1. Okay, so P2 plus P3 is P5 plus P6. P2 plus P3, okay, is P5 plus P6. Correct answer is option number A. Okay, and also option number C. Okay, both are equal, option number A में both are equal and equal to 1. ठीक है, option A and as well as okay, option number C. ठीक है. All the questions Vishwadit are relevant to ECEE computer science instrumentation. सबके लिए relevant है. Nothing to worry here. Okay. Next. Okay. Now let us talk about the design of synchronous counter. Synchronous and ripple. पहले दोनों को study करते हैं. Okay, the synchronous counter and the ripple counter. Okay, so basically in the synchronous counter, all the flip-flops will be using the common clock. Okay, and in ripple counter, okay, the clock is applied only to the LSB flip-flop, and then the output of every flip-flop will serve as the clock to the next. तो पहले synchronous को देखते हैं, where all the flip-flops, synchronous counter में, what is the meaning of the word synchronous? That all flip-flops are synchronized by a common clock. All the flip-flops are synchronized by a common clock. All the flip-flops are synchronized by a common clock. Okay. Now let us design a 3-bit binary synchronous up counter using T flip-flop. Okay, up counter. It counts up. Regular 3-bit binary up counter. So 000, 001, 010, 011, 100, 100, 101, 110, 111 and back to 000. Okay, once you achieve the last state, it will go to the initial state again 000. Okay, till the time it is powered on, okay, it will keep counting from 000 up to 111, back to 000 and etc. 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 Okay. Okay. 000, 001, 010, etc. 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 up to 111, back to 000. Okay, now how to design it? You first start with the excitation table. Okay, what I'm going to do in this excitation table, I take a current state and I take a next state. Okay, for every current state, write down the next state. Okay, for every current state, write down the next state. So suppose the current state is 000. What is going to be the next state? 001, because ये table follow करना regular up counter. Okay, after 01, after 12. So if the current state is 001, next will be 010. If the current is 010, next is 011 and etc. till the last. If the current is 111, after 111, I told you, you have to go to 000. Okay, so after 111, 000 will be the next state. Okay, this is what we have to implement. To implement this, what should be the T flip-flop input? Normally, till now, you know, if a T flip-flop input is given, what is going to be the next state? But here the next state of a flip-flop is given. Current state and next state both are given. To achieve that transition, what is the value of the input signal to the flip-flop? That is known as the excitation signal. That is here known as the excitation signal. Okay, अब देखना यहाँ पे how to design this excitation signal. How to write down this excitation signal. Please notice here. Okay, to decide the excitation signal for TQ2. Okay, that is a T input to the Q2 flip-flop. TQ2. You will look into the transition only for Q2. You will look into the transition only for Q2, correct? Only for Q2. So देखो, Q2, 0 से 0. Look into the transition only for Q2 right now. Okay, 0 to 0. Same. Now, whenever you have a same state, T input should be 0, na? Okay. Next again देखेंगे. Okay, this was 0 to 0. Next again 0 to 0. Okay, next again 0 to 0. Whenever there is no change in the state, the T input is 0. But now look into the next entry. I am only looking into Q2. 0 to 1. 0 to 1 means toggle occurred, and toggle means toggle will occur only when T input is 1. So you are deciding to input now given the transition. So T input should be 1 here. T input should be 1 here. ठीक है? Next देखते हैं चलो. Now what is next? Okay, 1 to 1 again same. 1 to 1 same. 1 to 1 same. So same पे keep putting zeros. But last 1 to 0. Okay, 1 to 0. It is a toggle. Change toggle, and toggle के लिए T input should be 1. So this is the T2 entry completed. This is the T2 entry completed. Similarly, to decide the TQ1 input, I will be looking into the transition of Q1. Okay, now let's look into the transition for Q1. Now let's look into the transition for Q1. This is Q1. This is Q1 plus. Okay, we have Q1 and Q1 plus. Okay, so now 0 to 0, no change. Okay, 0 to 1, toggle. Okay, 1 to 1, no change. Okay, 1 to 0, toggle. Okay, 0 to 0, no change. 0 to 1, toggle. 1 to 1, no change. Okay, and 1 to 0, toggle. This is TQ1. Okay. Okay, now similarly TQ0, and for TQ0 you will be looking into the Q0. आप Q0 को देखेंगे, ठीक है? आप Q0 को देखेंगे. This is Q0 and Q0 plus. This is known as the Q0 and Q0 plus. Okay, so 0 to 1 toggle, 1 to 0 toggle, again 0 to 1 toggle, 1 to 0 toggle, 0 to 1 toggle, 1 to 0 toggle, 0 to 1 toggle, 1 to 0. That means for every possibility toggles. Okay, so that means what is the TQ0 input? That is fixed at 1. That is fixed at 1. Clear? That is fixed at 1. That is what is fixed at 1. Okay, that is fixed at 1. Okay, so now to implement the hardware of the circuit, we need to decide what is the functionality of T2, T1 and T0, and then we'll implement the functionality using the gates. Okay, one thing is very clear, TQ0 को solve नहीं करना है because TQ0 is always 1. That is solved. Okay, next I will solve for TQ1. I will solve for TQ1. Okay, by the K-maps, alternate 0, 1, 0, 1, 0, 1, 0, 1. I will take the K-map corresponding to it and solve it. This is Q2, Q1, Q0. Okay, sometimes there can be design based question also, designing a synchronous circuit even in the objective question. So that is why I am discussing this procedure. अब देखो 0 1 0 1 0 1 0 1 ग्रे कोड को फॉलो करते हुए, ठीक है? So now there is definitely one chord, one and only one chord coming up here, and that chord is in Q0. So you have TQ1 which is equal to Q0. You have TQ1 which is equal to the Q0. Which is equal to what? Which is equal to the Q0. ठीक है? Now similarly, last but not the least, TQ2 पे आ जाते हैं. उसका भी K-map entry कर देंगे. Okay, so 0 0 0 1 0 0 0 1. Okay, 0 0 0 1 0 0 again 0 and 1. So only one pair coming up. Okay, and that is the pair in Q1 and Q0. Okay, Q1 and Q0. Okay, so what is the value of TQ2? It is simply Q1 Q0. It is simply Q1 Q0. It is simply Q1 and Q0. It is known as the Q1 Q0. ठीक है, done है. चलो. So look into the logic circuit diagram here. That is what it is. अच्छा, some inputs are misplaced. I will write it here perfectly. ये देख लीजिए. Forget everything. This is T2 input. This is T1 input. This is the T0 output. Okay, which is fixed. T0 input is fixed at 1. Okay, what is the T1 input? देखिए, what is the T1 input? That is equal to the Q0. That is equal to the Q0. Okay, that is equal to the Q0. So देखो, this Q0 has been taken here and placed. This Q0 has been taken here and applied to the T1. Now what is the T2 input here? What is the T2 input? Q1 Q0. What is the T2 input here? That is, ये रहा Q1, ये रहा Q0, and this is the Q1 Q0 that is fed to the T2 input. This is what is a 3-bit up synchronous counter. Synchronous means all the flip-flops are fed with the common clock. All the flip-flops are supplied with one and only one clock. One and only one clock. Okay. One and only one clock. Acha. This is, okay, this is a 3-bit design. Okay. This was a 3-bit design. Correct? this was a 3-bit design. We got T0 equal to 1. We got T1 equal to the Q0 previous output. We got T2 equal to the product of the previous two Q1, Q0. Suppose dear, if you go for 4-bit also na, 4-bit up counter na, synchronous की बात कर रहा हूँ मैं. Okay, I'm talking about synchronous only right now. Okay, this was 3-bit up. Now if you go for 4-bit up also na, I'll tell you only one small change. I'll tell you only one small change coming up. And what is that one small change? T0 will always be 1. Okay, T0 is always 1. T1 will be Q0 here. T2 will remain to be same, Q1, Q0. Okay, T3 will come, another flip-flop. Now for 4-bit you need 4 flip-flop, another flip-flop, and that will be equal to the product of the Q output of the previous 3 flip-flops, that is Q2, Q1, Q0. That is Q2, Q1, Q0. Getting it? Similarly, if you want to design a 5-bit, Q3, Q2, Q1, Q0 next aa jayega. Okay, that pattern will continue. Okay, specifically for up counter. Okay, specifically for up counter. So dekho. Okay, there are two important differences that I will highlight for synchronous and ripple counter. For synchronous and ripple counter. Okay, first in terms of hardware. Okay, what is the hardware of synchronous counter? It will have n flip-flops. Of course, I'm talking about n-bit design. Considering n-bit design. Okay, I'm talking about. Okay, what happened again? Okay, n flip-flops plus something. Whereas ripple counter, I will start discussing ripple counter also. Okay, but ripple counter for n bit will only contain n flip-flops. Will only contain n flip-flops. That is only and only going to contain n flip-flops. Clear? Okay, if you talk about a ripple counter for n bit ripple counter, and similarly I'm talking about a n-bit synchronous counter. But in synchronous counter, in addition to the n flip-flops, what else do you need? In addition to the n flip-flops, you need some AND gates. Like here, you got one AND gate. In the 3-bit design, you got one AND gate, one 2-input AND gate. Okay, here in the 4-bit, one AND gate, 3-input AND gate. No, this will not be 3-input AND gate. देखो Q1 Q0 is already designed na? Q1 Q0 is already designed. Okay, that is already available at the output of the first AND gate. What will you do? Okay, you'll just have to AND with Q2. So one more AND gate of 2 input only. भाई अगर यहीं पे show करूँ, this is already available ना? You will take the next flip-flop that will have the T3 input and Q3 output. You will take Q3, multiply with the Q1 Q0 already available, and then feed to the T3. This becomes 4-bit, and same clock you apply here also. This becomes the 4-bit design. So another AND gate also you need, but that is 2 input capacity only. Okay, but for 4-bit design, how many AND gates? 2 AND gates. So in general, how many AND gates? Okay, n minus 2 AND gates. N minus 2 AND gates. 2 input AND gates, ठीक है? N minus 2 2 input AND gates. ठीक है? N minus 2 2 input AND gates. Okay, but for ripple counter, it's going to be n flip-flops only. Okay, it's going to be n flip-flops only. It is only and only going to be the n flip-flops. Clear? It is only and only going to be the n flip-flops. Now have a look into the ripple counter. The next parameter, speed. Okay, अभी speed की बात करेंगे, propagation delay की बात करेंगे. Okay, अभी speed की बात करेंगे, propagation delay की बात करेंगे. Okay, speed and propagation delay. ठीक है. अच्छा, here let me write down the propagation delay answer. Okay, the total propagation delay of ripple counter is just equal to TFF. Now, what is TFF? Let TFF equal to propagation delay. Okay, TFF also known as T clock to Q. Okay, or T clock to Q, propagation delay of each flip-flop. हर एक flip-flop का delay TFF मान लेते हैं. Okay, then the total delay of synchronous is just equal to delay of one flip-flop. Why? The total delay here is equal to the delay of one flip-flop. Why? Because all the flip-flops are active simultaneously. That is what synchronous means. Okay, that is what synchronous means. Once the clock edge comes, kaun sa edge hai? Positive edge triggered hai. So as soon as you get the clock positive edge, same clock hai na? As soon as you get the clock positive edge, all the flip-flops are active at the same time. Suppose all needs a time of 10 nanoseconds. Assuming identical flip-flops. Suppose all needs a time of 10 nanoseconds. Because all are active at the same time. Why they are active at the same time? Because it is a synchronous circuit. Okay, same clock is applied to all. And all of them are active at the clock. Okay, so because they are active at the same time, sabhi ka door open hua ek saath and everybody needs 10 nanosecond time. So all the 3 bits will be produced. All the 3 bits will be produced simultaneously after 10 nanoseconds. All the 3 bits will be produced simultaneously after 10 nanoseconds, yes or no? Okay, that means whatever is the delay of individual flip-flop, that will be the total delay, because all the 3 devices active at the same time, they end at the same time. They end at the same time, clear? They end at the same time. Okay, yes, parallel output, correct. They end at the same time. Okay, so the total delay is just equal to the delay of one flip-flop, that is TFF. Okay, that is TFF. That is why the minimum time period of the clock, now think about this, the minimum time period of the clock is also TFF, and the maximum clock frequency, the clock frequency is 1 upon time period. The maximum clock frequency, is pe question aata hai, the maximum clock frequency at which a ripple counter can be operated is given by 1 upon TFF. The maximum clock frequency at which a synchronous counter, sorry, not ripple, the maximum clock frequency at which ripple counter, synchronous counter is operated is 1 upon TFF. Is 1 upon TFF. You get questions on these fundamentals also, that is why I am highlighting. Okay. Now let us come to ripple counter. And as I told you, ripple counter, all the flip-flops are not connected by the common clock. Okay. Whereas the external clock, जो external clock है, that is basically applied to the LSB. That is basically applied to the LSB flip-flop. That is basically applied to the LSB flip-flop. Applied to the LSB flip-flop. Applied to the LSB flip-flop. Okay. The external clock is applied to the LSB flip-flop. Applied to the LSB flip-flop. Clear? Okay. Then every flip-flop output will serve as a source of clock for the other flip-flops. Have a look into it. Have a look into it. This one is LSB. And this is where you apply the clock. Okay. But then the output of every flip-flop will be serving as the clock. Okay. I have assumed the initial to be negative edge triggered. So I am assuming all the flip-flops to be negative edge triggered. Okay. This will be serving as a clock for the next flip-flop. Okay, the Q1 output will be serving as the clock for the next flip-flop. Okay, also remember in the ripple counter, okay, 2 important points to be noted is external clock is applied to the LSB flip-flop, and next point to be noted is all the flip-flops are in toggle mode. All the flip-flops are in toggle mode. All the flip-flops are in toggle mode. ठीक है, अब टॉगल मोड का मतलब क्या होगा? सपोज आई एम यूजिंग जेके फ्लिप फ्लॉप्स हियर. Okay, suppose I am completing the design using JK, or you can design using T also, that does not matter. Okay, toggle mode. What is the toggle mode of JK flip-flop? Both inputs JK 1 1. Okay, so both the inputs JK 1 1 for all the flip-flops. All flip-flops must be in toggle mode. So dear, here inputs will always be fixed. Here the input will always be fixed. Here the input will always be fixed. Okay? Here the input will always be fixed. Okay? But now how does the transition occur? Once let me explain it to you. Okay, so what will happen? Q2, Q1, Q0. Initially by default they will start with 0 0 0. Na? Initially the device is power on. The device is in the reset state. Okay, so it is 0 0 0. Okay, 0 0 0. Okay. Na, ab break kiya to momentum will be spoiled. Okay. Momentum will be spoiled. Okay, so let us continue. Let us continue without any break as of now till the time we can continue. Okay. If you say counters are not to be discussed, I can stop here. That is your choice. If you say कि नहीं बाबा counters not to be discussed, okay, we know about counters, I can stop here. तो देखो, now after some time external clock will come after every fixed amount of time ना. Okay, after every fixed amount of time external clock will come. ठीक है, पूनम डाउट पूछ लीजिए, हिंदी में बोल देंगे, but this has been planned as a English session. अब देखो, what will happen? जैसे ही external clock आएगा, external clock is applied where? LSB, and we know what is the clock. It is a periodic waveform. Okay, after every particular time there will be negative edges. It's a negative edge triggered, na? After every some time, okay, that particular time is known as the time period of the clock. After every particular time, the negative edge will keep coming here. So this will always toggle. Why it will toggle? Input 1 1. See, there are two things. Apply the input and wait for the door to open. Apply the input and wait the door for to open. By input मैंने 1 1 fix apply कर दिया है, and now I want door to be open. Since it is a flip-flop edge trigger device, the door will open at the negative edge here. Okay, so as soon as the negative edge will come, the flip-flop will toggle because the inputs are 1 1. So initially, dear, it is in the state 0. Okay, now it is going to in the state 1. Now it is going to make the transition to the state 1. Okay. Now, the clock is not applied to the other flip-flop. Okay, the other flip-flop will be working based on the output of the previous flip-flop. So Q0 output is going to the clock. Q0 output is going to the clock of the next one. At the next one. Ab dekhiye, what type of transition is this? What type of transition occurred on the Q0? On the Q0, it is a 0 to 1, that is positive edge. Okay, 0 to 1 is known as positive edge. So what has occurred here? 0 to 1. Will this flip-flop work? This is a negative edge triggered flip-flop. It will only work on the negative edge. It will only work on the negative edge. It will only work on the negative edge. Okay. So this will not work. Not work means inactive. Inactive means previous state. Okay. Similarly, now you will look into the transition at Q1 to decide the next state of Q2. Okay, but Q1 pe what type of transition? This is not at all a transition. Okay, if this is no transition, Q2 remains in the same state. Q2 remains in the same state. Now again, after some time, negative edge will come. External clock negative edge will come to the LSB, and LSB will keep toggling after some time. Now this becomes 0. Now because it becomes 0, look into it. This is a negative edge transition. Okay. Now because this becomes 0, this is a negative edge, and because Q0 has a negative edge, क्या होगा? Q0 पे you have obtained a negative edge, 1 to 0 transition. So Q0 has a negative edge, so this flip-flop will be active, na? Next flip-flop will now be active. Next flip-flop will now be active. तो चलो, next flip-flop will now be active. 0 becomes 1. Active means toggle, na? Input तो fix है. Okay. Okay. So 0 becomes 1. Okay, now what type of transition is this? Positive edge. Positive edge पे next work नहीं करेगा. So next will be 0. Again after some time LSB will toggle 0 to 1 positive edge. So next will not change. Only negative edge we need to search. Okay, 1 to 1 same. Okay, no transition. So no change. Now 1 to 0 again transition. What type of transition? Negative edge transition. Negative edge है तो next flip flop will toggle. Next flip flop also 1 to 0. This is also negative edge. And whenever any flip-flop has negative edge transition, next flip-flop will toggle. यही करना है ना? यही करना है. So next flip-flop will toggle 0 to 1. Again after some time LSB will toggle 0 to 1 positive edge. So no change. 0 to 0 no transition. तो next में no change. Now again after some time LSB will toggle. इसको यहाँ से continue करते हैं dear. 1 0 1 तक आ गए हैं. After some time LSB will toggle. Okay, 1 to 0. 1 to 0 is again a negative edge. Negative edge means next one will toggle. 0 to 1. 0 to 1 is a positive edge. So next में no change. Okay. Now again LSB will toggle 0 to 1 positive edge. No change in the next. 1 to 1 no transition. So no change in the next. After 1 1 1 again LSB will toggle. LSB toggle हुआ. So this is again negative edge. So next will toggle. Okay. Next 1 to 0. This is also a negative edge. Okay. So next will toggle. Okay. Next will toggle means 1 to 0. So you come to 0 0 0. That means you have come back to the initial state and all the states are counted. It is a regular up counter. So I can say that this design is a 3-bit ripple up counter, and see no external gates are used. Only 3 flip-flops. Only 3 flip-flops. If you tell me what is the circuit diagram for a 4-bit ripple up counter? What is the circuit diagram for a 4-bit ripple up counter? Just one more flip-flop. Okay. Just one more flip-flop here. Okay. This is the J and K input. They will be 1, 1. This output Q will go to the clock. Okay, and this is going to be the Q3. Complete. Just one extra flip-flop. With every 1 bit extra flip-flop, but no extra gates will be required here. That is how I already concluded. That is how I already concluded that for a ripple counter, there will be only n flip-flops if it is an n-bit design. But speed, the propagation delay here will be how much? 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 So, dekho, suppose this takes a time of 10 nanosecond. This also takes a time of 10 nanosecond. This also takes a time of 10 nanoseconds, assuming all uniformity. Okay, assuming all to be uniform delay. Have a look into it, dear. Have a look into it. First, the clock. Okay, suppose this clocks come here. Okay, LSB will be active, and this takes a time of 10 nanosecond, and only after LSB transition is complete, then only the next can be active, na? Then only next can be active. So next is active after 10 nanoseconds. It will take 10 more nanoseconds time. Okay, so it will produce the output at 20. Okay, then only next is active. So this is active at 20. Okay, this again takes a time of 10 nanosecond. I can total 30. Total delay is 30. Total delay is 30. The device to transition, worst case delay is 30 nanoseconds, and that is why I say the next edge of the clock should come greater than 30 nanosecond, because for one transition itself, worst case time needed is 30. Okay, so let the counter complete one transition, na baba, then only you supply the next clock. Otherwise, overlapping will occur. Okay, so next clock edge should come only after 30 nanoseconds. Only after 30 nanoseconds. Okay. Okay, so that is what I'll write down here, that the delay here 30 means 3 times 10. In general, n times the delay of a flip-flop. If it is an n-bit design, in general it is n times the delay of a flip-flop, and that is what I'm telling you. Okay, the time period of the clock should be greater than NTFF. That means the minimum value of the time period of the clock is NTFF, and okay, the clock frequency, the maximum clock frequency at which the circuit can operate, clock frequency is 1 upon time period, and that is 1 upon TFF. That is 1 upon TFF. Okay, so the point here is the clock frequency is overall divided by n. Here it is 1 TFF, here there is n in the denominator. That makes ripple counter as slow, because it is again based on the ripple action, like ripple adder based on the ripple action of carry. Here it is based on the ripple action of the clock. Okay, it is a slow adder again. It is a slow counter. Okay, this one is faster. Synchronous is faster, but it takes more hardware. Okay, more hardware means costly. Okay, this takes more hardware. Costly. This takes less hardware. Okay, कम पैसा दो कम speed मिलेगी, ज़्यादा पैसा दो ज़्यादा speed मिलेगी. Simple law of the world. It is a very simple law of the world applicable to any device. To obtain better efficiencies, to obtain better speed, you need to pay more. Simple, huh? Everywhere in the world it is applicable. Okay, and obtain, if you have less money, you'll have lesser speeds. That is one fundamental difference between synchronous and ripple. Okay, between the synchronous and ripple. Clear, everybody? Okay. Now, next important thing to note with respect to ripple counter. Dekho, not every time you will be solving this truth table ki when there is a negative edge, when there will be the toggle occurring, when there is not the toggle occurring. I'll tell you the direct result. They'll tell you the direct result. And what is the direct result? See, look into the clock connection. How is the clock connection? The Q output goes to the negative edge of the clock. Negative edge triggered device. The connection can also be taken by Q bar. The connection can also be taken by Q bar. And the flip-flop also may be negative edge triggered, or it may be even positive edge triggered. It may be even positive edge triggered. Okay? Acha, if that is the case, na? Okay, if that is the case, now have a look into it. If that is the case, na? What is the design that I have discussed? I have discussed the design where the connection is from Q to negative edge. Where the connection is taken from Q to the negative edge. Whenever there is the connection from Q to negative edge, it will be an up counter as we have proved. You need to remember only one of them. केवल एक याद रख लीजिए dear. Rest automatically. Now how automatically? How automatically? You will only remember one. Q to negative edge. केवल एक याद रखना है आपको. Q to negative edge. Okay, very important point actually. Okay, so if it is Q to positive edge, dear, negative की जगह positive edge होगा. If any one parameter change, the pattern will change up to down or vice versa. The pattern will change up to down. ठीक है? Next. Okay. Next. Okay. Suppose if it is negative edge only. Suppose I am designing negative edge only, but rather than Q, I take the connection from Q bar. Rather than Q, I take the connection from Q bar. Okay. Then also up becomes down. ठीक है? और अगर दोनों ही चेंज कर दिया, Q की जगह Q bar, negative की जगह positive edge. Okay. If both are changing. Okay. If anyone changes down, if both are changing, तो up to down, down to up. If both are changing, up से down, but both are changing, तो back to up. It will be up only. Okay, so what you have to do, just remember one thing in the find. ये one thing in the mind feed कर दो, Q to negative edge. If any one of them change, any one means Q becomes Q bar and negative become positive. If any one change, it is a down counter. If both change, it is up. केवल एक याद रखना है, Q to negative edge. केवल एक याद रखना है, Q to negative edge. Okay, now let me go to a question here. Okay, so that is why, the questions that are important on the ripple counter, they are mostly of what nature? They are mostly of the nature where reset and preset pin will be there. Okay, the circuit shown consists of JK flip-flop, each with the active low asynchronous reset input. Okay, asynchronous reset input. See, RD bar, as I told you, bar means active low pins. This is active low pins. It will be active, okay, when you supply low. Now, what is the role of this reset pin? And it is clearly mentioned asynchronous reset pin. It simply means that it will reset the flip-flop. Okay, the flip-flop will reset. That means the next state of the flip-flop will be 0. Okay. Immediately, the flip-flop will reset. Okay. If you send RD equal, chalo, RD की जगह क्या है? Let us say this is X. So flip-flop will reset if X, let's say this variable is X. If X is how much? 0. It will be active if it is low. So if it is low, if X is 0, it will active. Active means its role is to reset the flip-flop. So the flip-flop will reset if X equal to 0 and the reset will occur immediately. Okay, without waiting. Asynchronous का मतलब समझ लीजिए. Without waiting. Clock edge. Asynchronous means it is not synchronized with the clock. It will work independent of the clock, and as soon as X is 0, okay, it's going to reset the flip-flop. It will not wait for the clock edge to come. Clear, everybody? It will not going to wait for the clock edge to come. It is not going to wait for the clock edge to come. Okay, now this counter is modulo 5. Now what is modulus? Okay, what is this modulo or modulus? Modulo, also known as modulus. Okay, that means number of distinct states of the device. It is also known as mod number. Sometimes it is also known as the mod number. So this is, what is the mod number of this counter? Dekho, let us study here. First of all, the first thing to notice is whether it is ripple or synchronous. Whether it is the ripple or synchronous counter, tell me. ये ripple है या synchronous है? Tell me. Dear, okay, the clock is only applied to LSB, na? Okay, Q0. Okay. Rest, the output of every flip-flop going to the next flip-flop, so it is ripple. Okay, it is a ripple design. Definitely it's a ripple design. And in the ripple, how to identify up or down? Look into Q to negative edge. Connection साफ दिख रहा है. Q to negative edge. Q to negative edge is up counter. Q to negative edge is up counter. So it is basically up counter case. It is basically a up counter case. Clear? It is basically a up counter case. ठीक है? तो इसको up ले लेंगे हम. Okay. ठीक है? So if it is a up counter, let me start making it stable. Q2, Q1, Q0. Starting from 0, 0, 0. 0, 0, 1. Okay, 0, 1, 0. But now, what is X here? There is a reset input here, X. That is the output of this NAND gate. Okay, that is the output of the NAND gate. And the input to the NAND gate is Q2 and Q0. This is Q0, okay? So let me write down this X also here. Okay, that is Q2, Q0 ka NAND. So Q2, Q0 whole bar. Okay, Q2, Q0 ka whole bar. And output of NAND gate is high. Output of the NAND gate is high. अच्छा हमें क्या चाहिए? हमें तो 0 चाहिए ना. अच्छा तो X NAND gate है ना. X equal to 0 if output of the NAND gate is 0 if both inputs are 1 1. If both Q2 and Q0 are high. Okay. If both are high, then only the output of NAND gate is 0. ठीक है? शॉर्टकट ही तो चल रहा है रोहित. ठीक है. 0 1 0. Next is देखो 0 1 1. अच्छा, if both are high Q2 and Q0, then only X will be equal to 0. Otherwise X is 1. Okay. 1 0 0. X is 1. Now please see 1 0 1. Now please see 1 0 1. What happens at 1 0 1? Okay. Q2 and Q0. Q2 and Q0 are both high. If they are both high, what will happen? X will become 0. Okay. X will become 0. Now what happens at X equal to 0? Okay, this X actually goes to all the flip-flops. You have to see where it goes. It goes to all the flip-flops. Okay, so at X equal to 0, all the flip-flops will reset immediately. Immediately. Okay, so what is the next state? The next state is the state 0 0 0. Okay, so now what is my count sequence? What is my count sequence? Sometimes they can ask you the count sequence. Sometimes they will ask you the mod number. So what is my count sequence? Tell me. What is my count sequence? Tell me. My count sequence starts from 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0. Now, after 1 0 0, point is, should I count 1 0 1? Should I count 1 0 1? That is the catch in the question. Should I count 1 0 1? Dekho, 1 0 1, as soon as 1 0 1 comes, X becomes 0. And as soon as X becomes 0, all flip-flops reset immediately. So that means in a very short amount of time, okay, this state will be lost away and this state becomes 0 0 0, and this is an uncountable state. What is a countable state? What is a valid state? A state is valid, a state is countable if it remains active for 1 clock cycle. If it remains active for 1 clock cycle. If it remains active for 1 clock cycle. So after 1 0 0, okay, maybe you think 1 0 1. Maybe you think 1 0 1. No, it is not 1 0 1. It is 0 0 0. Okay. Okay, so this is not to be counted. This is not to be counted, and hence what is the perfect mod number? 1 2 3 4 5. It is a mod 5 up counter. Up है ये तो पहले ही बता दिया था. It is a modulo 5 up counter. It is a modulo 5 up counter, dear. It is known as a modulo 5 binary up counter. Correct answer is A. Correct answer is A. Correct answer is A. It is a modulo 5 up counter. Now one more question related to it. Okay. Suppose for the previous question, if clock frequency is 100 megahertz, if I give you a clock frequency where it is, okay, this clock frequency, okay, suppose the frequency is given to you as 100 megahertz. What is the frequency obtained here? What is the frequency obtained at the MSB? So what is the frequency division concept in counters? The frequency obtained at MSB. Okay. Q2 bole to MSB. The frequency at MSB is basically given by the clock frequency divided by n, where n is the mod number. Where n is known as the mod number of the counter. Okay. तो यहाँ पे आंसर कितना हो गया? The frequency at Q2 is equal to clock frequency, which is 100 megahertz. That will be divided by 5. Okay, that will be divided by 5. Okay, the Vikram answer will be 20, not 25. It is divided by mod number. Mod number was 5 and your answer will be 20 megahertz. Clear, everybody? Your answer is going to be 20 megahertz divided by the mod number. Divided by the mod number. Divided by what? Divided by the mod number. Clear? Chalo. ठीक है. So this is one homework for you, dear. Okay, one homework related question. Okay, what is the frequency at Q3? And Q3 is once again the MSB. You look into it, na? The clock is applied to LSB. And it is a ripple counter. Basically, you clearly have a ripple counter again. Okay. Because output of every flip-flop goes to the next. And what type of connection? Q is a negative edge. So it is ripple up. It is ripple up. Because the connection is Q to negative edge. The connection is Q to negative edge. It is ripple up. Only thing is, again, there is a reset pin coming up. It is a reset pin coming up. Okay. It is a reset pin coming up. Okay, so when is the circuit going to be reset? That count, you have to start with up counter 0, 0, 0, 0, 0, 0, 0, 1, etc. And you have to see when is this X, okay, which is applied to all the flip-flops. Okay, you have to again see when the X becomes 0 because it is active low. Okay, because it is active low. One more thing I told you. Okay, whether it is bubble or bar, even both are there. Na, it is active low only. Cancel nahi karne ka hota hai usko. This is just symbol. You don't cancel it. Even if they show both bubble and bar, it is active low only. Please remember, it is active low only. This is active low only. This is active low only. Clear? So, rest you complete. It's a homework for you. Chalo. Yeah, I'll jump to the Ring and Johnson counter also. Okay. Nothing, same activity, Tithi Saha. Only thing is the flip-flops will be reset when you get the high on the X. So you have to wait when X equal to 1. Okay. Chalo. So one question directly on the shift register. Following shift register is initially loaded with the bit pattern 1010. After how many clock cycles will the content of the shift register be 1010 again? After how many clock cycles will the content of the shift register be 1010 again? So see, this is the serial input to the shift register. Okay, it takes one serial input and all the outputs are read parallelly. This is what is SIPO. क्या बोलते हैं इसे? Okay, you have only one serial input. Okay, see, input is only one bit serially at a time. Serial in, but all the outputs are parallelly available to be read. The parallel out, because there are 4 configurations. Okay, serial input, serial output, serial input, parallel output, parallel input, only single serial output, and parallel input, parallel output. These are the 4 architectures of the shift register. Okay, this one is SIPO. Okay, question is basically simple only. Such questions, if they come, they are simple. ठीक है, इसी के साथ Ring and Johnson counter पे भी आ जाएंगे हम लोग quickly. Okay, so let us say this is the bit Q3, Q2, Q1, and Q0. Okay, initially it is loaded with 1010. Okay, now it is the XOR of Q1, Q0, further XOR with Q2. Okay, so let us say this is the serial input SI, and that is nothing but Q2 XOR with Q1 XOR Q0, and we know that XOR is even associative. XOR भी associative होता है. अच्छा, NAND and NOR मैंने आंसर दिया था कि नहीं? NAND and NOR are not associative. I think I forgot to give you the answer at that time. NAND and NOR, I asked you a question. Remember, NAND and NOR are not associative. Okay, I hope I'm not going back to that topic. If I answered that time, well and good. I don't know whether I answered you or not, but I'm telling you they are not associative. ठीक है, कोई doubt है तो मेरे को बाद में बोलना, ठीक है? But they are not associative. Okay. So rather than taking 2 XOR and then XOR with Q2, better you take it as a single step XOR Q2, Q1, Q0. And how do you solve 3 input XOR, you know? How do you solve 3 input XOR? How do you solve 3 input XOR? Odd number of ones pe na? Odd number of ones pe. So let us take this. Okay, let us take this table for Q3. These are also very common and important questions based on shift register. Okay, and then serial input, which is the XOR of किस का XOR है, एक बार फिर से लिख लेंगे 2 1 and 0 Q2 Q1 Q0 Q2 Q1 Q0 Q2 Q1 Q0. Okay, starts with 0 0 0 0. Let us start with 0 0 0 0. Sorry, given and a starting state given. If not given, I will start with 0 0 0 0. My starting pattern is 1 0 1 0. Okay, and at 1 0 1 0, see how many ones? Odd number of ones. Acha, what is the serial now? How does the shift register work? Okay, it's a right shift register where every bit will be transferred to the right. Okay, 1 bit at a time. This is 0. This one goes here, and whatever is the serial input, na, whatever is the serial input. Okay, like serial input is 1. I'll copy it here. That also goes to the MSP. Okay, that also goes to the MSP. What goes into the MSP? It is a serial input. Rest 1 bit right shift at a time. 1 bit right shift at a time. Okay, now look into these 3 bits. 1 0 1. How many number of ones? 2. Even number of ones. So serial input 0. यहाँ पे भी लिख देते. Okay, now just right shift this and right shift the first 3 bits. 1 1 0. Now 1 1 0. 2 ones. 2 ones. Even number. देखो तो यहाँ किया 0 copy. This 0 slides here. Then you have 0 1 1. Again 2 ones. So serial input will be 0. ये 0 किया यहाँ पे copy. This goes to the MSB. 0 0 1. Okay, Q2 Q1 Q0 has odd number of ones now. Serial input will be 1. Okay, ये 1 को किया transfer, then 0 0 0. How many ones? Even number of ones now. The serial input is now 0 0. Okay, now this 0 slides here and 1 0 0. Now you have odd number of ones again. So this is 1. ये 1 यहाँ copy किया. This 1 comes here. Now 0 1 0. Okay, this 0 1 0 appears here, and now you have the initial state. Okay, now you have the initial state again coming up. Okay, you come back to the state 1 0 1 0. After how many clock cycles? Okay, after how many clock cycles it actually happens? This is the initial. Okay, now after 1 clock cycle, 2 3 4 5 6 7, right? 1 2 3 4th 5th stage 6th, and after 7 clock cycles you get the repetition. Okay, 7. Okay. Yes, Abid Bashir, what is the confusion? Please tell me. So it appears after 7. It appears after 7. Option number C. Correct. Nishu, Vikram, Manaswi, correct answer. It's 7. Okay. Just keep on tallying the calculations also. It's going to be 7. Okay. Now with this shift register, correct Tithi, with this shift register, okay, when I connect, okay, when I connect, odd number of ones liya hai na? Look into this. Here also you have odd number of ones. So output serial input will be 1. Okay. इसके आगे check ही नहीं करना है ना, because the state is repeated. So no need to check further a bit. Okay. Yeah. Whenever the serial output, okay, we call this final output as the serial output and serial input, considering a SISO shift register now. Just considering a SISO shift register, serial input, serial output shift register, connected in ring format. So what is this ring format? Okay, the serial output connected back to the serial input. Okay, the type of counter you get is a ring counter. The type of counter that you get is a ring counter. Now what is the count sequence? Okay, let us say I have initialized. Let us say I have initialized this ring counter, okay, by 1 0 0. Okay, by 1 0 0. Okay, so what's going to be the next state? To see what is the value of the serial input. The serial input, okay, is just equal to what is there at the Q0. Okay, so what is the serial input? Whatever is the value of Q naught. Okay, and these are the actual states, Q3, Q2, Q1, Q naught. Okay, again perform the right shift operation. Okay, this bit shifted to the right, this also shift right, this also shift right, and whatever is the serial input that will enter inside. Okay, so what is the next state here? Next state is 0, 1, 0, 0. This 0 again written here. Okay, now again 0 comes inside and 0, 1, 0 outside. Overall 0, 0, 1, 0. Similarly, next state 0, 0, 0, 1. Next, ये 1 यहाँ पे आएगा. This 1 goes to the MSB. 000 shift right to 1000. 1000 initial state. 1000 initial state. Okay. So I'm taking it little quickly, but in case if you have any doubts, मेरे को बोलते जाना. So what are the states basically? If you see the pattern, it starts with 1000. Okay. Then it goes to 0100. Okay. Then it goes to 0010. Okay. And then from 0010, last is 0001. Back to 1000. Okay. Total 4 number of states if it is a 4-bit ring counter. Okay. Acha. If I start, why I did not start with 0000? There is a disadvantage here. Okay, that this ring counter will have several lockout states including 0000. If you start with 0000, okay, serial input will also be 0, na? Okay, so what is the next state? 0 and again 000. Next state is again 0000. 0000. It will be a lockout state. Okay, there will be several lockout state. Okay, the desirable state pattern here is such that only one bit is high at a time. Okay, only one bit is high at a time. No, it's not about 1 bit difference here. The beauty of the pattern is, okay, only 1 bit high at a time. Only 1 bit high at a time. Okay. So, commonly ring counter, suppose, okay, let me take a simple example. Say, for example, look into Diwali pattern. You have 4 LEDs. Let's be simple. Okay. Suppose you have 4 LEDs. Okay. And you want to develop a pattern. Such that only one LED is on at a time. Okay. And when a particular LED is on, the other will be off. If a particular LED is on, the other will be off. Okay. If a particular LED is on, the other will be off. Okay. I can use, there can be other counters also, but ring counter can be used here. Okay. Ring counter can be used here. Only thing is, ring counter you should always initialize with 1000, and if you initialize with 1000, next it will recycle into so many states, but every state will have only 1 bit high at a time. Okay, so what is the first state? 1000. This LED is on, others are off. After some time, how much time? That depends on clock. You are the one to design the clock. So how much time gap you need between the LED? That you can design using the clock. Okay, so you can supply the clock frequency as you want. Okay, so after some time, this LED is going to glow. Next will be off. Others will be off. After some time, third will glow. After some more time, fourth will glow, and etc. Okay, etc. Only one LED will be high at a time, will be on at a time. So, ring counters are commonly used in the control sections where you need to make only one device high at a time. Others should not be operational. Only one device active at a time. Okay. But if it is n-bit ripple counter, the point here is, if it is n-bit ring counter, it will have n number of states. How many? जैसे यहाँ पे 4 states था. In general, a n-bit ring counter will have only n states. What if I double the number of states? What if I double the number of states without any extra hardware? Let's talk about switch tail ring counter. Johnson बाद में देखते हैं. पहले switch tail ring counter को समझते हैं. What is switch tail ring counter? Okay, simply the name says switch the tail of the ring counter. What was the tail of the ring counter? The connection from Q0 goes to the serial input. Switch it. Okay, switch it to take it from Q0 bar. Switch it and take it from the Q0 bar. Okay, so only one wire change, no extra hardware. केवल वायर को उठा के यहां से यहां लगा देना है. Okay, no extra hardware. Okay, so when you take this connection from the Q0 bar, feed it to the serial input. Okay, this becomes a switch tail ring counter, and look into the number of states of the switch tail ring counter now. Okay, let me start with again. Okay, Q3, Q2, Q1, Q0, Q3, Q2, Q1, Q0. Starting with 0, 0, 0, 0. Now, what is the serial input here? It is equal to Q0 ka complement. Okay, the tail has been switched to 0 complement 1. Now, after the clock, what will happen? This 1 comes inside and 0, 0, 0 right shift. This is still 0, toggle 1. 1 comes inside, 1, 0, 0. 0 toggle 1. 1 comes inside, 1, 1, 0 right shift. 0, sorry, ये 0 है, 0 का toggle still 1. Again 1 comes inside, 1, 1, 1. Okay, then 1 ka toggle 0. Okay, now 0 comes inside, then 1, 1, 1. Again 1 ka toggle 0. 0 comes inside, 0, 1, 1. 1 ka toggle 0. 0 andar aaya. 0, 0, 1 right shift. Again 1 ka toggle 0. 0 comes in and then 0, 0, 0. We go back to the initial state. So how many number of states? Ye to repetition ho gaya. Okay, you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, you have total 8 number of states. You have total 8 states here. Okay, you have the total 8 states here. Clear, everybody? You have a total of 8 states here. Okay, you have a total of 8 states here. Okay, double the number of states. Using same 4 flip-flops, we have double the number of states. Okay, but the problem now is, okay, a problem kuch aisa hai that beauty of the ring counter is lost. Beauty was only 1 bit high at a time. The beauty was 1 bit high at a time. That beauty is lost. Okay, I will redesign the beauty also. Here, not only 1 bit is high at a time, multiple bits are high. Okay, that beautiful pattern has gone. उसको भी मैं reintroduce करूंगा. ये देखेंगे. Okay, Q3, Q2, Q1, Q0. Okay, and with respect to it, I will design some control signals, okay, respectively known as S0, S1, S2, S3, S4, S5, S6, S7. Okay. Now, what are these control signals? Chalo, rather than writing their value, let me write down the control signals. Dekho. The first state is 0, 0, 0, 0. How to remember the Johnson counter pattern? Counter ka pattern? That is also very easy. Okay, I start with 0, 0, 0, 0. Then comes a 1 inside. Okay, then comes a 1 inside. Then comes another 1 inside. Then comes another 1 inside. Then comes another 1 inside. Now everything is 1. When everything is 1, start the entry of zeros. Okay, then comes a 0 inside. Then comes another 0 inside. Then comes another 0 inside. 0, 0, 0, 1. Then another 0, you will be at the starting state. Simple to remember the count pattern. Okay. Simple to remember the count pattern. 3-bit का pattern बताइए चलिए. 3-bit pattern. I start with 0, 0, 0. Very easy to remember Johnson counter pattern. Okay. Start with 0, 0, 0. Then a 1. Then another 1, double 1. Then triple 1. अच्छा सारे 1 आ गए. Now enter zeros. 0, 1, 1. Now double 0. Now 0, 0, 0. ये तो repeat हो गया. Okay, how many? Do we have 6? Yes. Okay. There will be 2 n states always. Ring counter has n states. Johnson counter will have 2 n states. Chalo. Now what are the control signals? I will be defining a control signal with respect to the first state. ध्यान देना. What is the unique identity of the first state? What is the unique identity of the first state? If you carefully note the MSB and the LSB. Note the MSB and LSB. Both of them are 0. Both of them are 0 and they are 0 only in this state. Rest all, this pattern is not followed. Rest anywhere else, this pattern is not followed. Can you trace it? So every state I am observing a unique property. Okay, that MSB and LSB are both 0, 0 and 0, 0 ke liye what is the code we write? Complement Q3 bar, Q0 bar. Okay. So that this signal will be high. This signal will be high only at the first state. Otherwise it will be low. क्योंकि ये वाला pattern 0, 0 is not seen anywhere else. Clear na? Next S1, S1. Now what is the unique property of the next state? Look into this. First two bits 1 0. Trace. Nowhere else. Nowhere else. Okay, nowhere else. Okay, so 1 0 means Q3 Q2 bar. First two bits. Similarly, ये आ जाएगा next pattern का highlight. Center to 1 0. Nowhere else. Nowhere else. Q2 and Q1 bar. I will keep highlighting this. Let me not erase it. Next will be this 1 0. Okay, the next signal will be Q1 Q0 bar. Next, MSB LSB 1 1. 1 1 means Q3 Q0. Next, S5. What is S5? 0 1. Q3 bar Q2. Next, S6. Okay, next S6. Center 0 1. Okay, Q2 bar Q1. And next, finally S7. Last two 0 1. Okay, Q2 bar Q1. That is Q1 bar Q0. Q1 bar Q0. This is the beauty. Okay. Whatever signals I have written, they will be only high corresponding to the given count. Otherwise, they will not be high. Okay. So these are the 8 control signals which will be only high one at a time. And like the previous example, 4 LED, not only 4, here you can control 8 LEDs. Using the 4-bit Johnson counter, you can control the 8 LEDs. Okay. You can control the 8 LEDs. Okay. So now, what is Johnson counter? Okay. Many people say and think that this is the Johnson counter. This is a part of Johnson counter. This is switch tail ring counter, which is a part of Johnson counter. When you design this control signal also, okay, along with this control signal, the complete design is the Johnson counter. Okay, so what is a Johnson counter? It is an n-bit switch tail ring counter with 2n decoding gates. How many gates will be needed? What is this? These are 8 AND gates needed to design this. And all the AND gates are of 2 input. Okay, so you need how many AND gates? 2n AND gates, because there are 2n states, okay, to provide the output for 2n timing signals. That is what Johnson counter is. Okay, total 2n states. Total 2n states. Okay, just a second. Time to tell you something important as well. Okay, chalo. So yes guys, 7 hours of class done and I have another classes to be planned. So unfortunately, we'll have to stop here because I have evening schedules planned up. Okay, so the most important thing I know you must be eyeing right now is ADC and DAC. Okay, so I'm not much worried about that. Important, बहुत important है ADC DAC. But very recently, if you followed the Special 26 series last month, okay, I took a video on ADC DAC. It is approximately a 2 hours video complete on ADC and DAC. Link मैंने share किया है. So if it is not covered, no problem. Just 1 month before I covered it, now you can watch that video. You can just watch that video. Number system and all is easy, okay? I'm telling you, last month we have to be selective. Okay, so we have covered up important parameters like K-map, Boolean algebra, NAND and NOR gates, essential prime implicants, multiplexers, decoders, full adders, ripple adders, and very important flip-flop counter, state diagram based question. Okay, and Johnson counter, ring counter, etc. Okay, if you want to cover ADC and DAC, it's a complete 2-hour video only on ADC and DAC. Go through it, save it up. आराम से देख लेना, maybe tonight or whenever you find time. Okay, आराम से देख लेना. Okay, nothing to be worried about. Look into it. Okay, it's a 2-hour complete video of ADC and DAC, almost 2 hours. Comfortable. आप अच्छे से पढ़ लोगे उसमें. आप उसमें अच्छे से पढ़ लोगे, ठीक है? And recently only I've taken just 1 month back. In the Special 26 series. Yes, PDF, I'll try to send it by today only. Anyhow, for marathon at least I'll find time. Okay, not immediately because I'm telling you I have another schedule. I'm also already exhausted, but I have to take up another schedule, but I will manage that. Okay, chalo. Okay, so guys, I know there are some topics left, but honestly, in the 7 hours, whatever best I could do, I have done. Okay, whatever best I could do, I have done. Okay. So some indirect portions of FSM's Bhanu covered here. Otherwise, in the special 26, you have the complete FSM video also if you want. Okay, quiz ke link ki baat karte. Now, very important thing is, yeah. So guys, now tomorrow, first of all, tomorrow, analog circuits. Okay, same time, 10 a.m. Stay tuned. Same time, 10 a.m. Stay tuned for analog circuits. I'll share you the analog circuits link also. Okay, but as I told you, daily quiz. Now what you can do is, you can attempt the quiz. Or if you want to take a deep breath, attempt it after 1 hour or so. Okay, but I told you 3 things. I'll repeat. Okay. I told you 3 things and I'll repeat that 3 things. I'll repeat those 3 things. Okay. Number 1, daily class. Number 2, daily quiz. And number 3, PYQs. Even if you follow this, your revision is perfect, your revision is complete. PDF is password protected. Password has already been told. Password has already been told. Password has already been told. Okay. Okay. So this is the link of the quiz. You can scan the QR code. I'll share you the link also once again. I'll share you the link also, but yeah. So if you want to go to the quiz, this is the link of the quiz. You can attempt the quiz now. Okay? Or you can scan this code and directly land to the quiz page. Directly you can land to the quiz page. One more important thing I should be now telling you is, just wait on. Tomorrow analog circuits link is shared with the analog circuits also. Okay guys, tomorrow analog circuits, the link is shared with analog circuits. So I have shared the YouTube link to join the analog circuits complete by Sanjay Rathi sir. I am coming back again guys, control system. Don't forget, Wednesday control system 10 a.m. I am again coming live on Wednesday. Okay, with the control system. Okay, complete. Okay, revision session like this. Yeah, at least. Okay, I've gone up to 7 hours and I'm again repeating guys, whatever best I could have done in 7 hours, I've done it. Going beyond it, not practically possible because of the other schedules to be taken. ADC DAC के लिए link मैंने share कर दिया है आपको. Please go to the link and watch ADC and DAC complete. ADC and DAC complete revision is there. Okay guys, so PDF I'll share you by night. Password has been already told. Bye bye. Thank you. Good night तो नहीं बोलूँगा, but yeah, good evening. Keep preparing hard. Okay. Yeah, here I'll be taking controls and signals and EMFT also in the next week. This week I'm taking with digital and control. And this weekend aptitude marathon is also there. Bye bye. Stay safe. Take care of yourself.